Hello guys, welcome to the channel. Today we will discuss machine learning. Basically, what is machine learning? Okay, so machine learning is a branch of artificial intelligence where computers learns patterns from the data and make decisions or predictions without being explicitly programmed for every task. So, see, in simple definition, instead of writing every rule manually, we give data to the computer and the computer learns from the data. Okay, what it means? Suppose you are basically working on any object or creating something. You will write the code manually. Okay, right? But that is not the case of machine learning. You will give the data to your computer. You will create the model. Computer will learn from the data and then it will make predictions on new data. Suppose I have basically trained the model in a data set. Suppose I have total experience of 2.5 years and I have the salary of 25,000. Someone has the experience of 5 years and he has a salary of 50,000. And then let's suppose you will give a data to your model for predicting. Suppose someone is working from 10 years. So what should be the salary of that person? So it will predict for on that new data. Okay, that is what machine learning. Okay, now let's understand what is basic workflow of machine learning. Okay, first step one, collect data. We gather data from different sources. For example, you are working on a house price data set. You collected this data set. Area is this. There are total two bedrooms, three bedrooms, and their prices are 50 lakhs and 75 lakhs. Okay, this is what you collected. Okay, now let's move to the second step. You will clean the data. You will not have only two rows in your data. It will have you will have millions of records. You can have millions of records in your data set. Then it may have some missing values, some duplicates values, wrong data. Then you need to clean this data before building the model. Now you clean the model. Now go to step three. Step three will be your training the model. You will give the data to the ML algorithm. There are many algorithms of ML. Okay, you have given data to a ML algorithm. The model learns patterns from the data you provided to that ML algorithm. For example, bigger houses usually cost more. More bedrooms increases prices. These are patterns learned by the model. Okay, by the data you have given for training. Now, let's move to the step four. You have built the model. Now, step four, we check how well the model performs on unseen data. Means suppose you have given this data set, okay, for training the model. Now, you will check your model by giving a new data on which you have not trained the model. Okay, then you will check, okay, how your model is performing on unseen data. Step 5, prediction. The trained model predicts output for new data. For example, predict price of a new house. Okay, on which you have not built the model, you have not given the data for training. Okay, so that is what machine learning is. Okay, so let's see some real world examples where machine learning is used. YouTube recommending videos. These are some examples which you see in your daily life. Okay, YouTube recommending videos, Netflix suggesting movies, Instagram, Facebook feed recommendations, spam email detection, face unlock in phones, Google Maps traffic prediction, Amazon product recommendation. These all examples you see in your daily life, right? So this is because of machine learning. Okay, so that is what machine learning is. From the next video, we will discuss every machine learning topic in both practically and theoretically. Okay, in both ways, we will discuss machine learning, all topics. Okay, so that is what machine learning is. So that's all in this video. Thank you. Hey everyone, welcome to the channel. In this video, we are starting our machine learning basic series, and today's topic is handling missing values. So, now in real world data sets, missing data is extremely common. Okay, if you don't handle it properly, your model can give wrong predictions or even make crash. Okay, and so in this video, I will show you what missing values are, why they matter, and different ways to handle them using Python. Okay, so what are missing values? Missing values are data points that are not recorded or available in a data set. Suppose I am showing you a data set. So this is my data set. Okay, so as you can see, this is our missing data. It is missing. These are our missing data. So we need to fix it. So why we need to fix it? Suppose if we don't handle missing values, machine learning model may crash. Accuracy of model will be decreased. Analysis will become misleading. That's what it is written. Prevent model errors, improve accuracy, ensure reliable analysis. Okay. So we will do this using Python. Why we are doing this using Python? Because suppose if you have 50,000 to 1 lakh rows in your data set, so it will become very difficult to handle this using Excel only. Okay, so we will use Python. We will see what are the different ways to handle missing values. Okay, so I will show you the different ways of handling missing values using Python. So for coding purpose, we will use Jupyter Lab. For Jupyter Lab, you just need to download this Anaconda Navigator in your system. In my system, it is already downloaded, so I'm not downloading it. So when you will download it, then simply when you will search here Anaconda prompt, okay, Anaconda prompt. So and then you will write CD and you will just give your file location. I'm giving the file location cd control V enter write Jupyter Lab then again press enter. It will automatically navigate to your browser and it will open Jupyter Lab. Okay, so it is opening. Uh, so you can see it is open in my browser. Okay, I will choose this and suppose I am renaming it. Suppose first and missing value. Okay, okay, enter. First, I will import some required libraries. Import numpy as np. Enter import pandas as pd. Shift plus enter. Okay. Now I will load the dataset. So how we can load the dataset? We can load the dataset using pandas libraries. Okay. Suppose I am taking a variable data is equal to in this variable I am loading the data set. Data is equal to pd dot read slash csv and I will simply give the path copy path. I will put the path. Okay. So for checking my data is loaded or not, we will check first three columns. Okay. Sorry, first three rows. Data dot head three. It will give the first three rows. Head gives the first five rows, so I'm taking three rows on. Okay, shift plus enter. See, my data is loaded, and here are these three columns. So this you can see nan. These are some missing values. We need to fix this. Okay, so what are the we will see what are the different ways to handle this. First, we will check the shape of the data. Data dot shape. Okay, so we can see here I am I have written CSV because this file type is CSV. if you have Excel, then you can write here Excel and you can give the path. Okay. So we can see by data.shape there are 16,598 rows and 11 columns I have. Okay. So I'm checking how many null values, how many missing values are there. So how we can check that data is null dot sum. Okay. So you can see in year column there are 271 missing values. There are two values are missing in genre, publics are 72. You can see that. So we need to fix this. Okay. So how we can fix that? In notes, there are many ways. We can drop the columns. We can use mean median mode, forward fill, backward fill. We will see that. Okay, practically. So, so our first method. Suppose I don't need this column. Okay. Suppose I don't need this column and it has some missing values. So we can simply drop this column. Okay. How we can drop the column? Data dot drop columns is equal to square braces and give the column name. Okay. Control C and Control V. Okay. And we will write in place is equal to true. In place is equal to true means we are updating the data permanently. Okay. See, I have done this. Okay. Now we will check data dot save. Okay. Data dot save. Shift plus enter. Sorry. Oh, sorry. It is data dot save. Now you can see there are 10 columns only. And here you can see I had 11 columns. Now I have 10 columns. It means publisher column is removed. Okay. Now another way. We can simply drop those columns and simply drop this. So how we can drop it? Data dot drop na. Okay. Data dot drop na. You can write in place is equal to true for updating permanently. Okay. I'm not writing it because I have to show you the different ways also. So I'm not writing in place is equal to true. It will like remove permanently the missing values rows. Okay. See, so it has dropped the missing values, missing rows which had missing values in any column. Okay. Now another. Suppose if we see data is null dot sum. Okay. Okay. When if we write in place is equal to true. Okay, it means it will update the data permanently. Suppose I'm writing it. Now you will see. See, there is no missing values in any column. Okay, we have dropped that. Now another way. Suppose I want to write unknown or zero in place of missing values. Okay, so how we can do that? Data dot fill na fill na write unknown. Okay, shift plus enter. It will replace missing values nan or anything with unknown. Okay, so this is also one way of handling missing values. Suppose now I want to fill by forward fill. What is forward fill? Suppose this is my missing value. Suppose this is my null value. Okay, so I need to fix this. So what forward will do is this missing value will take 33 as its previous value. Okay, so we can do data dot ffill ffill. Okay, x is equal to 1. Why we are writing x is equal to 1? X is equal to 1. What x is equal to 1 do? It will update the data horizontally. Okay, it will do the it will update the data horizontally. Okay, x is equal to 1. Data data dot backward fill. Data dot backward fill. Backward fill. What backward fill do? It will take this value, next value. Okay, this will take 30 value. If this is null value, it will take 30. Their next value. Okay, right axis is equal to 1. Okay, shift plus enter. Okay, this is also the one way. This is also the way to handle missing values. And next, suppose I want to do it for a single column. Suppose I want to do backward fill for general column. So we can do that? Data, take the column, control C, dot B fill, B fill. Okay, shift plus enter. It will take the next value in its missing value. Okay. Now next, we can do this by using mean, mode, median also. Suppose mean, mode, median is used for basically numerical values. So I have numerical values in year column. So we can do this by year. Okay. So we'll see. Suppose how we can do that. Data, we are taking year dot fill na in parentheses. Again, we will take data year. So from where we are updating. From year's mean value, we are filling the missing value. So we will take mean. Okay. So what we are doing here, data year, we have taken year column from data. We are filling missing values, fill NA, and from where we are filling missing values, year dot mean. Okay. From mean of the year column, we are filling the missing values of year. So shift plus enter. Okay. Same way we can do this median and mode also. We can simply write here median. Okay. Shift plus enter. And same way we can do by mode. So you all know about mean, mode, and median. So these are the different ways, okay, to handle missing values. These are the different ways to handle missing values. In the next video, we will see how we can handle duplicates value. Okay. Thank you. Hello guys. Welcome to the channel. Today we will discuss how to handle duplicate values. So what are duplicate values? Duplicate values are rows in a dataset that are exactly the same or repeated. What it means? Suppose suppose I have a dataset and these are its columns. Okay. And let's take this row. Okay. Look at the values in this row. In this row. 25 services, single, high school, no, yes, no. Okay. Look at the values in 11th number row. And now look at the row number 13. It is exactly the same values where it has. Okay. So we just need to drop these duplicate rows. Okay. Why we need to basically drop the duplicate rows? Because see, because duplicate data does not add any new information, right? Because it is already repeated. I have I have already its information. Okay. So we don't need the exactly same rows after it. Okay. It simply repeats the same record again. So we just drop the duplicate rows. Okay. So why do duplicates occur? Data entered multiple times by mistake. Somebody like entered single rows multiple times. Okay, merging data sets incorrectly. Someone is merging the data and by mistake it gets repeated. Okay, so these are the other things it is written. Okay, so how we can handle this using Python? Okay, so for coding purpose, we will use Jupyter Lab as I discussed in the previous video. Please download Anaconda Navigator for using Jupyter Lab. After downloading it, just search Anaconda prompt here. Okay, Anaconda prompt. Yes, Anaconda prompt. Write CD and just give your file location. Okay, it is my file location. Yeah, this is my file location. Control C, Control V, enter. Write Jupyter Lab. Jupyter Lab. Okay, press enter. It will navigate to your browser and open Jupyter Lab. Okay, it's loading. So as you can see, it gets open and I will choose this. And now suppose I'm renaming this. Suppose to handling duplicate values. Okay, enter. Now suppose first we will import some required libraries. Import numpy as np, import pandas as pd, ठीक? And shift enter. Now we will load the data set. I am taking a variable data is equal to td dot read slash csv. Okay. Now just right click, copy path and control V. Okay. Now we will check this data is loaded or not through data.head. It will give initial few rows. Okay. I will take 3 rows. I have written 3. Now shift enter. See, my data gets loaded and if you have Excel sheet, then you can write here Excel. Okay. And you can give the path of the of a path of your file. Okay. So, by the way, I'm giving the data set for every video which I'm using. Now, suppose suppose this data set has many duplicate values. So we just need to basically drop the duplicate values. Okay, and nothing we need to do. Okay, so how we can do that? Data dot drop duplicates. Okay, see, data dot duplicates, drop duplicates. Okay, we will write in place is equal to true. Okay, in place is equal to true, which means it will update the data permanently. Okay, shift plus enter, it will drop all the duplicate value. Okay, now my duplicate values are removed. Okay, so now I want to basically store the refined data. How we can do that? Simple. Write data dot to slash csv. And the name. Suppose I'm giving some name like refine dot csv. Or we can write cleaned dot csv. But make sure you will give index is equal to false. Unnecessarily it will provide your index like this one 0 1 2. We don't require this in my excel sheet. Okay, just write false. Okay, index is equal to false. Okay. Shift plus enter. Okay. Yeah. See. Now shift plus enter. So you can see here clean.csv is downloaded. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss replacing values and changing data types. So what is replacing data? Replace means simple, changing one value into another value in the data set. So why do we need to replace values? We replace data when values are incorrectly filled in our columns. Data is inconsistent. Suppose I want only this male. I have this M also, this male also. I want this only. So we need to fix these things and we need numeric format for models. Suppose we will when we will build machine learning models, then we will need to convert string values into numeric values. Okay. So suppose this is my data set and these are its columns. Okay. Suppose this is my gender column and I can see I have female values, M values, male values. Okay. So M represents here male. Somebody is incorrectly wrote M in place of male. Okay. So we need to fix this using Python. So how we can fix this? By Python, we I will use Jupyter Lab for this. For using Jupyter Lab, just download Anaconda Navigator. Okay. In my system, it is already downloaded. So when you will download Anaconda Navigator, just type Anaconda prompt. Open it. CD. Now give your file location. This is my file location. Control C. Control V. Enter. Jupyter Lab. Write Jupyter Lab. Press again. Press enter. It will open Jupyter Lab into my browser. It gets open. So I will choose this. I will rename this. Replace. I will suppose give name replace values. Replace values. Values. Press enter. Now right. Now we will import some required libraries. Import numpy as np. Import pandas as pd. Shift plus enter. Now we will load the data set. I'm taken a variable data pd.read slash excel. I have Excel file, so I will take Excel, right click, copy path, paste here, control V, check the data is loaded or not by head, take first three rows, data.head. Now, see my data is loaded and I got my first three rows. Okay, so we have seen we need corrections in gender column. Suppose I have small m and we don't know how many values with small m. So we need to fix this. Okay. So how we can fix this? Suppose first I just need to replace a single m value. Um, I only need corrections in m. Okay. So how we can correct one value only. Okay. So data I will take gender column, gender, dot replace which value we want to replace m, comma, from which value it should be replaced male. Okay, male. In place is equal to true, which means it will permanently update the data. So press enter. Okay, this is a spelling mistake. Replace. Okay, so it is handled. Now suppose I want to handle multiple values. Suppose I have male also, male. Okay, male also. We need to make this like capital M. So how we can handle multiple value? Suppose I am also male also. So we can how we can handle multiple value? Again, I will copy this code C, control V, dot replace. Okay, dot replace. Which values we want to replace? First M value I want to replace. Then I want to replace also s- starting from small m male. Okay, I need to replace these values. From which value we need to replace? From this value I want to replace. Male is starting from capital M. Okay, right in place is equal to true. Okay, now set place enter. Okay, it will be handled. Okay, so this is how we can handle for single value. This is how we can handle for multiple values. Okay. Now, suppose I want to change this value to a numeric value. Okay. Like when we will build machine learning model, then we will do this. So how we can replace this by numeric value? Suppose we can use male as 1, female as 0, as we have only two values. Okay, so we can do this. How we can do this? Data, take gender column equal to, again take your data gender column dot map. I will use map method. Which value I want to map? I want to map male as 1. I want to map female as 0. Okay, shift plus enter. Okay, it will be map. Okay, now we will check our data. Right data. See, this is converted as 1, 1, 1, 0, 0. Okay. 1 for male and 0 for female. See, first three rows are male. So first three rows are 1. Okay. So how this is how we can handle this. Okay. Now we will check how to convert data types. So what is data type? What is data type? Every column has a data type. See, this is our data. This is our string data type, means object data type. Also, we can say string data type. This is our integer data type. This is our float data type. And Boolean means is true false. Okay, true false. Okay. Why we need to change data types? Models require numeric data as it is already I have discussed. Wrong data type can cause errors, improve memory uses. Okay. So how we can do that? Suppose. First, I will see data.info. It will tell us the data types of different columns. Okay, see, date column has this data type, date time data type, time, store ID. This has object data type, quantity has float data type, total price has float data type. See, now suppose I want to change quantities data type as from float to integer. Okay, how we can do that? First, it has it you can see it has some null values, so we need to fix that values. Then only we can change the data type. But we will fill data, go for your quantity column, quantity dot fill any, okay, fill any with one. Suppose I want to give one for the null values. Write in place is equal to true for getting data permanently changed. Okay. This is a warning, this is not an error. Okay. So now we can change the data type of quantity column. Okay. So you can see here it has uh, you can you can see it has float 64 data type. Now we will change it to integer. How we can do that? Write data quantity quantity is equal to, again go for your data quantity column, quantity. I will choose, I will basically use as type. As type as type is used for changing the data type of any column. Okay. I will use this int. Okay. I will convert the quantity columns data type by int from float 64. Okay. Now you can see it has float 64. Now I will change this from int. Okay. Shift plus enter. Okay. So now data type is changed for the quantity column. Now I will show you data dot info. See, quantity has now int data type. Okay. So data type is changed for quantity column. So this is how we change the data type of any column and how we can handle or replace values. Okay. So in today's video, we saw how we can replace values and how we can change the data types. So that's all for the today's video. In next video, we will see encoding. Okay. Thank you. Hello guys. Our today's topic is encoding using one hot encoding. Okay. So first, what is encoding? Encoding means simple. Converting categorical, yeah, means text data into numerical form. Okay. So what is categorical data? Categorical data that represents categories or labels. Okay. See, suppose I have a gender column. I have two types of categories, male and female. I have color column. There are three types of categories I have in this column. Red, blue, green. City, Delhi, Mumbai, Pune. I have these three categories. So these are not numbers. So okay, these are categorical data. Okay. So why do we need encoding? Because whenever we will build machine learning models, machine learning always basically deal with numbers. It does not basically it does not deal with categorical data, text data. Okay. So we that's why we need to convert it into numerical form. Okay. So like we can convert male to zero, female to one, or female to zero, or male to one. Okay. So this process is called encoding. So one hot encoding. By one hot encoding, we just create separate columns for each category. Suppose I have gender column, I have male and female categories, and after encoding, it will give us basically two different columns, gender male, gender female. Okay, so uh, I have a data set. I will show you the data set. So this is my data set. Okay. If you will check in gender column, I have two categories, and in ethnicity column, I have one, two, three, four categories. Okay. Today I will do encoding using one hot encoding for these two columns. Okay. So how we can do? Okay. how we can do using Python. For Python, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. Okay, and after downloading it, search your Anaconda prompt, sorry, Anaconda prompt, write CD, give your file location, Control C, Control V, enter, write Jupyter Lab, and again press enter. Okay, it will open Jupyter Lab into my browser. I will wait for a few seconds. It is open. I will choose this. Suppose I will give some name. Suppose I am giving one hot encoding. Okay, press enter. Then I will import some required libraries. Import numpy as np, import pandas as qt, shift plus enter. Now I will load my data set. Suppose I have taken data variable for loading the data set, pd dot read slash excel, because I have excel file. I will give you the data set, copy path. Now control V. Now I will check my data is loaded or not. Data dot head 3. I will check first three rows. See, my data is loaded, and these are my three rows, first three rows. Okay. So I have to perform operations of encoding for these two columns, gender and ethnicity. What we will do, I will basically uh, I will basically take these two columns first. Okay. Suppose I have taken a new variable data2 is equal to, how we can take a data double square braces and give your column name center, take your another column that is ethnicity, control C, control V. Okay. Now see, the data2 is I've taken from data C. Now I have taken these two columns from from our data. Okay. So now I will do pd dot get dummies. Okay. Dummies for my data two. What get dummies do? It basically automatically creates new columns. Okay. Suppose I have two categories, gender, female. It will create gender slash male, gender slash female. Two columns automatically. This is what getDemis do. For ethnicity, it will create four columns because it has four categories. Okay. So see, shift plus enter. Now see, I have this gave me six new columns. Two based on gender column, and four based on ethnicity. Okay, this is what getDemis do. Okay, this is what getDemis do. Okay, now I will import one hot encoder by which we will do encoding from scikit-learn. I will I will import one hot encoder. Okay, sklearn dot pre-processing. From pre-processing module, I can get one hot encoder. Okay, one hot encoder. Okay. Shift plus enter. Okay. Now I have imported one hot encoder from scikit-learn. Okay. I will create an object to call one hot encoder. Okay. Suppose this is one hot encoder. So I will just give OHE. Okay. OH is equal to one hot encoder. Copy. Control V. I have created an object to call one hot encoder. Okay. Now I will create a variable AR is equal to for taking an array. Okay. So OXE dot fit transform. I am fitting one hot encoder to data 2. Okay. I will explain this. Fit transform for data 2. Okay. To, to array. To convert this as an array. Okay. So what we are doing here? Fit basically learns unique categories. Okay, what are unique categories? Suppose, for example, male, female, Asian, Latino. These are unique categories. It will learn. Fit. Okay. Transform. Transform means convert them into encoded value. What it means? This is in categorical form. It will convert those into numeric form. 1, 2, 0. Okay. So shift plus enter. Okay. Now I have converted this into array. Okay. Now what I will do, I will convert this into a data frame. Can be, so I can make this into a readable form. How we can do that? pt dot data, data frame, pt dot data frame for which variable AR columns. I will give all columns name here. Okay, all columns name here. What are my all columns? Control C, Control V. I will give male. Now four more columns. Control C, Control V. Three columns more. Control C. Two more columns. I'm converting this into data frame. Okay. Control V. Last column. My last column is this. Okay. Control C. Control V. Okay. So I am converting this array into data frame. So shift plus enter. Okay. This is saying I have 8. I am giving 6 columns in, but it has 8. So what we can do, I can simply give AR. I can only give my variable shift plus enter. Now see, my all columns which were gender female, male, ethnicity Asian, which has true false value after get dummies, or I had categorical values. Now it all has numeric values. Okay, it all has numeric values. I have converted this into numeric form. Okay, so this is how we convert categorical data into numeric data using one hot encoding. Okay, so this is all in this video. In next video, we will see how we can do encoding using label encoding. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss label encoding and ordinal encoding. In previous video, we saw what is encoding and how to do encoding by one hot encoding. Okay, encoding is just converting categorical data into numeric form. Okay, and we have seen how we can convert and how we can do encoding using one hot encoding. Okay, so in today's video, we will see how we can do encoding by label encoding and ordinal encoding. So first, what is label encoding? Okay, label encoding assigning a unique number to each category. Suppose I have a column color and I have three categories in that particular column: red, blue, green. So we will assign label encoder will assign a basically a number to each category. Suppose it assigned red to 0, blue to 1, green to 2. Okay, and what is ordinal encoding? Ordinal encoding means assigning numbers based on meaningful order. Basically, it assigns numbers based on a meaningful order. What it means suppose I have an education column. Okay, so I have these categories in my education column: low, medium, high. And after encoding low, it will assign low to 0, medium to 1, high to 2. Okay. So what is the difference between label encoding and ordinal encoding? Label encoding assigns number without considering order. Okay. It will basically randomly assign numbers to each category, red, blue, green, and it will assign based on order. Okay, ordinal encoding. So this is our data set. We will do encoding, label encoding for ethnicity column. I show you. See, these are my categories. We will do label encoding for this, and I will do basically ordinal encoding for this. These have also few categories, one, two, three, four. So we will do basically label encoding, ordinal encoding for this column. Okay. So how we can do that? We will do this by Python. For basically Python, basically for coding purpose, we will use Jupyter Lab. And for using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So when you will download Anaconda Navigator and you will search Anaconda prompt here, Anaconda prompt, CD, Control V, sorry, okay, I will type in CD and give your file location, give your file location, CD, Control V, write Jupyter Lab, press enter. It will open Jupyter Lab in my browser. I will wait for a few seconds. So I will choose this. I will rename this. Suppose I will give some name. Label ordinal encoding. Okay. Press enter. Okay. First we will import some library. Import numpy as np. Import pandas as pd. Okay. Shift plus enter. Now we will load our data set. Okay. See. Suppose I will take data as my variable ed dot read Excel because I have Excel file. I will write Excel. So I will give the path, right click, copy path, paste here, control V, and we will check our first three rows by data dot head 3. So my data set is loaded. We will do label encoding for ethnicity and basically ordinal encoding for business unit. Okay. So you got to know what is the difference between these two encodings. Okay. The basic purpose is simple. We will assign categorical data to numeric data. We will convert categorical data to numeric data. Okay. So how we can do that? First, we will do label encoding. Okay. So how we can do that? First, I will import label encoder from scikit-learn, sklearn dot pre-processing pre-processing import label encoder. Okay, label encoder. Okay, now set plus enter. Now we will make an object for calling label encoder. Suppose I will create le is equal to just with label encoder. Okay, enter. Now, which column we want to basically, which column we want to fit for the label encode? Which column? And ethnicity because we are converting categorical to numeric data of ethnicity using label encoder. So I will fit this column. Okay, how we can do that? Ali dot fit give here column data. It is the column name ethnicity. Control V. Okay, see it is fitted. This column is fitted to label encoder. Now I will make a new column so that we can fetch the numeric data from ethnicity column. Okay. Suppose suppose I will take a new column. Control V. I will give some name slash num. Okay. I'm converting to num. I've taken that is equal to ali dot fit transform transform. Okay. What I will transform ethnicity column, ethnic column data. Now, okay. So what we are doing here? Fit means I already discussed in my previous video. Fit means it learns the basically unique values. What is the meaning of unique values? See the data. So these are unique values. Asian, Black, Persian, Latino. These are unique values. It will learn unique value. Okay. So what is the meaning of transform? Transform basically convert the categorical data into numeric data. So this is what we are doing by this line. Okay. Now step plus enter. Now we will check our data. Step plus enter. See, I got my new column ethnicity num and it has assigned numeric data for my ethnicity column. Okay. So see here. Okay. This is how we do label encoding for converting categorical data into numeric data. Now we will see how we can convert categorical data into numeric data using ordinal encoder. Okay, so I will use the same data set. but I will do for business unit column. Okay. Now I will import first sklearn dot preprocessing preprocessing import import ordinal ordinal encoder. Okay, ordinal encoder. So plus enter. Now, okay. Suppose I will make a object for it also. Okay. Suppose I have ordinal encode, so I will just take OE as my object name. Okay. Just press tab. When you will press tab, it will show you. Now I have created an object to call my ordinal encoder. Okay. Now, first I will see what are the unique values in my business unit column. Okay. How we can see that? Data, take your column, dot unique. See, these are my unique values. Okay, these are my unique categories in my business unit column. I will do ordinal encoding for these categories. I will convert these categories into numerical data. Okay, so how we can do that? Okay, so first I will take a variable, separate variable. Okay, suppose I will take data two. Data two is equal to I will take my all basically I will copy this. Okay, I will just copy this. Okay, control C, then paste it here. We are giving it this double square basis because it expects 2D data. Okay, so I have given this. Okay, so now, okay, then also, okay, so it has some duplicate values, sorry, null values also. Okay, so it has null, okay, nan value I will just simply drop. So it has, yes, okay, I will just, plus enter. Okay, so now I will do this. Suppose OEX, I will take a variable, new variable. I will call my ordinal encoder tab, enter, null encoder. Now I will do categories. Okay, categories. Categories is equal to what is the category? I have defined my category into data two. So I will just give my data two. Okay, now yes, shift plus enter. Okay, now I have given my categories to ordinal encoder. Okay, now I will make again a new column. Suppose I will give some num, business num. Okay, now is equal to, again I will do fit transform, fit. transform, fit transform data, data, which for which column I am doing this? Business unit, business unit. Okay. So I will give this also two braces and two square braces. Okay. Now what we have done here, I will again I have done fit transform by ordinal encoder to this this column basically for this column of data. Okay, I have fitted ordinal encoder for this column. Okay, fit means it will learn the new category, unique categories. Basically, these are unique categories, and basically transform. It will convert the categorical data into numeric data. Okay, shift plus enter. Okay, so it is showing unknown categories nan. Okay, so it is showing nan. Okay, so suppose so it is considering nan also in this. Okay, nan. So what we will do? We will do. Okay, okay. First we can fill. Okay, first we will fill uh, the business unit column. Okay, first I will fill my nan values. Okay, first I will fill my nan values in this column dot fill n. I will just write unknown. Okay, unknown in place of this. Okay, okay. So it has taken unknown. Now I will do basically it will uh, sorry. I will write in place is equal to true also so that it can permanently change my data in place is equal to true. Shift plus enter. It is just a warning, it is not an error. So don't worry. So now I will give here unknown, shift plus enter, shift plus enter, shift plus enter. Okay. So now I will see my data. So now you will see here new column. See this ethnicity num. I have basically converted categorical data into numeric data from ethnicity column by label encoder, and this is my new column business num. It I have converted categorical data into numeric data of business unit using ordinal encoder. Okay, so this is how we use a label encoder and ordinal encoder for converting numerical data categorical data into numerical data. Okay, so this is how we do conversion of categorical data and categorical data into numeric data using these two encoders. Okay. So that's all in this video. In next video, we will see outlier detection. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss outlier detection and removal. So what is an outlier? An outlier is a value that is very different from the rest of the data. What it means? Suppose I have a column weights, and most of the values in weights column are lying between 50 to 80 kg. And suppose I got a value of 150 kg. So that is very far from the 50 to 80 kg. So that will be an outlier. Suppose I have a 10 kg data. So that is also very far from the mean value, or we can say the maximum range values. Okay. So why do we need to handle outliers? So outliers can distort mean and variance of the data. Okay. they can reduce model accuracy when we will build machine learning algorithms and we will have complex data which will have outliers, then we will need to fix that. Okay. Some models like linear regression are very sensitive to them. Okay. So, so basically what this diagram is saying. Okay. First, see this red box. Okay. This red box is IQR. What is IQR? IQR is basically those 50% data where maximum values are lying, like here 50 to 80 kgs. So suppose the main values are most values are coming to 50 to 80 kgs will lie here in this red box. Okay, and this yellow line is the mean. Okay, yellow line is the mean. Suppose I am getting a value here in this line between this. Okay, and here. So that will be normal data. So that will be that will normal data. Okay. So now suppose I got my values here very far from this. So that will be an outlier. I got my values here. So that will be an outlier which is very less than our mean values. It is very greater than these values. Okay, so that will be our outliers. Okay, so how we will fix this outliers? So I have two methods. Okay, I will show you how to do it by Python. First, see, method one using IQR. Okay, IQR is equal to Q3 minus Q1. I've already described. So, suppose I am calculating this Q1 minus 1.5 into IQR. So, I got some values like, let's say 15. Okay, by calculating this. Now, I have a value that is 14, which is less than this. Then that will be an outlier. And suppose this is I got value here in 15. So suppose I got value 16. Okay, then that will be a normal value. Okay, but I will get 14, then it will be an outlier. Suppose here I am calculating maximum. Suppose I got 50, but I got 50, but I have a value that is 51, that is greater than this, then that will be an outlier. Suppose I have value 49, then it will be less than this, then that will be a normal value. Okay, so I will check this and detect this by IPR method and also fix the outliers. Remove the basically I will remove the outliers by IPR method. Okay. Second method we will also see using Z score. Z score, what Z score says, Z is equal to X minus mu upon sigma, where X is your actual data point. Suppose I have data 80 kgs, that is our actual data point. Mu, mu means mean, this one, mean. Okay. Now, sigma, standard deviation. How much data is deviating from the mean value? Suppose this is our mean value and I have value around here. So how much my data is far from this mean value? Okay, so that is sigma. And Z score, how far a value is from the mean. Okay. So this is sigma basically stand how much data is deviating from the mean. Okay, so that is there is a rule. If Z is greater than 3 or Z is less than minus 3, then that will be an outlier. Okay, so I will see that I will show you how to handle outliers and remove outliers. Okay, so first see the data set. This is my data set. I will check for height and weight outliers. Okay, now see how we can do that. I will use, I will rename. Suppose I will give some name outlier detection removal. I will import some library. Import numpy. Sorry, numpy as np. Import pandas as PD. I will import matplotlib and seaborn also data. Those libraries are for plotting graphs. Matplotlib.pyplot as PLT, import seaborn as NS. Okay, shift plus enter. Now I will load my dataset. Okay, suppose I will take a variable df is equal to pd dot read csv. I have CSV file. Right click, copy path, control V. I will check first three rows which are of head. Oh, sorry, it's not data. Df. So here are first three rows and my data gets loaded. Now first I will check if there is any null value in my data set or not. Again data I'm writing. Sorry for that. No, there is no null values in my data set. I will check this by describe. It will give me all columns, mean, num. Okay. So, so it gave me dot describe gave me heights and weights count total 10,000 rows are there. 10,000 rows. Mean of these two columns, standard deviation, mean, and maximum for 25%, 55%, 75%. Okay. So first I will check by plotting a graph if there is a outlier or not. Okay. I will plot a basically box plot for these two columns. Okay. Its size. I'm giving up my uh, graph size. You will see the subplot at the first place. Whenever I will plot multiple graphs together, we will use subplot. Okay. I am plotting a box plot, give your data, which is my data set df y is equal to df, and which column we are calling weight. I will give a title. Suppose I will give weight before. Okay. Now same I will give for height column also. So C, control V. I will give this as second place. Give height and give the title height. Okay. Now just write plt dot show. It will plot the graph. See, see, you can see in weight column an outlier is occurring. In height column, there are some outliers at minimum, before minimum also, and after maximum also. Okay, you can see it. So this is confirmed. I have outliers. Okay, so first we will see how we can handle outlier using IQR method. Okay, first I will suppose I'm calculating this Q1. Okay, Q1 df df weight. Q1 basically gives 25%, finds 25% of the data, right? Quantile 0.25. Okay, it will give the 25% of the data. Same, I will calculate Q3 also. Q3 right, Q3, and right here 7 point. Okay, okay. So what is my IQR? IQR is equal to Q3 minus Q1, Q3 minus Q1, Q1 50%. So I will calculate this. IQR, I'm calculating for weight, so I am giving weight W. Okay, so don't get confused by this. I will minus, it will be minus Q1. Okay, now we will suppose then my IQR. So, so this is my IQR. Okay, now I will calculate lower also on the on basis of this. Lower means minimum and upper maximum. I will calculate this. Okay, lower W is equal to, what is the formula of lower? Q1 minus 1.5 into IQR, and for upper Q3 plus 1.5 into IQR. Okay, so Q1 W minus 1.5 into IQR. Okay, so this is my formula. I will print this also. So here it is my lower, and I will calculate upper also. That is my maximum. What is the formula of this? Q3 plus, okay, Q3 plus 1.5 into IQR. So Q3, where is my Q3? This is my Q3. Control C, Control V, plus 1.5 into IQRW. Okay, I will print this also. So I got my minimum and maximum. And what I have, what we have learned. See, if value is less than this, less than minimum, then that will be an outlier, and maximum greater than this, then that will be an outlier. What it means then? If I got a value less than 58, that will be my outlier, and greater than 264, that will be an outlier. Okay. So same I will calculate for my height column also. Uh, for height column also, I will give h. I will replace this by height. Replace this by height. Press enter. Now IQR h. I will replace this by h is equal to. I will again replace this by h. 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 Okay. I will print this. Press enter. I got my IQR h. Okay. Now I will same calculate lower and upper. Means lower means minimum, and upper means maximum. I will replace this by h, given h, and h. Okay, I got this. Okay, no upper, 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 sorry, height. Okay, I will replace this. So I got my minimum value and maximum value for this. If I have a value less than this, then that will be my outlier. I have value greater than this, then that will be an outlier. So now I will simply create a new variable where we will store the data without outlier. How we can do that? Suppose I have created a variable here. I will store the data without outlier. How we can do that? df. I'm going for df. Okay. Now I'm going for my df weight column. What I'm saying is give me those that weight column. Basically df IPR will be df, basically a df data, but df weight will be greater than or equal to lower means minimum. It should be greater than or equal to, otherwise it will be an outlier. And now weight should be less than equal to upper, right? Upper. Okay, you got my point. What I'm saying, give me the data where weight is greater than minimum, greater than minimum, and less than maximum, less than less than maximum. Okay, what I'm saying here. Same for my weight column also. Give me those height. Sorry, give me same for my height column. Give me those height which are greater than minimum and less than maximum. Right? Okay. Okay. Sorry, not fine. Okay. I will simply do chat GPT. I will simply paste what it is saying. Okay. So I will simply copy this. Right. Okay. It has picked my value. Now, so you got my point, right? Now, now I will plot a graph to see whether my outlier is removed or not. Okay. So I'll simply copy this. Simply copy this. Okay. Here I will give height. Sorry, weight. I will write here after, and I will give this because now my data is in this without outlier. Okay, same here, and I will write height after. No, plot the graph. See, outlier is removed. See, see the basic difference between these two graphs. Here it was an outlier. Here I had an outlier. Now see the graph. There is no outlier. Okay. So we have fixed the outlier. Okay, by IQR method. Now we will see how to fix outlier by Z score. Okay. So I have already explained Z squares mathematical expression. Okay. Now I will do this using Python. For performing Z score, I have to import basically stats from SciPy, import stats. Okay. Now works but basically gets very simpler in with G square. Okay. What just I need to write G weight is equal to np dot abs. What is this abs means? This abs is for converting the negative values into positive values. See, we can get -3 also. So just we are converting into positive value. So we will not need to basically do separate coding for minus and plus. I will do this by this one only. Okay. So np dot stats dot z score z score df weight. Okay. Same for height also. Okay. So we are calculating its z score. Z score means we are suppose I got 3 -3. So I can get if my value will be greater than 3 or minus less than -3, then that will be an outlier. Okay. So just we are calculating z score. Okay. Basically what this is doing, this formula. This formula is basically here dot z score. That's why we use Python for machine learning. Okay, we are doing this uh, mathematical expression by this one line of code only. Okay, so suppose I will print this also. So, press enter. Okay, I got this z weight and z height. Okay, now I will basically I will store a store my new data into new variable without an outlet. Like in IQR method, I had df slash IQR where I stored my new data without an outlet. In same way, I'm storing my new data into this but without any outlier. So how we can write the condition? I'm writing give me the df data, give me the df data, but what should be z z weight z weight should be should be less than 3. and and df with height also. Height, Z height should, what I'm saying here, give me the DF data exactly, but weight, Z weight should be less than 3 and Z height should be less than 3. Okay. So yeah, we do chat with it. Take this. Yeah, I will copy this. I will take this. Okay. So shift the center. So I have new data. I have plot. I will plot new graph also for seeing that by z square method, my from z square method, my outlier gets removed or not. Okay. So how we can do that? I will simply copy this. I'm simply copying this. I will just remove this and I will just update the new variable. Okay. DXJ will be some. See, from my z square method, also the outlier gets removed. Okay. Okay. So here we can see one outlier is coming. So it didn't work perfectly, but although it basically replaced all the maximum outliers. See, first I had these outliers, this much outliers in height, and now I have only this one. I have also only this one. So so by G square method, it didn't remove one outlier, but although it removed most of the outliers. Okay, so this is how we handle outliers using Z score and IQR method. Okay, so in next video we will see feature scaling using normalization. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss feature scaling using normalization. First we will see what is feature scaling. Feature scaling means bringing all features means columns to a similar scale so that no feature dominates other. What it means? Suppose I have two columns. I have age column in which data lies between 80 to 60 and I have salary column in which data lies between 20,000 to 1 lakh. Okay. So as we can see, salary's value is much greater than age, right? So when we will build machine learning model, then it will give more importance to this salary column because it is much higher than age column. Okay, which is wrong in our case. Both are important for us. Okay, so in that case, normalization comes into play. Now, what is normalization? Normalization is a type of feature. scaling where values are converted into a fixed range, usually 0 to 1. What it means? Suppose I have a data frame in which I have values 10, 20, 30, 40. Okay. Now I will apply, when we will apply normalization to it, it will convert 10 to 0, 20 to 0.33, 30 to 0.66, and 40 to 1. Okay. So this is how normalization works, and this is how normalization scales the data, right? So this is the mathematical expression for basically normalization, where this is x prime. X prime is basically a new normalized value. Okay, and x is your original value, and x mean is the minimum value in the column, and x max is the maximum value in the column. Okay, so for these algorithms, we generally use normalization. For k-means algorithms, k-means algorithm, SVM algorithm. We will see all these algorithms one by one. Then we will see supervised learning, unsupervised learning. Okay. So now this is the data set. I will apply normalization to these two columns, height and weight. Okay. So see, I will show you how we can do it using Python. So for Python, we will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So when you will download it, just search Anaconda prompt, give your file location, press enter, write Jupyter Lab, press enter. It will navigate Jupyter Lab into my browser. I will wait for a few seconds. So I will choose this. I will rename this. I will write feature, scaling, scaling, normalization. Okay. Press enter. Now import some libraries, some required libraries. Numpy, import pandas SPD, import matplotlib.pyplot as PLT, import cbond as an ascent. Okay, hit the enter. I will take a variable data is equal to pd dot read, where I will give this is our seventh lecture. I will copy path into the, I will check my first three rows just to ensure my data is loaded or not. Okay, so my data is loaded. Now I have to basically apply normalization for these two columns. So what I will do, first I will separate these two columns. Okay, suppose I will write num cols. I have taken a variable and I will just give the name of these two columns. Okay, Whenever we will call it, I will write data. Okay. 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 Now, first I will plot a graph. Okay. I will plot a graph. I will directly num calls. Okay. This plot. I will give some subtitle before normalization. Okay. TLT dot show. Okay. See, see here. Don't look at the this graph. Okay. See these values 400, 350, 300. What we need to fix is this, not this. Okay. So you don't need to basically see the bar graph, sorry, bars and all. Okay. Just see the values. Okay. Now, how we can apply normalization? For that, I will need to import min max scalar for normal normalization dot preprocessing from preprocessing module of scikit-learn import min scalar, right? Yeah, min max scalar. Okay. Oh, sorry, this is a spelling mistake. Okay. Now I will create an object to call my min max scalar. Okay. Scalar is equal to with tab min max scalar. Okay, I have created an object to call min max scalar. Shift plus enter. Now I will just copy my uh, actual data into a new variable data dot copy. Okay. Now data I will test it. Num I will sorry I will call num calls for those columns, num calls for height and width, which I have taken in num calls, I have to perform normalization. So I will call num calls directly is equal to this is the object through which I am calling min max scalar. So just write scalar dot fit transform data num calls, right? So again, fit will basically fit will basically learn the unique values, all the unique values in heights and width, and transform will basically scale the data. Scale the data means it will convert it like in 0 1 0 0.25 0.3 like this. Okay. So shift plus enter. Now I will check my data scaled. See height and weight column. First see here the height and weight column 1.62. This was the actual data set in which I had the values in height and width columns like this. And now after normalization, look at the values. it has scaled the values of height and weight. Okay. Now I will plot a graph. Data scaled numpulse dot is plenty what's the title right after normalization. I will give the title after normalization. Okay. PLT dot so see now look at the values. Now look at the values 0, 0.25, 0.50, 0. This is the values. And look at here. Here is the values were 1.6, 1.8, 2.0, 50, 100, in 150 in weight column 50, 100, 150, and in height column 1.6, 1.8, 2.0. Now look at the values of of height and weight 0.00, 0.25, 0.50, and 0.00. So it has converted, it basically scaled the data. Okay, scaled the data. So this is how normalization works. In next video, we will see feature scaling using standardization. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss feature scaling using standardization. In my previous video, already I explained what is feature scaling and how to do it using normalization. Feature scaling means bringing all columns to a similar scale so that no other feature dominates other. Okay, which means suppose I have age column 18 to 60, salary column 20,000 to 1 lakh. When we will build machine learning model and when we will use some algorithms, then it will give more importance to this because this column has the value like 20,000 to 1 lakh, which is much higher than this value. So it will give more importance to this, which is wrong in our case. So to counter this, in previous video, I used normalization. It basically scales the data to 0 to 1 form. Okay. So in this video, we will discuss how to perform feature scaling using standardization. Okay. Standardization is also a method of doing feature scaling, which brings all columns to the same scale. Okay. It converts data so that mean becomes 0 and standard deviation becomes 1. So it uses this mathematical expression z is equal to x minus mu upon sigma. Is your original value, mu is equal to your mean, and sigma is your standard deviation. How much data is deviating from the mean value? X minus mu gives the distance between the mean value and the your actual value. Okay, so why do we use standardization? Suppose I have two columns in my data, height and weight. In my height column, there are values 1.5 to 1.8, and in weight column, I have values like 50 to 90. When you will use logistic regression, SVM, KNN for building machine learning models, then it will give more importance to this weight column because weight column's value is much higher than this. So it is wrong in our case because both columns are useful for us. Okay. So to counter this problem, we will use standardization in today's video. First, look at the data. In this data, I will basically scale the data of these two columns using standardization. Okay. I will show you how we can do it using Python. So for Python, And for coding purpose, we will use Jupyter Lab. Please download Anaconda Navigator. In my system, it is already downloaded. When you will download Anaconda Navigator, just search Anaconda prompt. Just search Anaconda prompt. Type cd. Give your file location. Give your file location. Control V. Enter. Write Jupyter Lab. Press enter. Navigated Jupyter Lab into my browser. Good. I will rename this. This is my eighth lecture. Eighth lecture. Feature scaling standardization. Okay. Center. First, I will import some required libraries. Import numpy as np. Import pandas as pd. Import matplotlib. Matplotlib dot pyplot as plt for plotting some graph. Okay. So first I will do. Okay. df is equal to pv dot read as CSV because I have CSV file. If you have Excel file, then write Excel. Just right click, copy path, Control V, check your data using by seeing first three rows. Okay. So my data gets loaded, and these are my first three rows. Okay. So I will first copy my data into a new variable first, just to show you by plotting some graph. Sorry. Copy. Okay. I have copied this df data into df before. Okay. Now I will perform standardization for these two columns. Okay. First I will import, sorry, from sklearn dot preprocessing import standard scalar standard scalar. Okay. Press enter. Plus enter. Now suppose I will make a object to call standard scalar. I have made an object. Okay. Now, which columns I want to basically scale, height and weight. So I will just take df double braces, square braces, height and weight. Okay, is equal to. I will call my object to call standard scalar dot fit transform fit transform df. I will just copy this. Okay. So what we are doing here, I'm calling standard scalar to fit for these two columns. Okay, it will scale the data for these two columns. Okay, so fit means it will learn the unique values of all unique values of height and weight, and transform will transform these values, or we can say scale these values into 0 to 1 form. Okay, so press the plus enter. Okay, now suppose I will check my df. Now see your height and weight column. It has basically scaled the data. Now here it had values like this, height and for height and weight. Now see the value it has scaled for height and weight. See, these are my new values. Okay, it basically scaled the data. Now my algorithms will treat both columns equally. It will not give more importance to any column. Okay, it will treat equally to all columns. I will I will show you by plotting a graph also before and after. Df before, because I have not interrupted df before. I have copied directly df data into this. Okay, so my df data is affected, not df before. Okay, suppose take height column, height and weight column. Okay, plt.x table, height. Same I will give for y label. Weight. Okay, I will give a title for my graph before standardization. Okay, before standardization. Before. Okay, now plt dot show. See, but don't look at this. This is your just value. Look at these values: 160, 140, 120, 100, and look at this: 1.5, 1.6, 1.7. Okay, now I will plot a graph after standardization. Okay, so I have standardization in df data. So I will just edit this by df from df before. Okay, and I will write after standardized. After standardized. Okay, got it. Now look at the value: 3210 minus 2 minus 101. Okay, so this is how values get changed. Okay, it has scaled our both columns. So this is how standardization works. Okay, so that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss function transformer. So what is function transformer? A function transformer is used to apply any custom mathematical function on your data. In simple words, if you want to change your data using your own formula, use function transformer. What it means? Suppose suppose I have a column passenger ID. Okay, and I have these values in it. Suppose I want to add a custom method, like every value should be divided by 100. So we can apply this method using function transformer. Okay, so why do we use it? Sometimes data is skewed, values are too large, relationship is non-linear, and these are the function we can apply, or we can apply our custom formula. Okay, now real life example. Suppose I have values like 1000, 2000, 50,000, 1 lakh values in a column. So these are much higher values. So after function transformer, we will basically make it smaller. Okay, we have reduced the values. Okay, so now after this data will become balanced. Okay, so I will show you how we can do it using Python. For coding purpose, I will use JupyterLab. For JupyterLab, please download Anaconda Navigator and then search Anaconda prompt here. Anaconda prompt, write CD, give your file location, Control C, Control V, enter, write JupyterLab. It will open JupyterLab into my browser. I will wait for a few seconds. I will choose this. I will rename function transformer. See, our first goal is to reduce these values. Okay, so for that we have already default function in our function transformer. I will show you that default function, and then I will show you by creating our my own function and how to call that function using function transformer. I will show you both. Okay, so first I will import some libraries. Import pandas spd, import matplotlib.pyplot as plt, swift plus enter. Now I will load my dataset. df is equal to pd.read slash csv, because I have csv file. I will do copy path, paste here. Now I will check my data is loaded or not by checking first three rows, df.head. So my data gets loaded and these are my first three rows. Okay, so I have to reduce these numbers, and I will do this by using a default function of function transformer. So first I will show you the default function. Okay, now from std dot pre-processing, I will first import function transformer. Function transformer. Okay, now I will create an object. Suppose I will create log transformer is equal to, I will call function transformer by this object. Now I have to give the function name here. I will use a custom function. Sorry, I will first use a default function. Click Shift plus Tab. Now you will see this is our uh, default function to basically reduce the values. Okay, I will use this first. Control C, Control V, plus enter. Now I want to use this function for this column. I will take that column from df data, take this column, Control V. I will call my object dot fit transform. Now, which is I am fitting passenger ID column. Give your passenger ID. Okay. Now set plus enter. What we have did here? What we did here? I have fit means it will learn all the unique values of passenger ID and transform will basically transform these values into smaller values. Okay. Now check your DF data. Now see the values of passenger ID here and here. 892, 893, 894, and here. See here. Okay. So this is how we use custom method to reduce the value. Now I will show you how we can use our own custom method. Okay. Now suppose I will create my own custom method. Custom function. Custom. Suppose I will create this. Now suppose I want to divide all the numbers, this number by 100. Okay. Return return x return 100. Okay. This will be my custom function. Okay. I have created. Now I will call the function transform by creating an object is equal to function transformer. Okay. Now I will give the function name is equal to this. This custom function I have created. So I will give this name control. Okay. Now set plus enter. Now I will do the same process. Control C, Control V. I will change the object name because this is my new object of custom function. I will call this. Okay. So now you will check DM. Sorry. Suppose I will give a new name. Okay. Let's go. Now see this passenger ID have reduced these values using a default function. This one. It reduced these numbers by using this function of function transformer, and then I use my own custom function to divide this passenger ID by 100. Okay. So this is your passenger ID custom, which is used. I have used for my custom function of function transformer. So this is how we use our custom function and default function of function transformer for doing different things. We can reduce the number. We can apply my own custom method. Divide by 100, divide by add by 5, anything we want. So this is how it works. Custom method or default method of function transformer. Okay, so that's all for this video. In next video, we will see feature selection. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss feature selection. So what is feature selection? Feature selection is choosing only the important columns or features for your model instead instead of using all columns. We keep only those that actually help in prediction. What it means? Suppose suppose I have this data set and this is an example of classification problem. Okay. Now these are my input fields and this is my output fields. Okay. Based on these input fields, I am getting the value for my output field, right? Now suppose I got to know that this field is not affecting my output column too much. Okay. So what I can do, I will simply drop this instead of going forwards with this column for building models. So how will I got to know that this model is not affecting my data output data too much? Using feature selection. Okay. So why do we need it? It removes the irrelevant features, means columns, reduces overfitting, improve model accuracy, and makes model faster. Okay. Now, how to do feature selection? There are two methods using SelectKBest, using random forest. Basically, we generally prefer random forest. But yeah, these are two methods. I will show you how to do feature selection using these two methods using Python and Scikit-learn. And for coding purpose, I will use JupyterLab. For using JupyterLab, please download Anaconda Navigator. When you will download it, just search Anaconda prompt here. Type cd, give your file location, copy this, paste here, write JupyterLab. So it is opened in my in my browser. I will choose this. I will rename this. I will write feature selection. I will import some required libraries. Okay, so press enter. Now I will load my data set. This is my data set. I will copy path, include B. Check your first three rows. Data is loaded or not. So yeah, my data gets loaded and these are my first three rows. Now, so first I will divide my data set into two parts. First for all input columns and one for output column. Okay. Now suppose in my X variable, I am taking all input columns. Give me the whole data set, but drop this column. Okay. This is what I am doing. I am taking all the columns, but I am dropping my output column. Okay, and in my y column, I will take my output column. Okay, so I've divided my data set. Now, first I will check correlation of all columns. So it gave me the correlation between all columns. First, I will show you by plotting a graph. Okay, I will plot a heat map. Now, see the last column. So rotational speed RPM is in negative. So it is basically harming my model accuracy or my output print. Okay, 0.24 quite good. 0.12 again it is less affecting my output field. 0.39, 0.39. So these are the two fields which are mainly affecting my output fields. Okay, this is what I get to know from my graph. Okay, now how to perform how to perform feature selection using using first method, using SelectKBest method. Okay, now first I will import SelectKBest method, sklearn dot feature selection, SelectKBest, and F classes. Okay, if you have uh, basically regression problem, so I have this is a classification problem, so I am taking F classic. If you have regression problem, then you can import F regression. Okay. Now plus enter. Now I will make an object to call my select kbest method. So function is equal to F classic, comma k is equal to I'm taking 3. Now what we are doing here, I'm I'm basically making an object to call my select kbest. Select kbest basically select top k features. This select this k features. It will select top k features. Okay, k is equal to 3. Now f is equal to classic. Basically f classic. Basically it is a statistical test for classification. Okay, F classic means. And K is equal to 3 means select top three columns or top three features. I'm using select K best method. So basically give me top three features. Okay. This is what I'm saying by this line of code. Now, Now suppose I'm taking a new variable, selector. I will call selector fit transform. I will transform now. Now, what it means? Selector fit means it will learn which values, which columns or features are most important, and transform means only keep those important features. Okay. Now, shift plus enter. Now I will take a new variable, selected features is equal to x dot column. I will filter my x column, which is my input columns. I will again call my selector object, get support. Okay, get support. So basically, it returns true or false for each column. Means this is my most important. This is affecting my data too much. Yes or true. This is not affecting my data. False. This is what get support do. Now, now I will see my selected features. See, it gave me top three features which are affecting my output data too much. See, 0.24, 0.39, 0.39. These three features have the highest values, right? Torque, NM, TWF, PWF, right? So it gave me top three features, right? So we got our three columns, the top three columns which are affecting my output data. So this is the first way of doing feature selection using SelectKBest method. Now I will show you how to do it using random forest. Okay. Now I will first import dot ensemble import random forest classifier. So again, it is my classification problem. So that's why I'm importing random forest classifier. If you have problem of regression, then you can use random forest regression, regression. Okay, got it? Now I will make a object to call my random forest classifier. Okay, shift plus enter. Now I will fit my XY columns. Sorry, XY. Okay, it get fitted. Now suppose I will make a column. Sorry, variable model dot feature importances. So what I am doing? I'm calling my random forest classifier through this object model which I created dot feature importances. After training, this I have trained. After training, model gives importance of each feature. That's what I'm doing here. Okay. Now shift plus enter. Now I will make a new variable feature Importance. I will make this into a readable format. Series importance, importance, index is equal to x dot columns. Okay. And converting important values into readable format. And index is equal to x dot columns means attach each feature names. Okay. That's what I am doing here. Dot index, small x. Okay. Suppose I will call this. So it gave me, okay, it gave me the values, right? This torque have the good value 27, 0.13. Okay. So it gave me the values. Okay. Now suppose I will make a graph dot value ascending is equal to false. I will make it higher to lower dot dot plot and is equal to bar. I will plot a bar graph. See. So see, it is showing this column is affecting my output data too much. Then torque, then rotational speed, RPM, then TWF and PWF. Okay. So it sorted in higher to lower. So this is saying this column is affecting uh, mostly into of my output field, then this is affecting more than this and then this. So this is my most important column for my output data. So this is how we do feature selection using these two methods, select k-best method and using random forest. Okay. So I have shown you all two methods of doing feature selection. So that's all in this video. In from next video, we will start supervised learning. Okay. Thank you. Hello guys, welcome to the channel. From today, we are starting our core machine learning series. So first understand what is machine learning. Basically, machine learning is a branch of artificial intelligence through which computers learns from the data, and then it make predictions or take decisions on the basis of the data we provided. Okay, so this is what machine learning. And there are three types of machine learning: supervised learning, unsupervised learning, reinforcement learning. We will see all these three learnings one by one. But first, we will go for supervised learning. Okay, there are two types of supervised learning: classification and regression. Okay, first understand what is supervised learning. So supervised learning is a type of machine learning where the model learns from the labeled data. Okay, what is the meaning of labeled data? Labeled data means we know the input. Okay, this is our labeled data set. Okay, we know the input and also we know the correct output. Okay, so this is our labeled data set in which we have our inputs also, output also. We know the input and output both. Then we will train our model using this label data set. We will train the model here, but first we will always split our data set into two parts, training data and testing data. On the basis of, by training data, we will train our model. We will train our model from the training data, and once my model will be built, then remember I splitted the data into two parts, training data and testing data. Now I will test my model through my testing data. Testing data, okay? Now, on the basis of testing data, my model will give predictions. Predictions that this is apple, this is apple, this is orange, and this is how supervised learning works. Okay, so there are two types of supervised learning: regression and classification. Regression for continuous values and classification for categories. Categories means yes, no, true, false, or maybe more than two types of categories like red, blue, green, cat, dog, cow. Okay, these are categories. We will predict through classification, and continuous values for we will predict by regression. Means suppose someone has 25,000 salary, someone has 50,000 salary. We will predict the salary or something like that, continuous values. Okay, this is what supervised learning means, and there are two types. From next videos we will learn how we can practically implement these algorithms. These are its algorithm: regressions algorithms, classification algorithms. Okay, first we will understand how we can apply these algorithms for our supervised learning for classification and regressions. Okay, then after supervised learning, we will cover unsupervised learning and then reinforcement learning. Okay, so that's all in this video. From next video, we will cover practically the different algorithms of regression and classification. Okay, thank you. Hello guys, welcome to the channel. From today, we are going to start our new topic, that is supervised learning, and our first topic is train test split. Now, what is train test split? Train test split is a technique used in machine learning to divide a dataset into two parts. Training data used to train the model, testing data used to evaluate the model, right? Purpose to check how well your model performs on unseen data. Now, suppose this is my dataset, okay? This is the dataset on which I will work. So this is my column. Okay, this is my column row. And suppose I am counting the total rows. Yeah, 1104. If I don't count the columns, then I have 1103 columns. Okay, now what will I do? Now suppose I am building a machine learning model. Okay, so then what I will do? I will divide my data set into two parts: training data and testing data. Suppose I have converted my data set into divided my data set into 80% and 20%. 80% for the training data and 20% for the testing data. Now, from 80% of the data set, I will train the model. And then when the model gets prepared, then I will check its output through the 20% testing data to check whether it is giving the correct output or not. Okay. So that is the concept of train test split. So why do we need train test split? If you train and test on the same data, the model may memorize the data. Obviously, like suppose you train the model by 100% data set. Now you have to check its output, that it is giving correct or not. If you if you check by the same data set from which you have trained the model, obviously it will give the right answer. Okay, so very high accuracy. Obviously, when it will give all the answers right, then it will give a higher accuracy, but it will be misleading. Okay, so obviously, always convert data set into two parts: training data and test data before building your model. Okay, now suppose basic idea: train, learn patterns, train data set for learning patterns, test data for checking performance of the model. Example, suppose I have 100 data points, means 100 rows. I will, I will basically keep my 80 rows for training and 20 rows for testing. Okay, how it works? Shuffle the data set. First, shuffle the data set randomly. Okay, then split it into two parts: training and testing. Train model on training data. Basically, prepare the model by training the model by training data set. And now when basically model gets prepared, then test the model by testing data, then like it is giving correct output or not, right? So I will show you how we can do train test split using Python. For coding purpose I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system it is already downloaded. So when you will download it, just search here Anaconda prompt. CD, give your file location, my file location, Control C, Control V, enter, write Jupyter Lab. It will navigate the Jupyter Lab into my browser. I will wait for a few seconds. No, I will choose this. I will rename this. Rename first topic. Train test split. Okay. No, I will import some basic required libraries. With pandas, XGBoost. Now I will load my data set. Data is equal to pt.read slash CSV because I have CSV file. I will give you the data set, copy path, control P, check my data is loaded or not by data.head. It will give you first three rows, data.head 3. Yeah, my data gets loaded. Okay, suppose first I will check is there any null value or not in any column. No, I don't have any null value. So perfect. Okay. Now, first, basically, first divide your columns into two parts. Divide your input columns and output columns. Means this is my output column. Okay, it column depends on these columns. Okay, right. So just divide columns into two parts: input and output columns. Okay. Now suppose x is equal to data dot drop means give the whole data set but drop only one column, that is lat. This is the data set for house price prediction. Okay, so this is the column for house price. Okay, so this is your output column. Means these factors will decide how much value your house, how much price the house could have. Okay, now so I will take y. Y is equal to give me the only output column, right? I have taken all the columns, input columns into X. Now I will take output column into Y. Okay. Now I am divided into two parts. Now I will now divide the data set into two parts, training data and testing data using scikit-learn's train test split. Now how I can do it from sklearn dot model selection import train test split. Okay. Now when I will convert the data set into two parts, training data and test data, then I will always have four, basically four variables, four total, four total type of variables in which data will contain. First, X train and X test. Okay. Then Y train and Y test. Okay. Now I will X train, X test, Y train, Y test is equal to, now I will call my train test split to co- convert, basically divide my data set into two parts, X comma Y, right? Now test size. Test size means, suppose what, in what ratio you want to divide your data set. Now I suppose I want to divide my data set into two parts, 75% and 25%. Now 25% means 25% will be your testing data. Okay. So mm, if you want to take 25% of the data set for your testing, then write 0.25. If you want to take 20%, then write 0.20. Okay. Now I will write one more thing. Random variable. Random state. Random state is equal to 42. What it means? Suppose, suppose it divided the data set into two parts, training and testing. It will randomly divide into training and testing. It will not divide like from 0 to 700 rows. It is testing data and rest you have training. No, it will not work like that. It will randomly divide your data set into training data and testing data. Now, suppose I run this line. Okay. Now data gets divided. Okay. Now data gets divided. Then suppose you open the program again after some time. Then again you basically run this line. Okay. Then if I don't write this random state, it will again change your data set. It will again randomly, it will basically again randomly divide your data set into two parts. If you will write random state is equal to 42, then it will be fixed. First time only it will divide your data set into random, then it will keep the data set remaining, it will remain same. Okay. By writing random state is equal to 42. Okay. Now suppose I will check x train dot state. Now 827 rules. Okay. Now first I will show you data dot set. Okay. From 1103 rows, you got 827 for training data. Obviously 14 columns because I have not taken the output column in X. Now it has converted 827 into training data from 1100. Now check X dot say 276 for testing data, right? Same same for Y also. 827, and one column 276 rows for one column. Okay. Y for output basically. Okay. So it has converted our output column 827 for basically training data set, 276 for testing the data set. Okay. For output column, and for input columns 827 for training, 276 for testing. Okay, this is what the concept of train test split. We will always use train test split before building any machine learning model. Okay, in the next video we will cover linear regression. Okay, that's all in this video. Thank you. Hello guys, welcome to the channel. In today's video, we will discuss simple linear regression. Okay. So first, understand what is linear regression. Linear regression is a supervised learning algorithm used to predict continuous values. For example, predict house price, predict salary, predict temperature. Okay. So basically, it has two types: simple linear regression and multiple linear regression. Okay. We will cover both. In today's video, we will cover simple linear regression. Okay. So what it means? In simple linear regression, we will have one input column and one output column. On the basis of, in this data set, on the basis of ours, we are predicting how much scores a student will get. Suppose someone studies for 1.1 hour, he is getting 41 marks, 1.2 is getting 40 marks. So on the basis of that, we will make a prediction model using simple linear regression, and we will check that. Okay, now first understand, okay, basic idea. Now what this algorithm do? See, suppose this is the graph I have plotted between my independent variable and dependent variable, means input value and output value. Okay, so first see, these are the data points, actual data points. These are my actual data points. These dots are my actual data points. What this algorithm do is it will draw a prediction line. Okay, and it will try to basically draw that prediction line as close as close as possible to the actual data points, means these values. Okay, it will always try to draw a prediction line as close as possible to its actual values. Okay, so this is how this algorithm works. We will check that using by working on this practically for this data set. Okay, so I will show you how we can do it. For coding purpose, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So once you will download it, just search Anaconda prompt, write cd, give your file location, control V, press enter, write Jupyter Lab, press enter. It will navigate Jupyter Live into my browser. I will wait for a few seconds. I will choose this. So I will rename. Suppose I will give simple linear regression. First, I will import some required libraries. Empires, NP, import pandas, as video, import matplotlib dot pyplot as plt, import cborn as sns. Okay. Now I will load my data set. Okay. Data is equal to pd dot read slash csv because this is my csv file. By the way, I will give you the data set. Right click, copy path, control V. Now check my data is loaded or not by checking its first three rows. So yeah, my data gets loaded and these are its first three rows. First, I will check is there any null value in my data set. No, there is no null value. So it is perfect for operating. First, first I will show you by drawing a graph. I will show you its actual data points. Okay. So first plt dot figure. I will take some figure size. Fig size is equal to 5. I will plot a scatter plot. I will take my x for hours, y for scores, and data will be my data because in my data variable I have loaded my data set. Okay. Now plt dot show. Okay. These are my actual data points. Okay. These are my actual data points. So as you can see, I can see here, I have some outliers also in my dataset. So how to handle outliers? I have already made a video on this. So in this video, we will not handle outliers. We will just basically understand simple linear regression algorithm, how it works by building a model. Now in previous video, I have covered in- before making any model, machine learning model, always we will divide my dataset into training and testing. Before that, I will divide my dataset into input and output. Okay, so I will take my input in X data. Our column is my input column. Control C, and in Y I will take my output column. So score is my output column. I will take that in my Y variable. So data gets divided into input and output. Now I have to divide my dataset into training and testing data. Okay, so I will first import from sklearn model selection, import train test split. Okay, now I will take my all four variables to divide my dataset into testing dataset, train and test dataset. Y train, Y test is equal to Now I will call train test script to divide my data set for which variables x and y I have taken. Now, suppose I want to divide my data set into 75 is to 25 ratio, means 75% for the training, 25% for the testing. So, how much we are taking our testing data? 25%. So, I will write 0.25 and I will give random state is equal to 42. I already discussed its theoretical part of random state in my previous video. You can check that. Okay. Now set plus enter. So X train for training data for hours. X test means testing data for hours. Y train means testing data for scores, and Y test means testing data for score. Okay. So this is how I have divided my data set into 75 is to 25 ratio. Okay. Now, now I will make my model. From first I will import linear regression scalar dot model, sorry, linear model import linear regression. Okay. Now, suppose I will make a object to call linear regression. Okay. Now, I will fit my training data into it. Y train. Okay. I'm giving the training data set for the model. Okay. I have given my training data for linear regression for the model. I have trained the model. Okay. Now, suppose I will check my accuracy. Okay. Suppose I will check my accuracy for the model. So this is how we can check the accuracy of the model. It is showing 50% is my accuracy. So it is very, very low accuracy showing for my model. This is because we have not removed the outliers. Okay. In my previous videos, I have already covered how to handle outliers. So I am not covering this. Basically, I am not handling outliers in this video. You can check that video. So my model gets trained, and I got my accuracy of the model. Okay, because I have not removed outliers. I have not removed basically outliers, so it is giving me very low accuracy. Okay, so no worries. Now, suppose I will try to predict a value. Suppose, suppose I will take a value 1.1. See, for 1.1 it is 41. Okay. Now I will check 1.1. Okay. I am not given the parenthesis. Okay. So this is a warning. You can ignore. So it has given 38, but you can see it was 41. So it predicted 38. Means suppose the student who studies for 1.1 can get the score of 38 if the model predicted. Okay. So this is how it gives prediction. Now I will make a new variable. So y predict is equal to lr dot predict. I am predicting my testing data set. Okay, X test. Okay, basically we are using train model to predict output values for unseen data, means training testing data. Okay. Now, step plus enter. Now I will plot a graph to show you how it draws a prediction line. Okay. So these are my actual data points. These are my actual data points. Now I will plot a graph to show you how how it draws a prediction line. Okay, between the actual data points. Okay. Now suppose I will give some bigger size first. Now I will plot again a scatter plot. I will take exactly same. Okay. Now I'm give I'm giving a prediction line. Okay. You dot plot data. I will take R's column, comma, Y predict. This is which I have predicted for testing data set. Okay, Y predict. Suppose I will give a color to the prediction line, red. Okay, I'm giving my prediction line as red. Now, suppose I will give some PHP dot legend for giving a title. Sorry, to basically recognize the data points and the prediction line. Okay, prediction line. Okay, now I will do PLT dot show. Same as dimension, but I say 60 then 15. Okay, suppose I will not take this. Okay, now see, see, this gave me a prediction line. Okay, this gave me a prediction line. So this is how it predicts the between the actual data points. Okay, so as I have shown already in my notes, so it tries to keep this prediction line as close as possible to its actual data points. Okay, so exactly here, yeah, this gave me a prediction line. It tried to keep all the data points as close as possible to its the prediction line. Okay, so this is how it predicts the value. Okay, so that's all in this video. In the next video, we will cover multiple linear regression. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss multiple linear regression. So what is multiple linear regression? Multiple linear regression is an extension of linear regression where instead of one independent variable, means instead of one input column, we will have multiple features, means multiple input columns to predict the target y, means to predict the output column. So we saw in the previous video I where I performed simple linear regression where I had one input column and one output column. Output column will be one in every case, but I had also only one input column, right? So see, on this data set, today we will perform multiple linear regression. Okay, so these are the two input columns. Okay, these are the two input columns. On the basis of these two input columns, we are predicting our output column, that is salary, total experience and total certifications. By total experience and total certifications, I am predicting the employee's salary. Okay, so you can see here we have multiple input columns. We can have four, five, six input columns also, but in this case, I am taking only two input columns. Okay, for performing multiple linear regression, right? So we can see by plotting a 3D graph for multiple linear regression. So you can see here x1, x2, and y. X1 and x2 are the two input features. Okay, input columns. Suppose in this case, total experience will be my x1, certifications will be my x2. Okay, and y will be my output column. In this case, I have salary column as y. This is my output column y. And every data point is a salary. Every data point here is a salary on the basis of total experience and total certifications. I have explained it in this notes by taking of example of house price prediction. Suppose X1 has a feature size and X2 feature has the second feature, which is bedrooms. And on Y, it's my output. What is my house price? And every data point is my house price with these two input features, right? So on the same way, we have here two input columns. On the basis of two input columns, this and this, I am predicting my output column. So how we can basically build a machine learning model using this data set using multiple linearities. Okay, so I will show you. So for basically coding purpose, we will use Jupyter Lab. Please download Anaconda Navigator to to perform to build machine learning models in Jupyter Lab. So in my system, it is already downloaded. So just search here after downloading Anaconda Navigator, Anaconda prompt. Okay, Anaconda prompt. Write CD. Give your file location here. Give your file location. Control V. Press enter. Write Jupyter Lab. Again press enter. It will navigate my Jupyter Lab into my browser. We will wait for a few seconds. I will choose this. I will rename this. I will rename this multiple. Okay. Now I will import some required libraries. Okay. Import matplotlib dot pyplot as plt. Import cbond as sns. Okay. Now I will load my data set. Okay. Suppose I'm taking a variable data to load my data set. pt.wait slash csv as because I have csv file. Right click, copy path, control V. Now check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and here are its first three rows. Now I will check is there any null value in my data set. We can check that. Okay, there is no null value in my data set. Okay, so this is fine. Now, now I will first show you by plotting a heat map that data, I'm taking data as data's correlation, okay, and not is equal to true plt dot show. Now you can see total experience column is nearly one. So it is very important column for my output column salary, total experience. Certifications. Certifications is not too much beneficial for my salary column, but yeah, I will take certifications also because I have to show you the multiple linear regression. So it should have more than one input columns in it. So now first I will divide my data set into X and Y, right? X and Y. And in X, I will take my all input columns, which are total experience and certifications. And in my Y column, Y variable, I will take my salary column as output column. Okay. X is equal to, I will use iLog. I will use iLog minus 1. So what we are doing here? So I'm saying in my X variable, give me the whole data set of all, give me all rows. This means all rows. And this means give me all columns also, but minus one. Minus one means leave the last column. Last column is my output column. So leave this column and give me all in all columns and all rows. Okay. So this is what the meaning of X is equal to data.ilog is. Now I got my all input columns in X. Now I will take in Y my output column. Okay. What is my output column? Salary. Okay. Now, now I will split the data set into training data and testing data. Suppose I will split my data set into 80% for training data and 20% for the testing data, right? How we can do that? From sklearn dot model selection import train test split. Okay, Shift plus enter. Now I'll give all four variables x train, x test, y train, and y test. Okay, is equal to, I will call my train train test split. Okay, now what are my two variables in for input and output column x and y? Now I have to convert my data set into 80% training and 20% for testing. So how much we are taking for testing? We are taking 20%. So I will write test size is equal to 0.2. Okay, I have already discussed the train test split in my previous video. In our previous video. Okay, so random state is equal to 42. Okay, now my data gets splitted. Now I will build my machine learning model for this data set. Okay. Now from sklearn dot linear model import linear regression. Okay. 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 This is the spelling mistake. Sorry for that. Okay. Now I will give an object to call my linear regression. Suppose I will take LR is equal to linear. I have made an object. Okay. Now I will fit my X test and Y test. Okay. Sorry, X train and Y train for my linear regression model. Okay. I will fit that. How we can fit that? LR dot fit. I am training the model by X train and Y train. Okay. X train means training data of these two input columns, and Y train means training data of this output column. Okay. So I am training the model by giving X train and Y train. Okay. So it's get fitted. Okay. My model get trained. Okay. Now I will check the accuracy of my model, how much accuracy I'm getting for my model. LR dot score X test comma Y test, right? Plus enter. So we are getting a accuracy of nearly 90%. Just multiply by 100. Yeah, we are getting accuracy of almost 90%, which is a very good accuracy, right? We can improve my accuracy also. But yeah, this is also a good accuracy for my model. Okay. Now we will check by predicting a value. Okay. Suppose I will take this input 7 and 1 for predicting salary. Okay. So LR dot predict what are my values? 7 and 1. I will give 7 and 1 as my input. Okay. Now see here. It gave me 79,139. Okay, so here it was 77,318 was my actual, and it gave me 79,130. So it is nearly close. Okay, so it is giving not perfectly, but yeah, it is quite accurate, right? Because also it has 90% accuracy. So this is how we can perform multiple linear regression. Okay, so that's all in this video. In the next video, we will discuss polynomial regression. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss polynomial regression. Okay, so what is polynomial regression? Polynomial regression is an extension of linear regression where we model non-linear relationships between input and output. Instead of fitting a straight line, we fit a curve. Now, what it means? In our previous video, we saw how we can use multiple linear regression and simple linear regression for basically for that kind of data sets in which our independent variable and dependent variable is following linearity. Okay. So when we will use polynomial regression. Okay. When we will use polynomial regression. When our input column and output column will not follow linearity. What it means? Suppose, see this graph. Suppose this graph is of input and output column. So here you can see it is making a curve, not a straight line, right? In these kind of scenarios, we will use polynomial regression. Okay, so what first we will see, why do we need in real world data relationships are often non not linear, which I explained. Suppose an example, salary versus experience. Initial growth slow, then fast, then stable. So this will not follow linearity. Then we can perform polynomial regression. Temperature versus energy consumption, growth patterns, right? So in these cases, we will use polynomial regression in which input column and output column will not follow linearity. Okay, this is making curve. So we will use polynomial regression. Now, how it works? Suppose start with feature X. Suppose this is my data set, okay, and this is my input column and output column, okay. And now I have this feature X, okay, and suppose this data set will this input and output column will not follow linearity, okay. Suppose I have this column X, which which is an input column, okay. Now we will start this with x, our x feature, which is our input column. Now in when we will fit polynomial regression in our algorithm, then we will have to choose a degree is equal to 2, 3, 4, 5, anything, any value, okay, up to degree n. So what it will do? Suppose I chose degree is equal to 2. What degree is equal to 2? What will it do? It will create a new feature. Suppose I choose degree is equal to 2 while fitting polynomial regression into my model, into my x feature, means in my input column. Then it will create a new feature, x square. It will hold all the squares of the value. Suppose I chose degree is equal to 2 to fit this x column. Okay. So it will create a new feature, and all the values in x square will be its these values squares. Okay. Now suppose I choose x is equal to 3, then it will create two new features. Two new features. What it means? Suppose I choose degree is equal to 3. It will basically increase two features. One will x square and another one will x cube. In x square, all the values will hold squares of these values, and x cube, there will be all cube values of these values. Okay, this is how polynomial regression works. Okay, and then we apply linear regression on the new features. Okay, to create a model. Now we will see this using Python practically. For Python, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. Once it will downloaded in your system, just search Anaconda prompt, write cd, give your file location. This is my file location. Press enter. Write Jupyter Lab. Press enter. It will open Jupyter Lab into my browser. I will choose this. I will choose this. I will rename this polynomial regression. I will import my required libraries. Okay. plot as plt import cbond as sns. Okay. Now I will load my data set. Okay. Data is equal to pd dot read slash csv because I have csv file. This is my file. I will right click copy path control V. Now I will check my data is loaded or not. Okay. So yeah, my data gets loaded and these are my first three rows. Okay. Now, first I will plot a graph to show you that this data set, this input and output column is not following linearity. Okay. Suppose plt dot scatter data. I will take my first column, control V. I will take my second column. Now, now plt dot show. Now you can see this is making a curve like curve. Okay, this is not a linear line. This is not a linear line. Okay, so it is not following linearity and it is basically making a curve. So we will have to apply polynomial regression before making our model through linear regression. Okay, so first first I will divide my data set into input and output. So we all know this is my input column and this is my output column. Okay, suppose x is equal to data. I will take this input column into my x variable. Now in y variable I will take output column. Okay, so I have separated input and output columns as x and y. Now I will import my polynomial regression scalar dot pre-processing import polynomial features. Polynomial features. Okay. Shift plus enter. Now, suppose I will make a object to call my polynomial features. Okay. Now we will have to give degree. Suppose I will give degree is equal to 3. What will degree is equal to 3 do? It will give two new features to my input column. Two new features, x square and x cube. X square in x square feature, all the values will be these values square in second column x cube, all the cube values of these values will occur. Okay, so suppose I will take degree is equal to 2, then it will create a single new feature for my x feature, which will be its squares. Okay, so I have taken suppose degree is equal to 3. Now I will fit my x column because that is my input column x. Okay. Now I will transform my x dot transform. Okay. Now my input column, I have taken my input column into x variable. By degree is equal to 3. I got two new features, means two new columns for my x column, means input column, x square and x cube. In x square, there will be my squares of these values will occur, and in x cube, cubes of these values will occur. Okay, so I got my two new features, and total I have now three features. Okay, three input columns now I have by using polynomial features, right? Now, now I will now I will build the model using linear regression. Okay, from scalar dot. First, I will basically divide the dataset into training dataset and testing dataset. Okay, into suppose 80% and 20%, 80% for my training and 20% for my training. So first I will import train test split model selection, import train test split, right? Now, now I will take my all four variables x train, x test, y train, and y test, and I will fit by train test split. I will call basically train test split. I have taken x and y column. Now I want 20% of the data set will be my testing data set. So I will give test size is equal to 0.2. Now random state is equal to 42. Okay, this is how we divide the data set into training data set and testing data set. Now my data gets divided into training data set and testing data set. Okay, so I have already covered train test split in my video. You can check the video. Okay, now I will build my model from scalar dot linear model import linear regression linear regression. Okay, suppose I will take an object. I will take an object to call linear regression. Okay, now I will fit my X train and Y train into my linear regression for basically training the model by my training data set, right? X train and Y train means training data set of temperature means the input column, and the training data set for my Y column means output column. Okay, LR dot fit X train and Y train. Okay, I'm training my model by my data set of training data set. Okay, it my model gets trained. Now I will check my accuracy of my model. Okay, X test. I will check my accuracy by testing data set into 100 into 100. Now I got an accuracy of 84%. That is not so much good accuracy, but although we got the understanding of polynomial regression and then how to fit it by linear regression. Okay, so we got to know the concept of polynomial regression, right? now now I will show you a graph through which I will describe how it tries to basically draw a curved line to best fit the predicted data, okay, to actual data, right? plt dot scatter. I will take this. I already plotted graph. Okay. Now, now I will give a red line. I will again take this. Okay. Now, suppose I will make a new variable first. Predict. Okay. PRD. Predict is equal to LR dot predict my X column. Okay. Okay. I will make this PRD and I will give color as red. I will give my line as color red. Okay. Now, now I will show reality dot. Okay. Okay. I forget this. Okay. Now see. So first we had a data set in which input columns and output columns were not following linearity. It was making a curve. So it tries to predict by making a curve line, making a curve line to predict the data. Predict the data. It tried to it tried to be as close as possible to actual data point. These blue data points are actual data points, and this is a prediction line. So that's how polynomial regression works. Okay, so this is how we do use polynomial regression. Okay, for non-linear data. Okay, non-linear data. Okay. So that's all in this video. In the next video, we will see regularization techniques. So thank you. Hello guys, welcome to the channel. Today we will discuss regularization techniques in linear models. Okay. So first, what is regularization? Regularization is a technique used to reduce overfitting in machine learning models. What is overfitting? Overfitting means modern learned noise plus patterns perform poorly on new data. What it means? Always remember, a good model learns only the real pattern. An overfitted model learns everything, including noisy data also. So we just need to train the model on the real pattern. Okay, not on noisy data, means everything. And overfitting means suppose I have a data set and of how many hours you study and how much marks you get. Suppose I have data set, someone studies for 1 hour and he got 40 marks. Someone studied for 2 hours, got 50 marks. And one value came, someone studied 1.1 hours and he got 95 marks. So that is right data. But in our case, that is an case of overfitting. We can't train our model on that particular data. So this is what overfitting and what regularization do adds a penalty to the model to keep it simple. Simple. It will add a penalty to the features so that our model will be simple and will be only gets trained on basically the real patterns, not noisy data. Okay. So why regularization is needed? Model becomes too complex. Okay. Suppose you have a case of overfitting and underfitting both in your data set. Some not necessary features or columns in your data set. Okay. Coefficients become very large. Model model memorize instead of learning. But every model should learn, not memorize the data, right? So so how we can perform regularization? We have two methods. Okay, for linear model. Okay, for linear model. First, L1 regularization means lasso regression. Okay, it adds absolute values of coefficient and can make some coefficients exactly zero. What it means? Suppose I have this data set, okay, and this is my output column, okay. On the basis of this till H column, these are my input column. On the basis of this input column, this output column is changing, right? So, suppose I have this data set. Okay, I have this column. Okay, and it is not adding any like major changes to my this output column. Or this is in simple words. See, suppose this column is not necessary for me. Okay, it is just increasing the complexity of my model or of my data. Okay, so what lasso regression do? It will make all the coefficients equal to zero. It will make this column as zero. Okay. So, so basically by this method, model automatically does feature selection. And what is feature selection? How to do feature selection? I have already discussed. You can check my video. Okay. Okay. It basically removes unnecessary features. What this method actually do? Removes basically unnecessary features like suppose this is my unnecessary feature, it will remove them. Okay, so this method, we understood what it do, see, when to use when you have many features. Okay, and when you want to remove useless features, right? Now second, L2 regularization, which regression. Okay, it adds a square of coefficients, strings value, but never makes them zero. It makes the coefficient zero, but it never makes the coefficient zero. Remember that. Okay. It adds square of coefficient. What it means? Keep all features but reduces their impact. When to use? When all features are important, means all the columns of your data is important. You have to take all the data, then you can apply this method. And okay, suppose, suppose this is my data. Okay, this is my column, input column. Okay, so you can see weight of this column is too much. Okay, too much weight of this column. When we will apply this method, ridge regression, it will reduce the weight of this input column. It will not make them zero because this is the necessary column for me. Okay, so it will reduce the weight of the column. Okay, now, now we will see how we can do it practically. Okay, so first I will copy my file location. I will search Anaconda prompt. DB, okay, enter, write Jupyter Lab. It will open the Jupyter Lab into my browser. I will wait for a few seconds. Now I will choose this. I will rename this regularization techniques. Okay. Now, first I will import some required libraries. Import numpy as np. Import pandas as pd. We are not importing matplotlib and cbon because I have not to uh, basically I have not to draw a graph, so I will not import that. Now I will load my data set. Data is equal to pd.read slash csv because I have csv file. For every video, I'm giving the data set. So this is my data set. Right click, copy path, control D. Now I will check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and these are my first three rows. Now, first I will check is there any null value before performing any operation on it. Yeah, I have 207 null values in total bedrooms column, right? So I will fill that first data dot fill and sorry, I have to fill this dot fill and suppose I will fill by the total bedrooms median. Okay, how we can do that? I will again take dot fill total bedrooms null value dot fill and by its median. Okay, in place equal to true. Okay, this is an warning. This is not an error. Okay, now suppose I will I will draw a heat map. Okay, I will plot a heat map. Okay, put map plot dot pyplot as plt import cborn as SMS. Now, now I will show you by plotting a heat map to show you how my features are affecting my output column or not. Heat map. I will take data as my data's correlation, not is equal to true. PHP dot show. Now, see longitude minus 0.046. So that is not affecting my data, right? So this is a useless feature for me. Latitude also same. House, median, age. This is affecting my output column a little bit. This is also affecting my output column a little bit. It is 0.049, I think. So this is also not that much useful for me. This feature population 0.025 minus 0.025. So it is a useless column for me. Households again, that is not a good feature for me. And median income, yeah, this is 0.61. Yeah, this is an important column for me because it is nearly 1. Okay, so now I will first divide my data set. into two parts, input and output. This is my input column and these are my this is my output column and these are my input columns, right? I will take all the input columns into my X, suppose data dot drop. I will drop this only output column. I will enter. I will write x is equal to 1 and y is equal to data. I will take the output column. Sorry, it is already copied. Okay. So I have divided my data set into input and output. Now I will do basically feature scaling by standardization. I have already discussed in detail how to perform feature scaling using standardization. You can check the video. Okay. First, from a scalar dot model selection import standard scalar. Okay, scalar. Okay. Okay. For that, it's processing. Okay. Now, now suppose I will create an object for calling standard scalar. Okay. Now I have to fit my standard scalar for my x because all the input values are in my x. So I will fit my x to a standard scalar. Okay, it gets fitted. Now, now I will import this into a data frame. See the transform x columns is equal to x x dot columns, right? Now, now I will divide my data set into training data and testing data. Now suppose I will divide my data set into 80% for training data and 20% for testing data. I will all these things train test split standard scaling or all these things I've already discussed. You can check my previous videos. Okay, I will check. I will give all the four variables y train y test is equal to I will sorry, first have to I will have to import train test split from SQL1 dot model selection import train test split. Now I will call my train test split. I've taken x and y variables. So I will give that. Now test size means how much we need testing data 20%. So I will write test size equal to 0.2 and I will give random state is equal to 42. Okay. Now my data gets divided into training data and testing data also. Okay. Now I will first make a model, then I will apply these two methods, ridge regression and lasso regression. Okay. So first I will import scalar dot linear model, import first I will import linear regression, lasso and ridge. Okay. I will import all this. Okay. Now first I will make a make an object to call my linear regression. Okay. Now now I will train my model. How I can train lr dot fit my training data. By training data, I will train the model. So it gets fitted. Now I will check my lr dot score. Okay. Y test into 100. So yeah, this model is giving accuracy of 61, which is very low accuracy, right? So this means we need to apply these methods, okay, for controlling our model to remove basically not unnecessary columns, or we need to remove the weights of the columns, right? Suppose I will give the matlab, uh, I mean I will check the coefficient means uh, it will give the weight of each feature in the model. Each feature means each column in the model. Okay, it will give the weights of each feature in the model. So yeah, it gave me it gave me the weights of each feature. Okay, so this is how you can see the weights of each column of my input column, right? So now I will show you. First, we will calculate how wrong is my model. Means mean absolute error, uh, mean squared error. Okay. So first, I have to import from sklearn dot matrix import mean absolute error and mean squared error. Okay. I have imported this. Now, first, I will calculate mean squared error. Means how much is the difference between my predicted value and the actual value. And I will do means mean squared. squared error means square that value. Give basically, suppose I got 2, then just square 2 means I will get 4. Okay, so mean squared error, just the difference between my actual value and the predicted value. Okay, mean squared error. Sorry, y test L, and I will take LR dot predict X test, right? I will see my MSC. So yeah, I got my mean squared error. It is too much high. Now, now I will calculate mean absolute error. Okay, average of absolute errors. Okay, average of absolute errors. Let's take MA is equal to mean absolute error. Same I will with this. Now I will see my MA. So yeah, I got my mean absolute error. Mean average of absolute errors. Okay. Now I will calculate RMS is equal to first I will have to import numpy. Yeah, I have already imported numpy. Okay. RMS is equal to NP dot square root means our actual error. Okay. Actual errors mean. Okay. Means we have squared for MSC the mean of the squared error. I have squared the error, right? Basically, the difference between my predicted value and the actual value. I received that for whole columns, and then I received my mean, and then I squared this. Okay, now I will calculate its actual error mean. Okay, actual error mean. So actual error mean is this. Okay, without doing a square of this. Okay, now I will we will see how to apply these regularization methods for my linear model. Okay, now first is my lasso regression, right? I will first see lasso regression first. LA, let's take LA, call lasso alpha is equal to 0.5. What is alpha 0.5 means? Means uh, applied moderate penalty to the coefficients. Okay, coefficients mean the values of my feature. Okay, moderate means not too much low, not too much high. Apply the penalty for my coefficient for the feature. Okay, moderate penalty I'm applying. Okay, now now I will just do LA dot fit. What I will fit X train and Y train, right? Okay, yeah, it gets fitted. Okay, so we saw how to use lasso, right? And now we will see ridge regression. Only difference is alpha we have to choose. Okay, in this suppose I have to do strong regularization. Okay, so I will choose alpha is equal to, let's say, 10. Okay, sorry, again, I will suppose take Ri, and here I will write ridge. Okay, now I will fit my X train and Y train into ridge. Sorry, Y train. Okay, it gets fitted. So this is how we ap- we perform lasso and ridge for regularization. Okay, so that's all in this video. In from the next video, we will see logistic regression. Okay, thank you. Hello guys, welcome to the channel. From today, we are starting our classification algorithms, and our first algorithm is logistic regression. Okay, so what is logistic regression or what is classification? You can understand by this. Okay, logistic regression is a supervised machine learning algorithm used for classification problem. So understand what is classification problem. Basically, it predicts categories or classes instead of continuous value. We saw in our regression algorithms like linear regression, multiple linear regression, we predicted continuous values like 5, 10, 20, like this. Okay. Now we will predict categories or classes. What it means. Suppose example, spam or not spam, pass or fail, disease or no disease, yes or no, customer will buy or not buy. Okay, these are examples of categories which we will predict by classification algorithms. Okay, so the output is usually 0 for no and 1 for yes, means false and true. Okay, now you can understand logistic regression through this graph. Now we have 1 and 0 predictions, no, yes, or false or true. Means suppose this is spam, means true. This is not spam, false. Okay, pass, true, fail, 0. Okay, so it will always predict from 0 to 1. Okay, so we saw in our uh, basically linear regressions models, we saw linear graphs or non-linear graphs. In this type of algorithm, we will always see it will basically draw as curve as curve. Okay, it will draw as curve to predict the values, predict the basically categories 0 or 1. Okay, so we will perform our logistic regression on this data set. This is input column and this is output column. Means suppose I am 19 years old. It has a chance to that something I will not purchase. Someone of age 35 will not purchase. Someone of age 32 will purchase. This is that kind of data set. Okay. So I will show you how we can do it practically. Okay. Now, first I will import some required libraries. Import numpy as np, import pandas as pd, import matplotlib dot pyplot as plt, import cbon as sns. Now I will load the data set. Suppose data is equal to pd dot read slash csv, because I have CSV file. Suppose this is my data set. I will right click, copy path, control V. Now I will check my data is loaded or not by checking its first three rows. So yeah, my data gets loaded and this is my first three rows. Okay. Now I will first plot a graph to show you how the graph of classification problems looks like. Okay. PLT dot figure fixed size. I will take some size for my graph, 4 3 suppose. Now I will plot a scatter plot. I will plot a scatter plot. Suppose I will take x is equal to age, my age column, and y for purchased column. Okay, purchased, purchased. Okay, and data. What is my data? Data is my data because in data variable I have stored the data, right? So I will write data. Now plt dot show. So for 1 and for 0, this is how it looks like. Okay, 0 1, sorry, 1 and 0. Okay, means purchased, no, they will not purchase for 0, and yes, they will purchase for 1. Okay, now first I will basically divide my data set into input column and output columns. Age is my input column and purchase is my output column. Suppose x is equal to, I have taken my input column. What is my input column? Age. And for y I will take my output column. Okay, okay. Now I have taken input column and output column separately. Okay, now i will I will divide the data set into training data set and testing data set. Training for training my model and testing for testing the model after building the model, right? So first I will import train test split from sklearn dot model selection import train test split, right? Now I will take my all four variables x train, x test, y train, and y test is equal to, I will call my train test split. Okay, for which columns, which variables I'm splitting, x and y. So what in what ratio I want to divide my data set? I want my data set into 20% for the testing data and 80% for the training data. So I'm taking 20% as my testing data. So I will write test size equal to 0.2. Now I will write random state is equal to 42. Okay. These things I have already discussed in detail. Now my data gets divided into my into my training data and testing data. Okay, now I will build my model from sklearn dot linear model import logistic regression. Okay, logistic regression. Now suppose I will make an object to call logistic regression. Now I will fit my lo- uh, training data set into my model X train and Y train, right? Now it gets fitted. Okay, it trained my model. Now I will check my accuracy of the model. Okay, lr.score X test comma Y test into 100. So yeah, I'm basically getting 91% accuracy, which is quite high accuracy, which is good. Means our model is good. Okay. Suppose I will check by predicting a value. Suppose I will check 19. Okay. I'm taking 19. Okay. So let's see what it predicts. Sorry, I forgot to put parenthesis. Yeah. So yeah, it gave me 0. Okay. So see here. It was 0 here also. Okay. And it predicted also 0. So yeah, my model is working good. Now I will show you how it predicts, how it draws a line for predicting values for 0 and 1. Okay. I will I will show you a prediction line on this. Okay. I will show you a prediction line on this graph. Okay. So suppose I will take first figure size. Figure size is equal to 4, 3 I'm taking. I'm making a small graph. SNS dot scatter plot. Suppose I will take age in X and Y for LR dot predict X, LR dot predict X, and I will take data is equal to data, because in data variable I have data set. Suppose I will give some color of my prediction line as red. Okay, I am giving red. Okay, now plt dot show. Okay. So okay, first give you I will plot this also. Purchased also. I will plot purchased also first, and I will give here line plot. Line plot. Okay. Purchase. Okay. Sorry. Yeah. So this is how I will not take color in this. I will use default color blue. So yeah. Now you can see how it predicted the values, how it predicted the output as user will purchase or not, 0 and 1. How this it makes, how it makes this prediction line. So this is how logistic regression works. Okay, that's all in this video. In the next video, we will see binary classification, multi-class classification. Okay, so thank you. Hello guys, welcome to the channel. Today we will discuss binary classification. So what is binary classification? Binary classification means there are only two possible outputs or classes. What it means? Suppose I have some problems. Spam email detection. There are only two possible outputs here. Email is spam or email is not spam. Disease prediction means patient is suffering from that disease or patient is not suffering from disease. Customer churn. Customer will stay or customer will leave. Loan approval. Loan will be approved or loan will be rejected. So as you can see, there are only two outputs here, only two categories here. So this comes in binary classification where we will have only two type of outputs or two type of categories. Okay. So what is the goal of binary classification? The goal of binary classification basically in this model learns patterns from the data which will uh, we will give the training data to basically build the model. It will learns the patterns from that training data and then predicts which of the two classes the new data belongs to, means the testing data. When we will test our model with new data, then it will predict from which class it belongs to. Okay. For example, input email text. It will predict email is spam or not spam, right? So this is my data set on which I will apply my classification algorithm. As you can see, this is my output column. You can see only two categories here, 0 and 1. So as you can see, what this data set means from the CGP of a student and academic performance of a student, we are predicting the student will get placement or not. That's what we are predicting, right? So here there are only two chances. A student will get placed or a student will not get placed. Okay. So how we can predict that using Python. Okay, we will do this in practical way. Now, first I will import some required libraries as PD. Okay, now I will load my data set in data variable pd.read slash csv. Now I will give the path of my file, my CSV file, right click, copy path, control V. Now I will check my data is loaded or not by checking first three rows. Data.head 3. Yeah, my data gets loaded and these are my first three rows of the data. Now, first I will basically divide the data set into input and output. So placement is my output column and these are my input columns, right? So in X variable, I will store my input columns, input column rows, and in Y, I will take placement, which is my output column, right? Now, data, I will use ilog. I'm saying, give me the all rows of the data, give me all the columns also, but don't give me the last column, -1. Don't give me the last column because it is output column, okay? For Y, I will simply go for the data and take this column. Control C, Control V. Okay. So we will get all the input columns into X and output columns into Y. Now, my data gets divided into input and output. Now I have to divide my data set into training data set and testing data set randomly. Okay. Now, so I will import train test split, go to model selection, import train train test split. Now, now I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split. These are the things I have already covered in detail. You can check my previous videos, x and y, for which variables or which columns, for which columns we are dividing the dataset into train test for x and y, because in x and y I have stored my input and output column. Now I will take test size, sorry, test size is equal to, suppose I want to take 20% of the dataset as my testing dataset. So I will write 0.2 and random state is equal to 42. Okay. So my data gets divided, right, into training, into 80% for the training data and 20% for the testing data randomly, not sequence wise. Randomly it gets divided. Okay. Now, now I will import my logistic regression because it is a problem of classification. Learn dot linear model import logistic regression. Okay. Now I will make an object to call logistic regression. Suppose LR is my have given for calling my logistic regression. Now, now I will fit my training data set into the model logistic regression. LR dot fit logistic, sorry, X train comma Y train, right? Now it gets fitted. Right? Suppose means my model gets trained from my training data, right? Now, now suppose I will check accuracy of my model. I will check by giving X test and Y test into 100. Now we got 83% accuracy, which is not that much good accuracy. We will see what are the operations to basically make accuracy better in upcoming videos. But now you can see how we can build a model for binary classification. Now suppose I will predict a value. LR.predict. I will predict, suppose I will give 6.28 and 8. Okay. 6.28 and 8 values. Okay. 6.28 and 8. So we got 0. And here it is also 0. Okay. So we got the right value. So this is how we build model for binary classification. Okay. So that's all in this video. In the next video, we will see multi-class classification, in which we will have multiple classes, not only two classes, or not. We will not have only two categories. We will have multiple categories. Okay. So we will see in the next video. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss multi-class classification. So what is multi-class classification? Multi-class classification is a type of classification where target or output has more than two classes or categories. Okay, what it means? We saw in our previous video in binary classification have we always have two categories in our output. Okay, but in multi-class classification, we will have more than two categories or classes in our output. Suppose I have some problems like animal detection. So I have these classes in my output, cat, dog, horse. In exam grade prediction, I have A, B, C, D, more than two. Flower prediction for iris dataset, we have three categories, right? So basically in multi-class classification, we will always have more than two categories, right? So you can understand the basic difference between binary classification and multi-class classification by this graph. In binary classification, there are only two classes, and in my multi-class classification, there are multiple classes, more than two classes, right? Now, now when we use logistic regression algorithm for multi-class classification, we can basically logistic regression can apply by logistic regression we can apply a total three approaches for our multi-class classification problem. Okay, first one is multinomial method, one versus rest, OVR method, and direct method. Direct method generally which already we saw how to like apply logistic regression directly. Okay, so first one, what first method do? Multinomial method. Multinomial method basically it all basically it handles all classes at the same time. All the classes. Suppose I have three classes, total three type of categories in my output column. It will basically treat all the classes at the same time. Okay, instead of creating new models for all classes. Okay, class one, class two, class three simultaneously. Okay. Now, suppose these are my classes in my iris dataset. I will show you the dataset. On this dataset, we will perform our logistic regression algorithm. This is the type of multi-class classification because see, here we are three categories in our output column, and these are its input columns. Four input columns and one output column, right? So we will apply on this, and this has three categories. So it comes under multi-class classification, right? So what it does, it will directly calculate probabilities for all three classes together. Suppose I got 90% probability for Setosa flower, and it will be higher than other two. Then our prediction will be Setosa because it has higher probability, right? So this is how multinomial method works. First, understand by theory. I will explain it by doing practically, but first understand it by theory. Okay. Second one is one versus rest, OVR method. The name itself suggesting OVR, one versus rest, means one class versus all remaining classes. For example, suppose I have three classes. It will create three different models, right? Three different models because I have three classes. If I will have four classes, then it will create four models. So first model will Satosa versus other, class versus other, model three, third class versus other two classes. And this is how it works. OVR method. Okay, one versus rest method. Okay. The name itself suggesting what it does. Okay. Direct method basically just apply logistic regression to you for your training data and test the model. Okay. So we will see how we can do it using Python. Okay. So first, look at the data set. On this data set, we will apply my logistic regression algorithm for all three approaches. And I have already explained why it comes under multi-class classification because it has three categories. Output column has three categories, more than two categories. Okay, so I will do it of its practical part. First, I will import some required libraries. Import pandas as 3D, import matplotlib dot pyplot as plt, import cborn as sns. Okay, now I will load my data set. Data is equal to pd.read slash csv because I have csv file. If you have Excel file, then you can write Excel. By the way, I will give you the data set. Copy path, control V. Now write. Check its first three rows. My data is loaded or not. Yeah, it is taking some time. Yeah, my data gets loaded and these are its first three rows. So my data gets loaded. Now I will show you its unique values. Means what are the unique values in my output column. Okay, data dot unique. Okay, so these are three different categories. These are three different categories of flowers we have in our output, and these are its input columns. On basis of these input columns, it affects our output, right? It will like decide my flower is setosa or versicolor, anything, any flower. Okay, now I will show you by plotting a pair plot how it is looking like uh, on these four inputs. I will show you. Data is equal to data because I have loaded my data set in data variable is equal to spaces I will give. Okay, of plt dot show. Now first look at the colors. Okay, setosa for blue, versicolor for green, sorry orange, and green for virginissa. So these are three different colors for different categories, different species of flowers. Okay, now look at sepal length, sepal width, and petal length, petal width. Okay, these are the four uh, basically inputs. These are the four inputs. Okay, so how it is looking like? Look at this. For sepal length, it has higher values. Means I have higher setosa for this. Look at this. This is how it's looking like, right? So I have shown you the how it is looking like, how it is separated, how it is like, how it is looking like into my graph. Okay, so now I will separate my data into input and output. I will use ilog. I will say give me all rows and give me all column, but don't give me the last column minus one. Last column because this is my output column and I will take my output column into Y. All the inputs input columns I have taken in X, and in Y I am taking output column. Okay. Now, now I will now I will divide the data set into training and testing data. Right. First, I will import train test split from scalar dot model selection, import train test split. Okay. Now, now I will take my all four variables: x train, x test, y train. These are the things I have already discussed. You can check my previous video of train test split is equal to, I will call my train test split for which variable x and y, right? Now I'm taking test size as 20%. I want 80% for my training data and 20% for testing data. So I will write test size is equal to 0.2, random state is equal to 42. Okay, now my data gets divided into training data and testing data. Now, first method was my multinomial method, right? Multinomial method. We will see that. I will give a markdown here. Multinomial method. I will choose markdown and shift plus enter. Now, my multinomial method. I will first give, first I will import logistic regression, sklearn dot model selection, sorry, linear model, linear model, import logistic regression. Okay. Oh, some spelling mistake. Okay. Okay. Now, suppose I will give an object to call my logistic regression. Now, here for multinomial method, because we are not applying a direct method, we are applying multinomial method. I will have to give, suppose, shift plus tab use. Now, see, here you have to use solver. Solver. Okay. For multinomial method, we will use this solver because this solver is fast, stable, and supports multinomial losses. Okay, this is because of it we are using this solver. Okay, now again when you will click shift plus tab, you will click here, then you will get this. Okay, max iteration. Suppose I will give 1,000. Let's say I will give 1,000. Basically, max iteration, if I will give 1,000, it will allow our model to train longer. Okay, this is what it means. Okay, I have explained both of this. Okay, so now step plus enter. Now, now fit your training data for your model X train, comma Y train. Okay, now my data model gets trained by my training data. Okay, now suppose I will check accuracy of my model, comma Y test. See, it is giving 100% accuracy. Okay, it is giving 100% accuracy because this data is very good data, iris data set. This is because uh, that's why we are getting 100% accuracy. See, we looked how multinomial method works, how we can use multinomial method, okay, and why it is used. Okay, now we will see OVR method. Okay, OVR method. Now, for first, again, I will give a mark now for using OVR method because I will give you the notes also. OVR method. For using OVR method, we will first have to import one versus rest classifier. Okay, from scalar dot multiclass import one versus rest classifier. Okay, now suppose I will give a second object lr2 is equal to I will call my one versus rest classifier. Now in this I will use logistic regression. I will use my logistic regression. Okay. Now, now in this we will suppose I will check shift plus tab. Now in this we will give our solver as linear. Okay. Suppose I will take this. I will take lib linear in. Why lib linear? Because linear basically works better for binary classification. Okay, binary classification means see what OBR method does. I have already explained one versus rest for basically three classes. It will build it will build basically three different models, and in one model it will it will check one class versus others, right? So that's why we are taking solver is equal to linear. It is better for binary classification. And I will again take max iteration as thousand so that my model gets trained longer. Okay, so if plus enter now. Now I will fit my uh, training data for my OVR method. Dot fit X test Y test. No, it gets fitted. Okay. Now Now I will check the accuracy again. LR2 dot score. I will give my X test, comma Y test, shift plus enter. Yeah, it is giving 86% accuracy. It is not that much good accuracy, but yeah, I am getting 86% accuracy in my OBR method. Okay, so for now, for my model, multinomial method is good. So from OBR method, we are getting slightly low accuracy. Now, direct method. Direct method is very simple. Just apply your logistic regression. Okay, I will give markdown, shift plus enter. Now, LR3 is equal to call your logistic regression. Okay, now fit your training data, X train, Y train. Now, check the accuracy. 3 dot score. We will give X test, comma Y test into 100. So it is also giving me 100% accuracy. So we saw how we can use different methods of logistic regression for multi-class classification. Okay, so we have seen all three methods for multi-class classification by logistic regression. Okay, so that's all in this video. For the next video, we will discuss confusion matrix. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss confusion matrix. So what is confusion matrix? A confusion matrix is used to check how well a classification model is performed. Okay, it compares actual values and real answers. Okay, my actual values and answers or outputs we are getting from the our model predictions. Okay, predicted values, model prediction. Okay, it compares this. Okay, it helps us to understand how many predictions were correct and where the model made mistakes. Okay. Now, suppose I have positive class is equal to 1, negative class is equal to 0. Okay. Then the matrix will be look like this. Actual 0, Tn, actual 1, predicted 0, Tn, predicted 0, Fn for actual 1, and predicted 1, Fp and T. What it means? True positive. Okay. TP means first TP means true positive. Means model predicted positive and it was actually positive. Okay. Next TN. True negative. Model predicted negative and it was actually negative. So these are two correct ones. Okay. Now false positive and false negative. FP. Model predicted positive but it was negative. Okay. Now, false negative. Model predicted negative, but actually it was positive. Okay. So these two are for calculating wrong and these are for calculating right. Okay. Means these two are for giving right output and these are two for giving wrong outputs. Okay. Now, now for confusion, when we will build confusion matrix, we will get these four values. Okay, how much true negatives, how much false positive, how much false negative, and how much true positive. And these terms have these meanings. Okay, now on the basis of this confusion matrix, we calculate accuracy of the model. What is the formula of accuracy? Accuracy tells overall correct predictions. Okay, accuracy is equal to TP plus TN means all true means right outputs upon all the outputs. Right outputs means these two outputs upon all outputs. Okay. So this is the formula of accuracy. Now, precision. Precision means out of all predicted values, how many were actual positive? TP, we will take only true positive TP and upon TP plus FP, true positive and false positive. Okay. Same recall out of all actual positive, how many were correctly predicted? TP upon TP plus FN. TP means true positive and upon true positive plus false negative. Okay. And F1 is score. F1 is for balances, precision, and recall. These two. Okay. This is the formula of F1 is good. F1 is equal to 2 into precision into recall. Precision into recall upon precision plus recall. Okay. Got it? What is the meaning of these terms? Okay. So I will show you practically how we can use confusion matrix to perform these things, to calculate these things. Okay. First, I will show you how to calculate, how to create confusion matrix using Python. In Python, it is very simple. We can do by only scikit-learn. Okay, so we will see that on this placement data set, I will perform confusion matrix. Okay, so now let's see how we can do it practically. Okay, first I will import some libraries. Import cbond as SNS. Okay. Now I will load my data set. Data is equal to pd.read slash csv. I will give the path of my CSV file. This is my file. Copy path. Control V. I will check my data is loaded or not by checking first three rows. Okay. These are three. These are three are my first three rows. Okay. Now, now I will first divide the data set into input and output. For input columns, I will basically store in X and output column I will store in Y. I will I will use ilog, give me all rows and give me all column, but don't give me the last column. That is output column. Okay. Data plus enter. Now my data gets divided. Okay. Now now I will now now I will basically I will divide the data set into training and testing data. Okay. Now from scalar dot I will import train test split. Okay. Model selection, import, import train test split. Okay. Now, now I will divide my data. I will take my all four variables for dividing my data set into training data set and testing data set. equal to xy. I will take test size as 0.2. Means it means 20%. I'm taking the testing data from the total data, random state is equal to 42. Okay. Oh, sorry. I forgot to call train test split. Okay. Now my data gets divided into training data set and testing data set. Okay. Now, now I will build the model from sklearn dot sklearn dot linear model import import logistic regression. Okay. Now I will build the model. First, I will take an object LR. I will call logistic regression by this object. Now I will fit the training data into my model X train comma Y train. Okay, it gets fitted. Now, now I will check my score means accuracy. So 83%, 83.6% is my accuracy I got. This is what accuracy means true positive plus true negative upon all the addition of all these four values of all these four terms. Okay, so I have already described what is the meaning of these terms. Okay, now, now I have calculated the accuracy. Okay, now I will create a confusion matrix CF. Suppose CF is equal to first I will import this sklearn dot matrix import confusion matrix. Precision is precision score, recall score, and last one F1 score. I will import all these three, all these four from a scalar. Okay. Now, okay. Simple is a spelling mistake. Now, I have imported all these things. Okay. Now, let's say I will create a confusion matrix. EF is equal to, let's see, I will call this confusion matrix. I will take Y test LR dot predict X test. Okay. X test. Right. Now I will see it. Now see, I have created confusion matrix. Now we got all four values. What is the meaning of these four values? 1670 is your true negative. True negative means model predicted negative and it was actually negative. Okay, so this is the correct answers which I got 1670. Now 4 4 is equal is your FP false positive means model predictive positive but actually it was negative. Okay, so there are total four values like this. Okay, 324 is your false negative means model predicted negative but actually it was positive. Okay, so how many values are like this? 324 values are like this. This is very high value, high number of values. Okay, 2 2 is your true positive means model predicted positive and it was actually positive. So there are only two values for this. Okay, so this is a quality of like a poor model. Okay, this is not a good model. Okay, this is what I got from creating confusion matrix. Okay, now 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 I will calculate all these things: precision score, recall score, and F1 score. Okay, first I will give a markdown that for a good model, all these values should be high. Precision score, recall score, F1 score, all these values should be high for a good model. Okay, I will write this. All these values should be high for a good model. Okay, I will give a markdown. Shift plus enter. Okay, now I will calculate all these things. Okay, I will take this. This is an score. Sorry, same. I will take y test. I'm comparing from what test and what my model predicts. LR dot predict for X test means our training. Which I basically what are my X test? My X test is the testing value of my input call. This is what my X test. So what is my model is giving prediction for those X test. X test into 100. Only 33.33. This is very low. So this is a sign of this is not a good model we have. Okay. Again, now this time I will calculate recall score. Only 0. See, I have multiplied it by 100. After that also, I'm getting 0.61. Again, this is very low. So this is not a good sign for my model, which means this is not a good model which we have built, right? Now, last one I will calculate F1 score. I've already described these terms: true negative, true positive, false positive, and all these things. Accuracy, precision score, recall score, right? Now, I will again take this. Now, see, only 1.20. This means if these values are not high in classification algorithms, then this model is not good. Okay, these values should be these all values: accuracy, precision score, recall score, F1 score. All these four values should be high. Then only we will think we will get a good model. Okay, so we got the we have discussed the confusion matrix topic, and all these confusion matrix, precision score, accuracy, recall score, we have discussed. Okay, now in next video, we will see how to deal with imbalanced data set. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss imbalanced dataset and how to handle imbalanced dataset. An imbalanced dataset means one class has much more data than the other class. What it means? Suppose from a dataset, I am predicting patient have that disease or patient do not have that disease. Okay, so in our dataset, 950 data points for zero category means no disease category. Okay, there are 950 data points, mean 950 rows, and only 50 rows or only 50 data points are for one. So this is much higher than this one, one for disease. Okay, so this is a kind of imbalanced data set. Okay, this one category has much higher data points than this one. So this is a kind of imbalanced data set. So we need to fix it. Why do we need to fix it? Because when you will build the model on this kind of data set, then model will predict more in most of the cases zero, because this data point has um, this zero has much data more data points than this one. Okay, so it will predict in most of the cases zero. Okay, so that's why we need to fix imbalanced dataset. So there are two ways to fix imbalanced dataset. First is oversampling and second one is undersampling. Understand what oversampling do? In oversampling, we increase minority class samples, add more data to smaller class. What it means? This is our minority class, right? This is the we increase minority class and more and add more data into smaller class. This is our smaller class or minority class. We will add more data points to this one by oversampling. Okay. And what is undersampling? We reduce the majority class samples and remove some rows from larger class. We will basically delete some data points from majority class, means the larger class. Okay, to fix imbalanced data set. So I will show you how we can do it practically. On this data set, I will perform oversampling and undersampling. Okay, this is our input column, age, and purchased or not purchased. It is my output column. Okay, so we will see how we can do it practically. First, I will import my pandas library. Okay, now I will load my data set. This is my data set. Copy path, control B. Check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and these are its first three rows. Okay. Now first I will show you how many zero, how many data points for zero and how many data points for one in purchased column. Okay. Dot value counts. Okay, so here you can see I have data points, 257 data points for zero and 143 data points for one. Zero have some higher data points than 1. Okay. So this is a kind of imbalanced data set. So we need to fix this. Okay. First, I will divide my data set into input and output. Age is my input column and purchase is my output column. Age is my input column and purchase is my output column. Okay. Now I have divided my data set into input and output columns. Okay. Now, now I will split my data set into training data set and testing data set. Okay. Dot model selection import train test split. Okay. I will I will take all four variables for splitting my data set into training data and testing data. Okay. X train, X test, Y train, and Y test is equal to, I will call my train test split X and Y variables in which I have divided my data set into input and output. I will take test size as 20%. I will write 0.2 and random state is equal to 42. Okay. Now, now I will build the model from a scalar dot linear model import logistic regression. Okay. Now I will create an object to call my logistic regression. Now I will fit my training data into logistic regression. Okay. Now it gets fitted. My model gets trained. Now suppose I will check my accuracy of the model into 100. So I'm getting 91% accuracy, which is a good accuracy. But although this is my imbalanced data set, we saw the values 257 data points for 0 and only 143 for 1. So we need to fix it. First, we will see our undersampling method. Okay, undersampling method. Under, I will give a markdown. Okay, and undersampling. What we do in undersampling? Undersampling, we reduce majority class samples, means we will decrease this higher data points category, okay, in undersampling, okay. Now, from IMB learn, IMB learn means imbalance learn dot undersampling import random under sampler. I will import this. Okay. Now, now suppose I will make an object to call random under sampler. Okay. Now, now I will create a new RU X and RUY for different input and outputs. basically resample my x and y, which is my x and y have x have input column and y have output column. I will resample it. Okay. Dot get resample x and y, x and y. Okay. Now, now we will check value counts for RUX and RUY. Okay. Now, sorry, for RUY, because RUY will have the output column. Okay. Y dot value count. Now see, it has decreased to 143. See here. I had 143 data points in hour 1 and 257 for 0. So in undersampling, we decrease the higher data, which higher data points, which category have higher number of data points. We decrease that in undersampling. So what we did, we decreased the data points of zero category. Okay, zero category. So now it has equal number of data points. Okay, so we have decreased the data points of higher number, higher number of data points. Okay, in zero. Now second one is our, now you can basically split the data set on the basis of RU and RUX and RUY. I have resampled it. So here you can give RUX and RUY. Okay, and you can give LR2 is equal to logistic regression, and now you can fit the data into new four variable, basically new X train and Y train, because we have resampled X and Y. Okay. Okay, it gets fit. Okay. Now my second method is oversampling. Okay, I will give a markdown. Sorry, I will give a markdown here. Shift plus enter. Now, what we do in oversampling? In oversampling, we increase minority class samples. Means we will increase the data points of one category. Okay. Now, how we can do that? Same, I will copy this from learning, imbalanced learn. Sorry, oversampling. I will be oversampling, and I will import random oversampler. Okay, I have imported this. Now suppose I will create a new object for this. RO is equal to. Now I will call random oversampler. Okay. Now I will create new X and Y. ROY is equal to, again we resample RO dot fit resample. What we will resample X and Y, in which I have given input column and output column. Okay, resample it. Now I will check the value counts for my ROY value counts. Now see, what we do in oversampling, we increase the uh, less number of, basically we increase the data points of that category which has lower number of uh, data points. In our case, one has lower data points. So here you can see now both have equal 257 and 257. In beginning, we had 257 for 0 and 143 for 1. So I have increased the data points of 1, and in undersampling, I have decreased the data points for 0. Okay, this is what oversampling and undersampling do. Now again we can do same. Okay, here I will give ROX and RON. Okay, now I can build a new model. So I will give LR3. Okay, now again I will fill LR3 dot fit extend wide. Okay, now so we saw in this video how we can handle imbalanced dataset using undersampling and oversampling. In undersampling, we decrease the higher number of data points category into lower, and I have increased the data points of lower number of data points category. Okay, okay. So in next video, we will see naive Bayes algorithm. Okay, so that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss naive Bayes algorithm. So what is naive Bayes? Naive Bayes is a classification algorithm based on probability and the Bayes theorem. We all studied Bayes theorem in probability and statistics, and it predicts the class or category of data using probabilities. Remember, using probabilities. Okay. For example, spam or not spam email, positive or negative review, disease prediction, news category prediction. So this is on which naive Bayes algorithm works. Okay, this kind of examples. Okay. So what is Bayes theorem? Bayes theorem is A by B is equal to PB by A into PA upon PB, where P A by B is equal to probability of A given B, P B by A is equal to probability of B given A, and PA is your prior probability and PB is your total probability. We have all studied Bayes theorem. Okay. Now, there are three types of naive Bayes algorithm which you can use practically. First is Gaussian naive Bayes, second one is multinomial naive Bayes, third one is Bernoulli naive Bayes. So now we will see when we use three different types of naive Bayes. So when we will use Gaussian naive Bayes, when data is continuous numerical data. Continuous numerical data. Data follows normal distribution, means bell curve. Okay. For example, our features will be height, weight, right? So in this kind of things, we will have continuous numerical data. So we can perform Gaussian and beyond that. Okay. Now second one, multinomial neighbors. When we will have textual data, text data. Okay, data is discrete or count based. Okay, so it is mostly used in natural language processing. Okay, so we will cover that also. Bernoulli and Bernoulli neighbors, when we will have binary features, for example 0 1 true false yes or no, then we will use Bernoulli neighbors. So I have explained when we can use Gaussian NB, multinomial NB, and Bernoulli NB. Now, I will show you how we can perform these three on basically practically on a data set. So I have this data set on which I will perform all three types of naive Bayes algorithm. Although it will not like satisfy the condition for some algorithms. For example, Gaussian NB, it is like satisfying the need for Bernoulli NB because I have 0 1 category here, only two categories, binary features I have. So yeah, but although my objective is to basically give you an idea how we can perform these three different type of naive Bayes algorithm practically. Okay. So now we will see how we can do it practically. Okay. First, I will import my pandas libraries, pandas as PD. Now, I will load my dataset pd.read/csv. Now, this is my dataset. I will right click, copy path, control V. Now, data.head. I will check my first three rows. My data gets loaded or not. Yeah, my data gets loaded. Okay. Now, now I will separate my data into input and output column. In X, I will take all input columns, these two columns, and in Y, I will take our output column. Okay. X is equal to data. I will use ilog. I'm saying give me all rows, give me all columns, but don't give me -1 means last column. Okay, because this is my output column. I will take my output column into Y. Okay, I will copy it. Sorry. Okay, now shift plus enter. Now my data gets divided. Okay, into input and output. Now I will divide my dataset into training dataset and testing dataset. I will take 80% for the training and 20% for the testing. Okay. Now I will import train test split dot model selection import train test split. Okay. Now I will take my all four variables x train, x test, y train, and y test is equal to, I will call my train test split for which variables x and y. I have taken my input and output. I will give test size as 0.2 because I want 20% as my testing data. Now, random state I will choose 42, right? Now, my data gets divided into training data set and testing data set. Now I will perform all three different types of algorithms of naive Bayes one by one for this data set. Okay. Now first I will import all three algorithms of naive Bayes sklearn dot naive Bayes naive Bayes naive Bayes import first Gaussian NB. Second one is our multinomial NB. Multinomial NB. I've already explained when we use Gaussian NB and multinomial NB and Bernoulli NB. Okay, but I'm just showing you on this data set only by applying all these three algorithms. Okay, Bernoulli, Bernoulli NB. Okay, I think I have did some spelling mistake here, so I will just copy paste. Okay, double L. I think I missed double L. Okay. Okay. So I have imported all this. Okay. Now, first, suppose I will make an object to call Gaussian NB. G and B I have taken an object. Okay. Gaussian tab. Now, we can call it. Okay. Now I will fit my X train and Y train into Gaussian NB, X train and Y train. Okay. Now it gets fitted for my Gaussian NB. Okay. Now I will show you suppose accuracy of my model. Okay. For X test, Y test into 100. Suppose I will show you the accuracy of training also. Okay. I will give train. Okay. Now, so 83% accuracy we are getting for our testing and training goal. Now I will use multinomial MNB is equal to, I will call my multinomial. Okay. Now I will fit, I will fit my training data for multinomial here. I will just, okay. Yeah, it gets fitted. Now suppose I will check the accuracy for this MNB and MNB. So same accuracy it is showing. Okay, for my Gaussian NB and multinomial NB. Let's check Bernoulli NB. BN Bernoulli. Okay. Now suppose I will fit my training data for Bernoulli. Now BNB. Okay. Sorry. BNB. Okay. Yeah, it gets fitted. Now suppose I will check my accuracy for Bernoulli. Yeah, it is giving accuracy for all these three algorithms of naive Bayes. Okay, so we saw in this video how we can use different types, three different types of naive Bayes algorithm. When we use these three different types of algorithm, in which cases I explained already. Then we checked how to use these three different types of algorithm, Gaussian NB, multinomial NB, Bernoulli NB on a data set. Okay, so that's all in this video. In the next video, we will start our non-linear supervised learning algorithms. Okay, so that's all. Thank you. Hello guys, welcome to the channel. Today we will discuss what is non-linear supervised learning and how to use decision tree algorithm for classification. Okay, now first, what is non-linear supervised learning? Non-linear models can learn curves, complex patterns, multiple decision boundaries. Like in supervised, like linear supervised learning, we saw when we draw the graph between the dependent variable means your output and independent variable means your input. When we draw that graph, you saw linearity between them, right? But in non-linear supervised learning, like we will not see linearity, right? It may form curves, it may form the complex patterns, okay, anything. Like it will not follow linearity, right? So to counter non-linear supervised learning, we have some algorithms, okay, like decision trees for both regression and classification, random forest, SVM, neural networks, and KNN. These algorithms we use for non-linear supervised learning. Okay, now It means instead of drawing a straight line, they create complex regions. For example, see, this is a kind of graph. Assume that. Okay. Now you will able to see here there are two types of categories here, blue and red, right? So this is how these algorithms divide these two categories. Okay, divide the two categories. Maybe sometimes like it will not be accurate 100%. For example, you can see a blue is coming in red area, right? So this can happen. But overall, these algorithms, this is how they separate different different categories, different categories. This is how they separate, right? So for example, simply a real life example, we will see. Suppose you want to classify fruits. Okay. Rules means you have features. Means if color is red and size is small, it will be cherry. If color is yellow and size is long, it is banana. If color is green and round, then it is apple. Okay. So when you will basically draw a graph for these features and your output, it will not follow a straight line relationship, right? So this is where decision trees works and all these algorithms. First we will see decision trees, then we will cover these algorithms also. First we will see decision trees. Okay, so decision trees for classification. Okay, remember we are using for classification. I will show you for regression in the next video, but in this video we are using decision tree for classification. Okay, so what is a decision tree? A decision tree works like a flow chart. Okay, it asks questions step by step and reaches a final decision. Okay, what it means? Basically, understand in a simple language. Okay, suppose it will first create a condition. Is age greater than 18? Two possibilities, yes or no? Yes. Then again ask a question, if he is 18 years old or he or she is 18 years old, then they have a job? Yes. Okay. Yes, then loan is approved. If they not have a job, then loan is rejected. Okay. Now, if his age is greater than 18, we saw what are the different categories can happen by year. Now, simply if he or she is not 18 years old, he is or she is less than 18 years old, then loan will be rejected simply. So this is how they basically classify the problem into each step. How this is how decision tree works. Okay, tree keeps splitting data based on conditions. You can see example of decision tree. Age is greater than 18, divided into two parts. Yes, no. Yes, then income is 50K. It can be yes or no. It is no. Suppose age is less than 18, no, then reject. Income is greater than 50K. Yes, then loan approved. If income is less than 50K, then loan rejected. Okay, so this is how they basically classify the problem into each step. Okay, and reaches to a final decision, right? A loan is approved or not approved, right? This is how decision tree works. Okay, goal of decision tree, main goal, create pure nodes. Okay, pure node means all outputs inside node belongs to same class. Example, yes, 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 this is pure. Suppose in this approve, it will classify this is a pure node and in no reject. This is this will be a pure node, two different pure nodes. So its main goal is to separate both categories. Okay, and each category will lie into its perspective category, not like randomly. Suppose approve, reject, approve. This will be an impure. Okay, this is this uh, basically through decision tree we can basically divide the classic categories. Okay, so This is how decision tree works, and I have already explained what is the meaning of nonlinear supervised learning, and these are his uh, algorithms for regression and classification both. First, we will see decision tree for classification practically. Okay, now suppose this I have this data set. I have used this data set previously also. So on this data set, we will see our decision tree classification. Okay, let's see how we can do it. First, I will import some required libraries. Import pandas std, import import matplotlib dot pyplot as plt, import seaborn as essence. Okay, now suppose I will import one more library. Okay, ml extend. Okay, from that I will import plot decision regions. Okay, so if you don't have ml extend, then you can download it by giving this prompt pip install ml extend into your cmd. Okay, it will be installed in your system. Okay, now from ml extend I will draw a decision tree, basically decision tree graph, how decision tree works. Okay, by ml extend. Okay, ml extend dot plotting, import plot decision results. Okay, now I've imported it. Okay, now I will load my data set. Data is equal to pd dot read slash tsv. This is my data set, non-linear. Copy path, control v. Now I will check my data is loaded or not by checking first three rows. Yeah, my data gets loaded, and these are its first three rows. First, I will show you by plotting a graph that it is a kind of non-linear graph, right? It's scatter plot, x is equal to age, y is equal to, I will take estimated salary, and q is equal to purchase. Okay, I will be purchased. Okay, now I will give data is equal to data. My data is in my data variable. I will write plt dot code. Okay, now so you can see here this is randomly plotted, right? This is not following linearity from anywhere, right? It is randomly, basically it is randomly existing. Okay, so now now I will divide my data set into input and output. My input fields are take all the rows, all the columns, but don't take the last column. Last column is my output column. I will take my last output column in Y. Okay. Now my data gets divided into input and output. Now, now I will simply basically I will basically standardize these two columns because you can see here this age column will have this age column has lower values and it has higher values. So our model, when I will train the model, then it will give more priority to estimated salary because it has higher value. So which is wrong in our case. So I have already explained in our previous video how to perform standardization. So you can check my video. So first I will standardize. Basically, standardize means we will scale the data. Scale the data into the form 0 to 1. Okay. And like that. Okay. From sklearn dot preprocessing import standard scalar. Okay. Now, suppose I will create an object to call standard scalar. Now I will fit my x because all input columns into my x. So I will standardize my x variable in which I have age and estimated salary columns. Okay. Now I will I will create into transform into data frame sc dot transform what transform x. Now I will convert it into columns x dot columns. Okay. Now if you will see here your x, now see. Now it has scaled my age and estimated salary, right? Before it was looking like that, now it is looking like this, right? So now I will split the data set into training data set and testing data set. Okay, 80% for the training and 20% for the testing. Okay, from scalar dot model selection import train test split. Okay, now I will take my all four variable x train, x test, y train, and y test is equal to. I will call my train test split. I will give my x and y variable. Test size I want 20%, so I will write test size is equal to 0.2 and random state is equal to 42. Now my data gets divided into training and testing. Okay. Now I will basically create the model. Okay. Now from sklearn dot tree import decision tree classifier. Okay. Because we are handling our classification problem, that's why I'm importing decision tree classifier, right? Now, now suppose I will again create an object to call my decision tree classifier. Okay. And I will fit my training data into it. X train and Y train, right? I will fit the model. It is fitted. Now, now suppose I will check my accuracy of the model. dt.score x test comma y test. So suppose I will into 100, I will multiply it. So it is giving 83% accuracy. Okay. Now I will show you how my decision tree is working on our data set. Okay. For that, I will basically plot our decision tree for it. Sklearn dot tree import plot tree. Okay. Now suppose I will plot my plot tree. What I will plot? DT, right? DT decision tree and PLT dot show, right? Yeah. Suppose I will give some big size. Bigger big size is equal to, suppose I will give 30 comma 30. Yeah. Not, it is still not visible, so I will make this to 50 to 50. Okay. Now it is slightly visible. Okay. Now see here. Suppose I am making more bigger because it is still not visible. Okay. So slightly you can see here. This is how it is dividing the data set. Okay. It is how dividing the data set. Suppose first let's say I will take some max depth. Okay. Because it is using all depths here. So I can limit the depths also, right? So this is one depth, this is two, this is three. I can limit that also. Okay. How we can limit that? Uh, here you can write, here you can write max depth is equal to, suppose I am taking four. It increased its accuracy also. See here. By applying max depth is equal to 4, the accuracy also improved of my model. Okay. Now you can see here. See, first, this is my age. Okay. This is my age. X0. Okay. Guinea is something how pure your data classifying. Okay. Samples 320 means there are total 320 samples, means there are total 320 rows. Okay. Now value is equal to 205 1 and 115 means For zero means not purchased zero. I have 205 rows, and for one, it means person have purchased. There are total 115 rows. Okay, now it divided true and false. Now you can see now my total age is 0.61. We need 0.3 and here 0.273. Now my uh, total rows are 234 here and total rows are 86 here. 191 for 0, 43 for yes, and here 14.0 for no, 72.0 for yes. So this is how it is basically dividing my data set, dividing the problem to take a decision, right? So this is how it is classifying. Okay, so this is you got to know how decision tree works. It divides the problem basically. True, false. It divides the total problem, right? Now, suppose I will plot a graph to show you how it is separating my data into two categories because I have only two categories, 0 and 1. So I will show you how it is classifying. I will use PLT decision reasons. Here we need to convert it into numpy, x to numpy, and y also I need to convert it to numpy, right? CLF is equal to your dt. Now PLT dot show. Okay, plot decision reasons. I have written PLT. Yeah. Now here you can see I have I have this date. I have randomly it was uh, occurring in my graph. You can see here both orange and blue, two different categories were randomly occurring. Now it classified. How it classified? Suppose first here blue classified. See here some yellows also. But yeah, overall my blue part is covered and into my orange part there are some blue parts also here. Here it has taken a blue. Some blue parts are also here, but overall data it has categorized into two different regions. Okay, so we saw uh, how decision trees works. Okay, so always check. Suppose you have not suppose here you have not given max depth. Suppose you have not given max depth. Your accuracy is coming low. So always check on max depth by applying different max depth like 3, 4, 5, 2, 6. Always apply and check your accuracy. How much accuracy is you're increasing or decreasing? Always check by max depth. How much depth you want to use. You don't need to always take all the depth, use all the depth. You can check by applying max depth. I want only four depths, till four depths. So you can apply. So we saw by applying max depth is equal to 4, my accuracy was improved, right? So this is how decision tree works, right? For classification problem. So that's all in this video. From in the next video, we will see how we can use decision tree for regression problem, right? Okay. So thank you. Hello guys, welcome to the channel. Today we will discuss decision tree for regression. In previous video, we saw how we can use decision tree algorithm for classification. And now in this video, we will see how we can use decision tree algorithm for regression. Okay. So what is decision tree regression? It is a supervised machine learning algorithm used to predict continuous numerical values. What do you mean by continuous numerical values? For example, I have house price prediction, salary prediction, temperature prediction. Like instead of predicting categories like yes, no, spam, not spam, this is a type of classification. Okay, this we can predict decision tree. This we can predict in classification by decision tree. This is an example of basically classification. So for regression, instead of predicting categories, it predicts continuous numerical values. Suppose like for example, salary 5 lakh, like temperature 45.7, something like 1200. Okay, so this is what we predict through decision tree for regression problem. Okay, so how it works? Simply see, same like classification problem. It splits the data, basically classifies the problem into step by step, yes, no form, like classification. Also, it works for regression also. Okay. So, like, suppose I have experience is less than 5. There are two conditions. Yes, experience is less than 5. Yes. Is experience is less than 5? No. Experience is greater than 5. Yes, no. For whom whose experience is less than 5, their salary is 25K. But whose experience is more than 5, their salary is 85K. So this is how it classifies the data, okay, and predicts the continuous numerical values like house price prediction, salary prediction, temperature prediction, okay. So this is how decision tree works for regression, okay. So on this data set, I have this as input column, years of experience and their salaries. Okay. On this data set, we will perform our decision tree algorithm. Okay. Now, let's see how we can do it practically. Okay. I will reopen it. Now, first, I will import my required libraries. Import pandas as PD. Import matplotlib dot pyplot as PLT. Import Seaborn as SN. Okay. Now, now I will load my data set. Data is equal to pd.read slash csv. So this is my data set. I will right click, copy path, control V. Now I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded and these are its first three rows. Now I will plot a graph. Okay, how my data is looking. Okay. I will give data is equal to data because in the data variable I have saved the data. Now plt dot show. Yeah, this is how data is looking like by plotting pair plot. See, first I had years of experience, then I had salary. See, this is how my graph is looking like. Okay, now first I will split the data set into input and output. First I will take my input column, although I have only one input column and only one output column. Output column basically always be one. Y is equal to data. I will take my output column, which is my salary. Okay. Now, my data gets divided into input and output. Now, now I will split the dataset into training dataset and testing dataset. I will take 80% for the training and 20% for the testing. Okay. Now, from sklearn dot model selection import train test split. Okay. Now, I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split now for x and y variables because I have input and output in x and y variable. Now I will take test size is equal to 0.2 as I want 20% of my dataset as my testing dataset. I will write random state is equal to 42. Okay, now my data gets divided into training and testing. Now I will build the model. Okay, now from sklearn dot tree import decision tree regression because we are dealing with regression problem. Sorry, regression and plot tree also. I will draw the tree for you. Okay, now suppose I will create an object to call my decision tree regression. Suppose I'm not giving any max depth now. I'm putting my X train and Y train for training the model. Yeah, my training, my model gets trained. Now, suppose I will check my accuracy of the model. X test, comma, Y test into 100. So, 93% accuracy is coming. Okay. Now, suppose I will show you how it breaking our data step by step. Okay. Now, suppose I will take some page size is equal to 50, 20, let's say I'm taking. Now plot tree, I will take DT because in DT I have fitted the model. Right now I will write plt dot show. Okay. So like suppose I will give max depth, some max depth I will give. Suppose I'm giving max depth as 3. You can give, you can check the max depth, okay, by giving 3, 4, 5 like this, okay. Yeah, my accuracy is decreased, little bit decreased, okay. But tree I can see now clearly, right? So here you can see first x0 is less than or equal to 0.35. First condition is put X, my years of experience is less than or equal to 6.35. Okay. Now, squared error, we already discussed it. This is our squared error. Samples, there are total 28 samples. Okay. Value is equal to 81164. This is your salary. Now, First condition is true. If X is our years of experience is less than or equal to 6.35, then true. Then here it classifies. Now X is less than or equal to 2.55, and this is the salary, and total samples are means total rows are 17. Now, second thing, it false means our years of experience is greater than basically greater than 6.35. Then again it goes X is less than or equal to 9.95 years of experience, and my salary is this. Okay, so this is how it splitted my dataset to get a final decision. Okay, so this is how decision tree works for regression. Okay, similarly, like classification. In classification, we take decisions for categories, and in regression we take decisions by decision tree for numerical continuous values, right? Like salaries, house price predictions means price of the house. Okay, so this is how we use decision trees for regression problem. Okay, so that's all in this video. In the next video we will see knn algorithm for classification. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss KNN algorithm for classification. So first understand what is KNN, K nearest neighbors. K nearest neighbors is a supervised learning algorithm used for classification and regression both. For classification predicting categories or classes, and for regression predicting numbers, right? In KNN basically for classification, the model predicts the class of a new data point by checking the nearest data points around it. What it means? Suppose I will explain you by a real life example. Suppose you have two fruits, apple and orange. Okay. Now you get a new fruit. Okay. But you have to predict in both of these two. Okay. Now which fruits we will check by KNN, which fruits are closest to this new fruit. Okay, apple or orange. Okay, suppose if most nearby fruits are apples, okay, to our new data point, then model will predict apple. And if my most nearby fruits are oranges to my new data point, then it will predict orange. Okay, so this is how a graph, an example of graph where I have two categories, 0 and 1. And this is how it tries to extract the same categories by calculating the distance between these data points. Suppose this is 1 for green, 0 for red. So you can see some red are there in green part also. Okay, but what it is trying to do is it is calculating the distance between the data points, each data points. And for closest data point, it tries to extract them together. Okay. Means it is categorized different categories on the basis of their distance. Okay. So greens are almost close to each other, reds are mostly close to each other. So this is how it basically classifying the categories on the basis of the distance. Okay, so main idea of Canon is similar things stay close together. Okay, this is what I explained in the graph. Canon works completed based on distance. Okay, it finds nearest neighbors on the basis of the distance. Check their labels or classes like 0 or 1. Any classes, any kind of classes. Choose the majority class. Okay. So this is what I explained in the graph, and this is what the in theory, main idea of KNN. Now we will check how we can do it, how we can perform KNN for classification problem practically. So this is my data set. Okay, this data set I have used previously also in my previous video also. So on this data set, I will try to perform my KNN algorithm. This is the kind of classification problem because I have only two categories, like two categories, or I have categories not like I have uh, continuous values like regression. So it is a problem of classification. Now we will see how we can perform KNN on this data set. Okay, so first I will import some required libraries. NumPy as np, import pandas as pd, import matplotlib dot pyplot as plt, import cborn as sns. Okay, now I have imported all the required libraries. Okay, so now I will load my data set equal to pd dot read slash csv because I have csv file. If you have Excel file, then you can write Excel. By the way, I'm giving the data set for every video. Okay, so this is my data set. I will right click, copy path. I will paste it here. I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded, and these are its first three rows. Now, now I will show you how my data is spread through a graph. Okay, now I will plot a scatter plot. I will give x is equal to age. I will give y is equal to estimated salary, and I will give data is equal to data because in data variable I have taken my data set is equal to, I will give purchased. Okay, now plt dot show. Now you can see how my data is spread. Okay, this is how my two categories, 0 or 1, purchased or not purchased, is looking like. Okay, so we will see at the end by plotting a graph again how my data gets separated using KNN algorithm. Okay, we will see that. Now, first I will divide my data set into input and output. I will take all input columns in X and all one my output column into Y. Data.ilog. So what are my input columns? Sorry, my all rows, my all column, but don't give me the last column because last column is my output column and these are my input columns, age and estimated salary. Okay, so I have taken X, all input columns into my X, and I will take output column into Y. Okay, Control C, Control V. Now my data gets separated into input and output by X and Y. Okay, now I will standardize these age and estimated salary columns. Okay, because you can see here age has lower values 1935 and estimated salary, obviously estimated salary will have more higher values. So my model will give more importance to estimated salary, which is wrong in our case because both columns are important for me. Okay. So I have already covered how to perform a standardize in detail. So I will perform a standardization, sklearn dot pre-processing import standard scalar. Okay. Yeah. Now, now suppose I will make an object to call standard scalar. Standard scalar. Okay. Now I will fit my x into standard scalar because only input columns I want to standardize. Okay. So control x I fit it. Okay. Now I will transform it into columns. Okay. X is equal to pd dot data frames frame sc transform sc transform form x columns is equal to x dot columns. Okay. Now I will show you the x. So you can see here my I have performed standardization. So you can check the values now. Okay. Look at here and look at here. Okay. I will standardize my input columns. Okay. The data of input columns. Okay. Now, now I will split the data set into training data set and testing data set. Okay. For that, I will import train test split scalar dot model selection import train test split. Okay. Now I will take my all four variables x train, x test, y train, y test is equal to. I will call my train test split for which variables x and y. I have taken input and output columns into it x and y. Now I will give test size is equal to 0.2 because I want 20% my for my testing data and 80% for my training data. Okay. Random state is equal to 42. Okay. Now my data gets split into training and testing data randomly. Okay. Now, now I will build a model using k nearest neighbors, k nearest classifier because this is a problem of classification. So now, how we can make it from sklearn dot neighbors 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 import k neighbors classifier k neighbors classifier. Okay, because this is the problem of classification. Okay. Now, now suppose I will make an object to call my k nearest classifier. Now, if you remember, in our decision tree, we used a parameter max depth. Okay, max depth we choose 3, 4, 5, anything. Similarly, in nearest k neighbors classifier, we can choose n neighbors is equal to 3, 4, 5. Suppose I will give neighbors n neighbors is equal to 3. What it means? Means I'm saying that look at three closest data points. Look at the three closest data points. Okay. That's what I'm saying by giving a parameter n neighbors is equal to 3. We can give 4, 5, 6, anything. Suppose I'm giving 3. Okay. In decision tree we saw we gave max depth is equal to 3. Suppose I'm giving n neighbors is equal to 3. Now I'm saying that look at the three closest data points. Okay. That's what I'm saying by this line. Now, now I will fit my training data into it. Knn dot fit, knn dot fit, x train and y train. Okay, it gets fitted. Now, suppose I will check accuracy of my model. X test, comma y test into 100. Now, 91% accuracy I'm getting. Okay. Now, now I will show you by plotting a graph how my data is getting categorized, how my data is getting spread. Okay, I'm plotting a graph. Okay, from ML extend. If you have not ML extend, I have already shown in my previous video while covering decision tree for classification, how we can install ML extend. Only pip install ML extend. You want to give command in your CMD and it will install. It will be installed. Okay. Dot plotting import plot decision regions. Okay. Now I will call this plot decision regions. Now we have to convert it into numpy to numpy. Also for y dot to numpy, and we will take CLF is equal to KNN, right? CLF is equal to KNN. Now I will write PLT dot show. Now, now you can see how it tried to basically categorize my both features or both classes or we can say labels. See, this is 0 for blue and 1 for this orange one. Now you can see some blue points are also there in my orange part, but it tried to cover that also. See here. Okay. So this is how it tried to split my categories or classes according to their distance. Okay. So this is how KNN for classification works. Okay. So in the next video, we will see how KNN works for regression problem. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss KNN for regression. So We saw in our previous video how we can use KNN algorithm for classification. Now we will see how we can use KNN algorithm for regression. Okay. Now, KNN regression means predict the value of a new data point by looking at the values of its nearest neighbors. What it means? First, understand KNN is K nearest neighbor. K means number of neighbors. Nearest means closest data points. Neighbor is existing data points in dataset. Okay. Now, in regression, for regression problem, the output is continuous value, not categories like 0, 1, apple or orange, not like that. It will be continuous value, not categories. Okay. For example, house price prediction, temperature prediction, salary prediction. Now understand this line. Predict the value of a new data point by looking at the value of its nearest neighbor. What it means? For uh, understand by this real life example. Suppose you want to predict the price of a house, okay, and you have three inputs. On the basis of these three inputs, you are deciding what should be your price of the house. Okay, so by Cannon for a regression algorithm, we will find the house prices which will be nearby that are similar in size, location, and room. Suppose suppose I have some size and location and rooms, and we are getting a price like 20, 30 lakhs. Okay, now suppose I have new data points, okay, new rows, which has similar size, location, rooms, okay. So it will predict the price like in the similar way, like similarly like previous value, like its nearest value. Like then you take their prices and calculate the average of nearby data points, okay, of nearby prices of the house, and then it calculate the average, and then the average will become the predicted value. Okay, so that is how KNN for regression works. Okay, so we will see that how we can do it practically. So this is my data set. These two are my input columns, and this is my output column. On the basis of uh, on this data set, we will perform KNN for regression algorithm. Okay, so let's see how we can do it. First, I will import required libraries like import pandas spd. Okay, now I will load my data set pd.read/csv. Now this is my data set. I will copy path, control V, and I will check my data is loaded or not. Yeah, my data gets loaded, and these are my first three rows. Now we will see how we can use KNN algorithm for regression. Okay, so it basically tries to predict the output on the basis of its neighbors. Okay, like I have similar values in our input columns, and it predicts some value. Like I have some values, so it will try to basically put that new data point for the for that place, and it tries to basically calculates the average of those similar data points and similar outputs, and then the average will become our predicted value. Okay, now I will separate my data into input and output. I will take all rows, all column, but I will not take last column, -1. That is my output column. I will take output column into my data salary will be now. I will split the dataset in training dataset and testing dataset. Okay. Now from scalar dot neighbors. Sorry. First, I have to split the dataset, right? So I will import model selection, import train test split. Okay. Now, now I will take all four variables: x train, x test, y train, and y test is equal to. I will call my train test split. Okay. Balance. Okay. I will call my train test split for x, y variables. I will give test size equal to 0.2. I want 20% as my testing data. Random state is equal to 42. Okay. Now, now I will create my model from sklearn. I will go for neighbors, import k nearest, uh, k neighbors regression, k neighbors regression, because this is the problem of regression. Okay. Now, now I will create my model. Suppose I will take an object to call my k neighbors regression. I will give some n neighbors. I have already explained what is n neighbors. Basically, suppose I will give n neighbors is equal to 3. So what we are saying, look at three closest data points. Only three closest data points. Look for only three closest data points. Okay. Now, so plus enter knn dot fit. I will give my x train, y train. Okay. Okay. I have given wrong here. Yeah. Now it gets fitted. Okay. Now, suppose I will check my accuracy. Score. I will give x test, y test into 100. So yeah, I'm getting 88% accuracy. Okay. Some things we can do, like we can standardize like longer higher values or something like that. Okay, those things I have already explained in my previous video. You can check that. Okay, so this is how k nearest neighbor works for regression problem. Okay, it basically tries to basically calculate the average of the nearest nearest neighbors. Okay, nearby values. Okay, that should be similar for my input column. Suppose I have these input columns, it will always look for the similar values of these input columns, and suppose, and it will calculate the, suppose I got some values which are similar to this one, these three. Okay. So it will calculate the average of them. Okay. And it will give my prediction. Okay. So this is how K nearest neighbor works for regression problem by calculating the distance. Okay. So that's all in this video. In the next video, we will see SVM algorithm for classification. Okay. Thank you. Hello guys. Welcome to the channel. Today we will discuss support vector machine algorithm for classification. So what is support vector machine? Support vector machine is a supervised machine learning algorithm used for classification and sometimes regression also. Okay? Its main goal is to find the best boundary, or we can say hyperplane that separates different classes. For example, spam versus not spam, cat versus dog, fraud versus normal transaction. It basically finds best boundary called hyperplane that separates different classes, like it separates spam not spam by hyperplane, cat versus dog, fraud versus normal transactions. It basically separates these two classes using hyperplane. Okay. For example, real life example, re- we will have some red balls on one side, blue balls on another side. Okay, then there can be many lines separating them, right? So SVM chooses the line that leaves the maximum distance or margin from both classes. Means the basically distance between these classes and hyperplane must be maximum. Then it will choose that hyperplane. Okay, basically larger margin is equal to better generalization, lower chance of wrong prediction, right? Because, see, suppose this is a graph where I have this hyperplane, and these are my two different classes, right? So if there will be highest, means there will be more distance between these two classes by this hyperplane, then it means my classes are classified perfectly, because the distance is far from the hyperplane for both classes. Okay. So it means by the hyperplane, it basically classified the data perfectly, right? So, so this is how SVM works. It creates a hyperplane, separates the classes, and predicts the output, right? So this is how vector machine for classification works. Now, some important terms in SVM. Hyperplane. Hyperplane, a boundary that separates classes, which I have already explained. In 2D plane, it is called line. In 3D plane, in 3D, it is called plane. High dimension is hyperplane. Margin. Distance between hyperplane and nearest data points means these are my data points and this is my hyperplane. So margin between the data points and hyperplane, basically distance from the data points to the hyperplane, right? That is called margin. Support vectors, the nearest points to the hyperplane. These points are very important because they decide the position of the boundary, means hyperplane. Without support vectors, hyperplane changes. Okay. So suppose this data point is much closer to hyperplane, then it is support vector. This point is much closer to my hyperplane, so this is support vector, right? So this matters more now. Now what is kernel? Basically, kernel is something which converts low dimensional data into higher dimensional data. Sorry, space. Okay. So the separation between two different data points, between two different classes, separation of between two different classes, or we can say categories, becomes easier by kernel. Okay. So first, kernel is a linear kernel used for linear data, polynomial for which creates like curved creatures, which is not linear, and RBF for complex non-linear data. Non-linear data plus complex. Okay. Sigmoid looks similar to neural networks, and I will cover deep learning neural networks. Then I will cover this also. Okay. So now we will check how we can perform SVM for classification, okay, and how we can use kernels also for linear data, linear, polynomial, if I have some not linear data, means I have some curved features in our between our independent variable and independent variable, then I will use polynomial kernel RBF and I will have complex or non-linear data, right? So this is the different cases of kernels. Okay. Now this is my data set on which I will perform my SVM classification. Okay. So how we can perform it? First, we will import some required libraries. Import pandas as PD, import matplotlib.pyplot as PLT, import cbon as SNS. Okay, now I will load my dataset /CSV. So this is my data. I will right click, copy path. I will paste it here. I will check my first three rows by checking uh, dot head. So yeah, my data gets loaded and these are my first three rows. Now suppose I will plot a graph to show how my data is looking like. Suppose I will first give some figure size. SNS dot scatter plot x is equal to, I will take CCPA. I will take Y as academic performance and U is equal to my placement, right? Placement. Okay. Now I will write PLT dot show. Oh, sorry. I have not given data as data is equal to. I have loaded my data into data variable. So I'll give that also. So yeah. So this is how my data is looking like. A little bit very complex data, right? Okay. So now I will first divide my data into input and output. I log. I will take my all input columns into my X means give this means give me all rows, give me all columns, but don't minus one means but don't give me the last column, which is my output column. And in Y, I will take my output column. That is placement. Sorry, that is my placement. right? Now, sorry, I mistake. This is my mistake. I gave one more comma. So, uh, my data gets divided into input and output. Now, I will basically divide my data set into training and testing. 80% for the training and 20% for the testing. Okay. From sklearn dot model selection import. I will import train test split. Okay. Now, now I will take my all four variables x train, x test, y train, y test is equal to. I will call my train test split. I will give my x and y variable because I have loaded the input columns and output column into x and y. I will give test size is equal to 0.2 and random state is equal to 42. Okay. Now my data gets divided into a train 80% for the training and 20% for the testing because I have given 0.2 as my test size. Now, now I will create my model from sklearn dot svm import svc support vector classifier because I am dealing with classification problem, so that's why I have imported svc. Now suppose I will create an object to call my svc. Now here I have to give kernel. Suppose like this is looking like a complex data. So I'm just giving my kernel as RBF. Here RBF. Here I explained already when we use different kernel. Linear kernels for linear data, polynomial when we will have some curved creatures into my graph. Then we will use polynomial kernel and RBF kernel, which we are using for complex and non-linear data. Okay, so and sigmoid for like neural networks. So this is when we use different kernels. Okay, according to our situation. So suppose I am taking RBF as my kernel. Here I'm commenting some kernels for you. Like for linear, you can write linear. Okay, linear. You can write when you will have linear data. Instead of RBF, you will write linear. And if you want to apply polynomial, then you just give to poly. Okay, and the last one, which is sigmoid. You just need to give sigmoid. Okay. Now an RBF I'm using. Okay. So these four different kernels are there in SVM support vector machine algorithm. So yeah, I'm giving RBF. Okay. Now suppose I will fit my training data into my model, right? I will train my model by my training data, X train and Y train, right? Right? It gets fitted. Now suppose I will check my accuracy of my model. X test, comma Y test into 100. So this is very low accuracy I'm getting. It only 83.7. But yeah, you basically you got an idea how we can use SVM algorithm for classification. So this is how we can use SVM algorithm for classification. And here we how we can use different kernels according to our situations in SVM algorithm for classification problem. Okay. So in the next video we will see how we can use SVM classification SVM algorithm for regression problem. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss support vector machine SVM algorithm for regression. Okay. In previous video we saw how we can use support vector machine algorithm for classification. Okay. So first understand what is SVR. SVR stands for support vector regression. It is the regression version of SVM algorithm. Okay. It predicts, SVR predicts continuous value, not categorical values like cat, dog, okay, red ball, blue ball. Those are categories. It predicts continuous values like house price, salary, temperature, stock price, like that. Okay. So, what is the main idea of SVR? Basically, it fit the best line inside a margin or boundary. I will explain it through a graph. Okay. HBR says small errors are okay, but only focus on points with large errors. The on those points which have large errors, it adds penalty to them. For small errors, it neglect that. Okay, so this is the main concept of SVR and margin. What is margin? Margin, like you can understand it. If prediction error is small, ignore it, or if error is outside the margin, then add penalty to them. Okay, this is what is the concept of SVR, the logic of SVR. Now you can understand by this graph. Here you can see the data points like this. Okay, like this. Okay, these orange dots. These are your data, actual data points, and it drawn a prediction line with respect to those data. Okay, so this is how it tries to predict from those actual data points. Okay, this is how it makes prediction. So we will see how we can use support vector machine for regression. And last thing, kernel. I have already explained what are the kernels in my classification. Basically, kernel which converts low-dimensional data into higher dimensional issues. There are four types. Linear kernel used for linear data, polynomial kernel. When we will not have linear data, we will have some curved like shapes in our graph. Then we will use polynomial kernel. RVF kernel for complex non-linear data, and sigmoid we will use it later when we will cover neural networks. Okay. So kernel concept is basically similar to for regression. Okay, so on this data set I have where I have total experience and certifications as my input column, and my output column is salary. Okay, so we will apply my SVM algorithm for regression on this data set. Okay, so let's see how we can do it. First, I will import some required libraries as np import pandas spd import matplotlib dot pyplot splt import seaborn as essence. Okay, now I will load my data set pd.read slash csv. This is my salary multi.csv is my data set. I will right click, copy path, paste it here. I will check it first three rows. So yeah, my data gets loaded and these are my first three rows. Okay. Now, now suppose I will plot a graph to show how my data is looking like. Fixed size, comma to SNS dot scatter plot. Plot. I will give X as my total experience. Total experience. Y. I will give Y for certification. Okay. And I will give my data as my data because in the data variable I have saved the data. I will take Q parameter salary. Okay. Now, sorry, PLT dot show. Okay. So this is how my data is looking like. Okay. Now, first I will basically divide my data set into input and output. Minus one means I give me all the rows and all columns, but minus one means but don't give me the last column, which is my output column. I will take output column into Y. Okay, my data gets divided into input and output. Now I will divide my data set into training data set and testing data set. Okay. Model selection, import, train test split. Okay. Now I will take my all four variables x train, y train, sorry, x test, y train, y test is equal to, I will call train test split. Yeah, I will give x and y. I will give test size as 0.2. I want 20% as my testing data and 80% as my training data. So I give test size equal to 0.2 and I will give random state is equal to 42. Okay. Now, now I will create my model from sklearn dot svm import svr because we are dealing with regression problem. For dealing with classification problem, we import svc. Okay. Now, now suppose I will create an object to call svr. Okay. Now, now I will give kernel. I have already explained in my previous video also where I explain SVM algorithm for classification, what kernels are, and in this video I also gave an overview what kernel, what is kernel. Okay, now suppose I am giving my kernel as RBM. There are total four kernels. I will write it here. Linear. Okay. Second one is polynomial. For polynomial, we just write poly. Okay, and third one is your RBF. Fourth one is your sigmoid. Okay, so so I've already explained how we can use different kernels according to our situations. Okay, for example, if we will have linear data, then we will apply linear polynomial for basically when we will have some curve like features, then we will use polynomial kernel RBF when we will have complex or non-linear data, and sigmoid we will not use this now. When we will cover neural networks, then we will apply sigmoid kernel. Okay. Now these are the four types of kernels. So first, let's suppose I'm taking RBF. Okay. Now I will fit X train and Y train. I'm training the model by my training data. Now suppose I will check my accuracy of the model. X test comma Y test into 100. So this is giving very low accuracy. Okay. RBF. Okay. Let's suppose I will take linear. Okay. So by linear, I am getting 71% accuracy. Okay. Now let's take poly. By poly, we are getting 59 accuracy. So for now, I'm only giving linear because from linear, we are getting some high accuracy, not like high, better than these two kernels accuracy. I'm getting 71% accuracy. So we are getting low accuracy because we have not standardized our values. Okay. So we need to perform standardization. Okay. So I'm not covering standardize in this video. I have already covered how we can perform standardization and why we perform standardization in my previous video where I covered data preparation. You can check that playlist. Okay. So uh, this is how we can use, you got an idea, right? How we can use SVM algorithm for regression problem. Okay. So uh, that's all in this video. And we also like covered how we can use different kernels according to our situations for regression problem also. So that's all in this video. In the next video, we will cover hyperparameter tuning. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss hyperparameter tuning. So what is hyperparameter tuning? First understand what is hyperparameter. Basically finding the best settings for a machine learning model to get maximum performance. These settings are called hyperparameters. And now uh, let me show you what is those settings exactly. Okay, let's suppose I have performed decision tree algorithm for classification in my previous video. So let me show you what is hyperparameters. Okay, so first let me execute all the line of code. Okay, so here you can see when you will click here. Here we have taken max depth is equal to 4. This is also a type of hyperparameter tuning. This is a type of manual tuning. I have chosen max depth is equal to 4 means I only want total depth as 4. I only want my model till the depth 4 in decision tree. Suppose I will click here shift plus tab here. Now you can see the criterion, splitter, max depth, minimum samples split, minimum samples leaf. These are called hyperparameters. Okay, these are called hyperparameters. So building a good model according to our scenario or situation, we just give values according to our situation or scenario, like in criterion splitter or like required things. Okay, these are default values. Okay, so on the basis of our requirement, we choose the values of these hyperparameters. Okay, so that is called hyperparameter tuning. Hyperparameter tuning. So there are three ways of hyperparameter tuning. First one is manual tuning. Manual tuning I have already shown. This is like I have chosen max depth is equal to 4. So this is a kind of manual tuning. I have tuned it manually. Max depth I have chosen 4. Now, what are the next two methods? More two methods, grid search and random search. What grid search do? Basically, you give multiple values, then model tries every possible combination and then select and will give you the best combination. Okay. And third one is random search. It will not check on all combinations like grid search. It checks random combinations. Okay. And it will give you the best combination according to the random search. Okay. So now we can do it practically. How we can do these, how we can perform these three methods for hyperparameter tuning. Okay. Now let's take our new file, hyperparameter tuning. And on this data set, I will perform my all three methods of hyperparameter tuning. Okay. So this is my output column and these two are my input columns, total experience and certifications. And on the basis of these inputs, we are calculating salary. Okay. So first I will import pandas library, import pandas as PD. Okay. Now I will load my data set. Suppose I will take a variable data slash CSV. Okay. So this is my data set salary multi.csv. I will right click, copy path, control V, and I will check my data is loaded or not. Okay, by checking first three rows. Okay, now my data gets loaded. Okay, now I will basically take all the input columns into X and output column into Y variable. Okay, data dot ilog. I'm saying give me all rows and all columns, but don't give me the last column -1. That is my output column. I will take output column into Y data. I will take salary. Okay, now my data gets divided into input and output. Now I will divide my data set into training 80% for training data and 20% for the testing data. So I will load train test split sklearn dot model selection import train test split. Okay. Now I will take my all four variables x train, x test, y train, and y test, right? And I will call my train test split to split my data. I will give my both variables x and y. I will give my test size as 0.2 as I want 20% of total data as my testing data, and random state is equal to 42, right? Now my data gets divided into 80% for the training and 20% for the testing. Okay. Now, let's build a model. Suppose I am taking a decision tree. Okay. for building a model. So I will import decision tree sklearn dot tree import decision tree regression because it is a problem of regression. So I'm importing regression, not classifier. Okay. So now let me give the method one manual tune. I will give a markdown here manual tuning. Okay. I will give a markdown here. Shift plus enter. Yeah. First one manual tuning. So this is very simple. Let's take an object to call my decision tree classifier. Okay. This is simple. Suppose I'm taking max depth as 5. Max depth as 5. Okay. This is your manual tuning. Okay. Where you are giving the where you are giving some values to your hyperparameters according to your situation. Okay. Basically by yourself. You are giving max depth is equal to 5. This is the kind of manual tuning. Okay. Let's fit dt dot fit our training data x train and y train. Okay. Now it gets fitted. Let's check its accuracy. dt dot score. I will take x test comma y test into 100. So we are getting 89% accuracy. Although we can increase our accuracy by performing standardization also because there is a need to perform standardization on this because you can see salary has many much much higher values than this one. So model will give more priority to the salary column. Okay. So I'm not performing standardization. I've already covered what is standardization and how to perform it. My motive of this video is to basically show you how we can use different methods of hyperparameter tuning. Okay. Now, now let's take second grid. What was the our second method? Grid search, right? Grid search and third one random search. So first we will see grid search. Okay. First let me give a markdown here. Second grid search. Okay. I will choose markdown. I will click shift plus enter. Okay. Now I will import first from sklearn dot model selection import grid search CV. Okay, CV. And let's import second one also. That is our random search. And I will import it randomized search CV. Okay, let's import this. Yeah, I have imported this. Now let me make a variable, okay, where I will take all like required hyperparameters and all their values. Okay, let me take df is equal to, okay, so first one is our let me see here from here, right? Shift plus tab. Suppose I will take first criterion, okay, criterion. So I am taking criterion, okay, first one, okay, criterion. Now let me see what are the values are available for criterion. Shift plus tab, and here you will see there are four different types of criterion are we can take. Okay, default one is your squared error. So let me take all this. Okay, I will take all this here. Control V. Okay, okay. Now what was our second one? Again, I will go for it. Shift plus tab. Now let's take splitter. Splitter. Okay, as our second hyperparameter. So I will give this, and again I will see what are the values are available for it. Splitter, best and random, and default is your best. Okay, Control C. Okay, sorry. Okay, best and random. And last one, I will suppose I will take max depth. Max depth. Suppose I am taking a range in max depth. Suppose I'm taking a range I for I in range. Suppose I'm taking 2 to 20. Okay, 2 to 20. I'm taking this range. Okay, now plus enter. Oh, okay. I forgot to put a comma. Okay, yeah. So now let me create an object to call my grid search CV. GD is equal to, I will call my grid search CV. Yeah. Now, I will first take decision tree regressor. Okay. Now, second thing, I will give parameter grid. Parameter grid. Okay. SDF. All these values. Okay. SDF. Okay. Now, I will fit my training data into it. GD.fit xtrain, comma, ytrain. Okay. Yeah. It gets fitted. Sorry. Till now it is not get fitted. Yeah. It gets fitted now. Now let me check what are the best parameters it is given. GD dot best parameters params. Okay. Yeah. It is saying your best criterion you can take as poison. Poison. Okay. And max depth you can take 4, and splitter will be best. You can take best. Okay. So what we can do, uh, we can give these parameters in our decision tree. Let's take this. Suppose I'm calling it as DT2. Okay. Now I'm giving these parameters here. Control C, Control V. Okay. I will remove the, okay. I will remove this. Okay, so it is giving me error here. Let's take this. Let's take equal to. Okay, now it gets fitted. Now let me check the accuracy. Dot score. Sorry, DT2 dot score. Now I will take X test, comma, Y test. So it is giving me 90% accuracy. Okay. First I was getting 89% accuracy. Now I am getting 90% accuracy. Once you will perform standardization, the accuracy will be increased much more. Okay. I'm not performing standardization here. So here you can see my accuracy increased a little bit. Okay. So this is how we can perform grid search. Now let's see how we can perform the third one. That is our random search. Okay. Let me give a markdown here. Random search. Okay. That is our third one. Sorry. I will have to give markdown here to highlight this. Yeah. Random. Again, I will give third number. Okay. Third random search. Now, how we can perform random search CV? Let's take an object to call random search CV as I have already imported this here randomized search CV. So I will call this. Okay. Now, now I have to uh, give decision tree regressor. Okay, comma and parent distribution. I have to give distribution. I have to give my DF and I have to give an iteration. An iter is equal to let me give 20. Okay. Now, okay, distributions. Okay. Now, I will fit rd dot fit x train and y train. Okay. It gets fitted. Now, let me check what are the best values of parameters it is giving. rd dot best parameters. Best params. Okay. Okay. Yeah. It is saying that splitter we should take best, next step we should take 5, and criterion should be so we should take squared error. Squared error. Okay. Now let me check if it is increasing my accuracy or not. So it is saying to take criterion as squared error, right? So I will take this control V, and it is saying next step we should take 5. Okay, it was saying 4 and it is saying 5 we should take. And splitter is best. It is also saying best. So we are not changing this. So now it gets fitted. Let sorry, I will first create a new variable. Now let me check the accuracy. DT3 dot score x train, sorry, x test, comma, y test. into 100. So it is giving 89% accuracy also. Okay. So here we can see by manual tuning, I got 89% accuracy. By grids using grid search, we got 90% accuracy, and from random search, we are getting 89% accuracy again. So to basically increase the accuracy of obviously we need to perform standardization. So here are these three ways to perform hyperparameter tuning. Okay, to choose the best values for your hyperparameters, like like grid search suggested that you should take criterion as position, max depth as for splitter as best. You should take. Okay. So we implemented that in this. Okay. And 1% accuracy improved. Okay. So this is how three different methods of hyperparameter tuning you can perform. So these are the ways to perform hyperparameter tuning methods. Okay. So that's all in this video. In the next video, we will see cross validation. Okay. So thank you. Hello guys, welcome to the channel. Today we will discuss cross validation. Okay. So what is cross validation? Cross validation is a technique used to check how well our machine learning model will perform on unseen data, whether the model is overfitted, underfitted, or performing well. Is what it does, instead of testing the model only once, cross validation tests it multiple times on different data sets. Means when we basically create a model of supervised learning, then we just basically split the data into two parts, training and testing, right? So there is there is one data for training data and there is one data for testing data. But it will it basically splits the training and testing both data into several parts. Okay. So and test that on all the splitted data set. Okay. Why do we need cross validation? Because suppose you have 80% training data and 20% for testing data. Then maybe the test data was too easy, maybe it was so difficult. So in that case, accuracy may not represent the real performance, right? So cross validation solves this problem by changing the train test split multiple times. Remember this. It will change the train test split multiple times and taking average performance. Okay, for all splitted data set. Okay, how it is performing on all splitted data set. Okay, so there are some ways of doing cross validation. First one is your k-fold cross validation. What it does, suppose you have 100 records and you have chosen k is equal to 5, then it will split the data set into five equal parts. Okay, so divide 100 by 5 is equal to 20. Okay. So each fold will contain 20 records. Okay. So first one, this is how k-fold cross validation works. Second one, stratified k-fold cross validation. It is used for classification problems. And suppose your data set is imbalanced. You have 90% data as cats in your output and 5% only for dogs. Okay. Then in normal k-fold, it will create bad split, right? Because you have only 5% of, right? And then stratified k-fold keeps same class proportion in every fold. Every fold means it, suppose it has splitted the data 10 times. Then it will basically keep these two categories or these two classes into same proportion, no difference. Okay. So this is how stratified k-fold cross validation works. And leave one out cross validation. Only one data point is used for testing and remaining all data points are used for training. What it means? Suppose I have five records. Okay, one, two, three, four, five. So what it will do in the first iteration, let's say one will be for testing, and two, three, four, five remaining four will be for training. Okay. In the second iteration, you will have suppose two as your testing data, and remaining one, three, four, five will be for training. And leave P out cross validation, in which in this cross validation we will give, suppose P is equal to 1, P is equal to 2, or P is equal to 3. In with respect to that P is equal to 2, 3, suppose we have given 2, then it will take two uh, two testing data from each iteration. Suppose I have five records, and one, two, three, four, five, and I have given P is equal to 2. Then maybe it's suppose it will take 1, 2 for training. Sorry, 1, 2 for testing, and remaining 3, 4, 5 for training in the first iteration. In the second iteration, it will take suppose 1 and 3. Then you will have 2, 4, 5 as your training data. Okay. This is how leap payout cross validation about. We will see how we can use all these cross validation techniques practically. Okay. So suppose I have this data set. So I have CGP as my input column, and package I have as my output column. Okay. So basically, it is a regression data. So uh, I have I have second one stratified K for cross validation. It is used for classification problems, so it will not work on this data. But I will show you the syntax for this validation technique also. Okay. So let's see how we can do it practically. Okay. First, I will import my pandas library as PD. Okay, now I will load my data set. Let's say I have data set. Okay, this is my data set placement.csv. I will right click, copy path, control V. Now I will give data.head. Now my data gets loaded, and these are my first three rows. Okay, so basically, uh, first I will make this data smaller because it will have multiple records, and when we will perform uh, leave one out, leave P out, then it will work very slowly because I have multiple records. So suppose I will create a new variable. In this, I will take only starting 10 rows. Okay. Okay. And suppose I will basically split the data set into input and output. Basically, I will take input data into my X new, and my output data package into Y new. Okay. Suppose uh, data I will take, as I have only one input column and one output column. Okay. And I will take Y new is equal to data package. Okay. Now my data gets split into two parts. Okay. Now I will import all four methods. Okay. Scalar dot model selection import. First, I will import leave one out. Leave one out. Okay. Second one, let's say I will take leave P out. Third one, I will suppose take K fold. And last one, let's say I will take static. Although it will not work on this data set because this is the problem of regression and this stratified k-fold only works for classification. But although I will show you the syntax for this also. Okay. Stratified stratified k-fold. K-fold. Okay. Okay. Here we go. Spelling sticker. Capital O. Okay. I will take I will copy paste from here. Okay. Now I've imported all this. Now let's take first one. Leave one out. Let me make an object for calling leave one out. I will call leave one out. Okay. Now I will I will give an for loop for I will take train and test in LO dot split. I will pass my X new and Y new. In my X new, there is my input column, and in Y new, there's my output column. Okay, now I will print my train and test. Okay, train test is not okay. Sorry. Yeah, you can see it. Okay, this is how it is splitted my data. Okay, let's see. First one, my zero. You will not gonna find here zero. Here I have one. You will not gonna find one here. One is for training and remaining all for testing. Zero. Zero here you will not find. One you will not find here. Two you will not find here. Basically here you can see zero is for testing and remaining all these values are for basically training. This is for testing and these are all are for training. This is how it is splitted. Okay, one by one. Here you can see till 30, all the values it has taken one by one. Okay, so uh, I will not print it. Okay, suppose I will I will keep this as it is. Okay. Now I will remove this. Okay. Now first one I perform leave one out. Now how to perform leave p out? Let's take an object LP to call leave p out. Okay. Now here you have to give p is equal to 2 or, or whatever value you want to give. P is equal to 2, 3, 4, anything. Okay. So again make an I will make a for loop for train test in LP dot split x new comma y new. Okay. Same I will show you by printing it. Print train and test. Sorry. Again I gave slash. Okay. Let's see. First one here you can see 0, 1. It has taken as for testing and remaining all for training. See, you in this array, you will not gonna find 0 and 1 because 0 and 1 it has taken for testing. Remaining all are for training purpose. Okay. Here you can see 0, 2. 0, 2 will you will not gonna find here because it has taken 0, 2 for testing here and these are for training. So this is how leave p out works. Okay. Suppose I will not print it. Okay. Now, third one. Let's take K4. Suppose I will make an object K. Okay. I will call my K4. Okay. Now let's take an split. Mid means convert my data into let's take 5. Divide my data set into 5 equal parts. Okay. I will copy this simply. Okay. I will basically just put KF here. Sorry, I will have to print. Yeah, here you can see it has divided your data set into 5 equal parts, and these are 0, 1, 2, 3, 4, 5 till 39. It has taken for testing, and all these are for training. And then after 39, it has taken 40 to 79 for testing, remaining all for training. Okay, so this is how it is splitted my data into 5 equal parts, and it has taken uh, testing data by itself and training data by itself. Okay, 0 to 39 for the first iteration, and 40 to 79 for the second, 80 to 119 for the third, and 120 to 159 for fourth, and 198 till 198 for the last one. Okay, so this is how K-fold works. Okay, although stratified will not work here because I have regression data and it only works for classification. But although I am showing you the syntax. It will have the same syntax. I will call this. You will have to again give an split. Let's take is equal and split is equal to 5. Now just copy. It will throw an error. Okay. It will throw an error because give here escape. It will throw an error because this is a problem of regression and we are applying stratified k-fold for regression. Okay, this will not work. This will, okay, I have done something wrong here. It is basically working here, but although we generally use stratified k-fold for classification. Okay, it is basically working by thinking it as a classification problem, but this is not my classification problem. This is my regression problem. Okay, although I have shown you how we can perform all the cross validation techniques, these four techniques, how we can perform. Okay, so that's all in this video. Hello guys, welcome to the channel. From today, we are starting unsupervised learning. So first understand what is unsupervised learning. Unsupervised learning is a type of machine learning where we do not have labeled output data. The model tries to find hidden patterns, groups, or structure from data by itself. Now what it means. Now let me show you a data set. This is the iris data set, okay, without output. We all know in iris data set we have three different categories, Setosa, versicolor, and virginica. These are three different categories are there in iris data set, okay. So here you can see we don't have the output, okay, and these are its only inputs: sepal length, sepal width, petal length, and petal width. These are its only inputs. So, what supervised learning do is it will try to analyze from these input data only how many categories can be there from these by these inputs. Okay, it will try to analyze how many categories can be there. We know this iris data set has three categories because we have worked on this data set. If you have any another data in which you have only inputs, so you don't know about the data set how many categories can be there. So by unsupervised learning, we can analyze how many categories can be there in the output on the basis of these inputs. Okay, so we will not have the output like supervised learning in for our unsupervised learning. We will analyze the output categories by unsupervised learning, and we will only train the model by giving the inputs. Okay, so this is what unsupervised learning is. For example, this is our input data. This is not output. This has not output. This is only input you are giving to model for training. Okay, only input data. Then it will try to categorize it. Like I found two different categories by your input data, apple and watermelon. My model found that. See, I didn't have the output data, but it categorized it into two different categories. Okay. So this is how unsupervised learning works. Okay. So what is clustering? Clustering means grouping similar data points together. Okay. Or dividing data into clusters where points inside a cluster are similar to each other. What it means? Suppose Suppose you have these data, unlabeled data, where you will not have the output. Okay, so this is how it is looking like. So it found then that these inputs are similar to each other. So it categorized those. Made a cluster of like yellow. It made another cluster of green. These have different properties from yellow, and also one for the red. And these categories have different properties from these two. Okay, so this is how it clusters according to its property. Okay, it groups the similar data points together. Okay, these red dots are similar to each other, these yellow are similar to each other, and these greens are similar to each other. So it is making three different clusters. Okay, so let's understand by a real life example how we can use this. Okay, suppose a shop owner, suppose a shop owner has a customer data. Okay, which type of customers are buying from him, the products from him. Okay, so using clustering, you found like student clusters grouped together. You had a suppose this is a student cluster. Okay, you group that together using clustering. Second one, the high income customers grouped together by you. Okay, and third one, premium customer grouped together. So we got three different, suppose this is a graph. Okay, we got three different types of clusters, three different type of categories for student customers, high income customers, and premium customers. We group together, and this will help business in a way targeting ads. Okay, recommend products, okay, and improve marketing. So this is a kind of real life example how we can use clustering. Okay, so that's all in this video. This is all about basically overview of unsupervised learning and clustering for you. From the next video, we will see unsupervised learning algorithm. In the next video, we will see k-means algorithm. Okay, so that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss k-means clustering. So what is k-means clustering? Basically, k-means clustering is an algorithm that divides data into k groups, means clusters where similar data points stay together. What it means? Suppose I have these data points, okay, before k means, and after we apply k means, it basically grouped the similar items into one cluster. This is one cluster, this is one cluster, and this is the another cluster. Okay, so it grouped all the similar item into one cluster. Okay, that's what it does. K means clustering. Okay, so before we do practical of it, we must know about some terms. Okay, first understand what is WCSS, within cluster sum of squares. Basically, WCSS measures how close data points are to their centroid. Centroid means average position of all points in cluster. Average position of all points in the cluster. Okay. So it calculates how close data points are to their centroid. Okay. Lower WSS means better clustering. Okay. So now, second thing, elbow method. So basically, the elbow method is used to find the best value of k in k means clustering, means number of clusters. It basically elbow method help us to find the best number of cluster where we should uh, take three number of cluster, four number of cluster. Here we have three number of clusters where we should take three clusters, four clusters, or five cluster. Okay, so how many clusters should be created? Okay, for example, k is equal to 2, 3, 5. These are number of clusters. Here you can see there are three clusters, and we can basically get the answer how many cluster we should take. Okay, for my data. Now, choosing the wrong K can give poor clustering results, obviously. So, elbow method help us to select the optimal number of clusters. Okay. Next thing is elbow point. When we plot a graph on x-axis number of clusters and on y-axis WCS. Okay, when we will plot this graph, then you will see like this kind of graph. Okay, always you will see like this kind of graph where basically the graph will bend like an elbow. Like here you can see the graph is bending like an elbow. Okay, like this. It is your elbow, and here you can see this is bending like an elbow. This is your perfect number of clusters. You should take four as your total clusters. Okay. So this is what elbow method, and this is your elbow point. This is your elbow point. Okay. So that is what elbow point WCSS and elbow method. Now let's see how we can do it practically. How we can perform k-means clustering practically. Okay. So basically on this data set, here you can see I have iris data set, and here you can see I don't have the output. Okay, I don't have the output. So we will perform the k-means clustering on this iris data set, which have in which I have only inputs. Okay, now first I will import some required libraries and as PD import matplotlib dot pyplot else plt import cborn as sns. Okay, now I will load my data set. Let's say data is equal to pd dot read slash csv. Okay, this is my data set. I will right click, copy path, and control V. I will check my data is loaded or not by checking its first three rows. Okay, so my data gets loaded, and these are my first three rows. Okay, now first condition is your data should be linear when you are performing k-means clustering. So we will check that by using a pair plot. Pair plot. Okay, data is equal to data plt dot show. Okay, now here you can see here it is basically following it is following linearity, right? Here you can see. Okay, here you can see it is following linearity, so we can perform our k-means clustering on this data set. Okay, now first I will import k-means from sklearn dot cluster import, and for unsupervised learning you will not need to basically divide your data set into input and output and training and testing. Okay, you will not need to do that. Okay, that only works for supervised learning. Okay, import k-means. Okay, now let's make WCSS. Okay, let's make WCSS. I have already discussed what is WCSS. Okay, basically it measures how close the data points are to their centroid. Okay, now let's make the WCSS. Okay, I will give a for loop for I in range Let's take 2 to 21. Okay, let's take km is equal to, call your k means I've created an object km. Here you can see shift plus tab. Here are some basically hyperparameters you can use. Let's take n clusters as your I, n clusters as I. Okay, and let's init, we will, you can simply copy. Okay, now now I will fit my data. Km dot fit data. Okay, now I will append my WCSS dot append by km dot inertia. Okay, km dot inertia. Okay, now I will plot a graph to check my elbow point, how many clusters which I should take. Okay, now let's make a graph. Plt dot figure. Let's take fig size is equal to 20 comma 5. Okay, now plt dot plot, what we are plotting, I for I in range, I for I in range 2 to 21. I have taken to put 2 to 21. Okay, now give WCSS and take as marker as O. O. Okay, now let's take plt dot x label. Suppose I will take number of clusters, number of clusters into my x-axis. Plt dot x sticks, plt dot x sticks. Again, I will take the range I for I in range 2 to 21. Okay, now suppose I will take y label as WCSS, WC, WCSS. Okay, now I will give the grid plt dot grid on x-axis. Okay, on x-axis. Now plt dot show. So here you can see your elbow point. So it is looking like our elbow point is here, right? It is bending here. So here you can see in the notes also where the graph will bend, that will be your elbow point. So here you can see graph is basically bending on 3. Okay, so I think we should take 3 as our total number of clusters. Okay, So you can see the elbow point is coming here. Okay. Now let's take an object again. Call your k-means. Okay. Now pass your clusters and clusters is equal to 3 because it gave me 3. It is bending on 3. Okay, so we are taking 3 as our clusters. We are telling that give me total 3 numbers of clusters. We will have only 3 type of categories in our output. Okay, now I will predict 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 data. Now it gave me the output. Okay, it gave me the output. Here you can see 0, 1, 2. There are only 3 types of categories it gave me. Okay, so now we have 3 different type of categories in our output. Let's uh, load this into our new column of our data. Let's take in this predict. Okay, I will simply copy this. Control C. I'm loading this output into my new column. Okay, now I will check my data. Yeah, you can see predict. Now I have my output 102. 3 different types of categories. Okay, and you can remember in our iris data set, we we will always have 3 different type of categories: versicolor, virginica, and setosa. Here we are getting also 3. Okay, so this is my predictions. Now I will make a graph, pair plot. Data is equal to data. Okay, I will give predict. Okay, okay. Now plt dot show. Yeah, it plotted the graph. Now let's compare this graph by our original data. So on this data set, I have performed k-means clustering, right, where we didn't have the output. Now let's plot a graph on actual data. This is my actual data where I have output also. Okay. Now let's make a graph of on our original data to compare this. Okay. I will load my data set. Suppose I will my data pd.read slash csv. This is my actual data. I will right click, copy path, control V. I will check my data is loaded or not. Yeah, my data gets loaded. And these are my first 3 rows. Now let's plot a graph for it also. Dot pair plot the data is equal to my data. I will give hue parameter as my species. Okay. Now plt dot show. Now you can compare your predicted output and your actual output. Okay, this is looking like same, right? Look at the graph. look at this pair plot. Okay, look at this ones, and now look at your predicted data, your sorry predicted uh, data graph. Okay, it is looking like same, right? So this is how k-means clustering works. Okay, so that's all in this video. In the next video, we will see hierarchical clustering. Okay, so thank you. Hello guys, welcome to the channel. Today we will discuss hierarchical clustering. So what is hierarchical clustering? Hierarchical clustering is an unsupervised machine learning algorithm used to group similar data points into cluster. Obviously, it is a it is a algorithm of unsupervised learning. Okay, so it will group similar data points into clusters. Okay, so it creates a tree-like structure of clusters called a dendrogram. Okay, unlike k-means, if you can remember, we used uh, basically elbow method. We plotted a graph and analyzed by elbow method how much cluster we should take. Okay, but in hierarchical clustering, we will draw a dendrogram. Okay, to know how many clusters we should take in our algorithm. Okay, to fit the data. Okay, so what is dendrogram? Dendrogram is a tree diagram showing how clusters merge. For example, look at this. This is a kind of dendrogram. Okay, so bottom you can see individual points 1, 2, 3, 4, 5, 6 like this, and top one largest cluster. Okay, one largest. Okay, now how to choose number of clusters? We cut the dendrogram at a certain height. For example, cut at height 5, maybe 3 cluster, cut at height 10, maybe 2 cluster. Rule. Choose the point where the vertical distance is largest. Okay. So here you can see it is the largest line we can see. Okay. So here we can see it is dividing the graph into two parts, the orange one and the green one. Okay. If I will cut if I will cut it, so it will, I think I will be able to cut here. So we can basically cut it into two parts. Okay. So that means it is saying that we should take two clusters. Okay. We should draw two clusters. Okay. That's what it is saying by dendrogram. Okay. So So there are two types of hierarchical clustering. Okay, first agglomerative clustering. It is its approach is bottom to top, and this this clustering we will see. Like commonly, we only use this cluster. Okay, not the second one. So how it processes? Starting with each point as its own cluster, merge the closest cluster repeatedly, and continue until all the clusters become one cluster. Suppose it will take, I have A, B, C, D. It will take individual A, B, C, D, and then it will continue till A, B, C, D will be together, will become A, B, C, D. Okay. Till then it will process. Okay. That's what agglomerative clustering, and this clustering we will use. It is not commonly used divisible clustering, sorry, divisive clustering. Its approach is top to bottom. It starts with one big cluster. Totally, it's opposite of agglomerative clustering. Okay, start with one big cluster and then split clusters repeatedly, and then continue until every point becomes separate. Okay, like it started with A, B, C, D, and then it separated all the characters A, B, C, D like this. Okay. And here are some linkage methods. So what is linkage method? When clusters contain multiple points, we need a way to calculate distance between clusters, right? So these methods are called linkage methods. So There are four types of linkage method. Single linkage, distance between the nearest points of two clusters. Complete linkage, distance between the farthest points of two clusters. And average linkage, average distance between all points. And last one, word linkage. Merge clusters that minimize variance. Okay, so now let's see how we can perform hierarchical clustering practically. Okay, so this is my data set. On this data set, I have performed k-means clustering also. So here you can see I have only input and I don't have the output. We need to guess the output, how many categories are there by plotting a dendrogram. Okay, so I will basically do hierarchical clustering for this data set. Now, first I will import some required libraries. Datasets 3D import matplotlib.pyplot as plt import cborn as essence. Okay. Now I will load my data. And one more condition is to apply hierarchical clustering is your data should be linear. Okay. It should follow linearity. Okay. We will check that by plotting a pair plot. Okay. pd.read/csv. I will, this is my data. I will right click, copy path. I will paste it. I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded. Now let's plot a pair plot to check it is following linearity or not. Okay, I will take data as data because in data variable I have loaded my data set plt dot show. Now you can see in my previous video also when we were doing k-means clustering, we already seen so this iris dataset is following linearity. Okay, so we can perform hierarchical clustering also on this dataset. Okay, so now I will make dendrogram. I will give a markdown here making dendrogram. I will give a markdown shift plus enter. Now I have to import scipy from scipy dot cluster, sorry, cluster hierarchy. Okay, hierarchy. Here, as let's say SC. Okay, now let's plot a dendrogram. I will give some figure size. Fig size is equal to, let's take 2010. Now I will write sc dot dendrogram. I will click shift plus tab. Here you can see some hyperparameters. Okay. Now I will give sc dot linkage. Okay. I will give my data. What method? What linkage we should use? Let's take single. Okay. I have already explained all the types of linkage, and I will check. These are some methods. Okay. Now let's take okay metric as QDN. Let's take this. Now I will use PLT dot show. Now you can see the dendrogram, right? So this dendrogram, if you can see, it is dividing my graph into two parts, this orange one and this green one, right? And this is the biggest line you can see around 1.6123 like that. Here it is reaching now. Okay. So uh, if I cut this line, so where first cut we can do here around 0.8 or something, here we can cut. So we can see we can cut it into two parts, okay, and it is dividing also my dendrogram into two parts, okay, first the orange one and the green one. So it is saying that take total two clusters, okay, means it is saying we can draw two clusters, we should draw two we should basically give two clusters, means we will have we will have two number of categories, only two number of categories. Okay. Now I will import sklearn dot cluster import agglomerative clustering, right? The first one, first type of clustering, we generally use this clustering only. Okay. Now, now let's take an object to call agglomerative clustering. Okay. Now, so I'm giving n clusters as two as suggested by my dendrogram, right? I will taking two. I'm taking two. Uh, Linkage. Let's take single. We want basically we want the distance between the nearest points of two clusters. Okay, so that's why I'm taking single. Now I will fit and predict from the data. Okay, now you can see there are only two categories, 0 and 1. Okay, there are no two, means it is giving only two categories. Okay, because we are given n cluster has two. Okay, now I will store this. I will store this output into my new column. Let's take predict column to store this. Sc.fit predict data. Right now, now let's see our data. Now you can see my output column is there. In starting, we didn't have the output column. Now we have the output column also predict. Now let's take make a plot. Sorry, let's plot a pair plot. Okay. Now I will give data as u parameter. I will give predict, right? Because that is my output. Now plt dot show me the graph. Okay. Now you can see there are two classes. There are two classes. Here you can see. 0 and 1, 0 and 1. Okay. So this is how my graph is looking like with the output. Okay. So we covered the hierarchical cluster, how we can get clusters and we can get output from hierarchical by a hierarchical clustering. So that's all in this video. In the next video, we will discuss DBSCAN clustering. Okay. So thank you. Hello guys, welcome to the channel. Today we will discuss DBSCAN clustering. So what is DBSCAN? DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. Okay. It is an unsupervised machine learning algorithm used for clustering. Okay. So unlike k-means, what DBSCAN do? DBSCAN does not require the number of clusters beforehand. Okay. It can detect irregular shaped clusters. It can also identify outliers or noise points. Okay. So these are some benefits of DBSCAN. Okay. So let's understand this using a real life idea. Okay. Imagine people standing in a park. Okay. So areas where many people stand close together, it will form a cluster. Okay. Understand this. In a park, people are, there are so many people are standing. Areas where many people stand close together, it will form a cluster. And people standing alone far away, that is an outlier. Okay, understood this? So DBSCAN works exactly like this. Okay, it groups points based on density, where many people stand close together, it will form a cluster. And people standing alone far away, it will consider as an outlier. Okay, understood this? So so basically, in DBSCAN algorithm, it uses we generally use only two parameters. Epsilon, eps means the maximum distance between 2 points. Okay, to consider them neighbors. Okay, think of it as a radius around a point. Okay, if another point lies inside this radius, they are neighbors. Okay, and second one is minimum points. Minimum number of nearby points required to form a dense region means cluster. Okay. For example, I have taken mean samples is equal to 5 means at least 5 points should exist nearby to create a cluster. Okay. So that's what it means. So let's see how we can perform DB-scan clustering practically. Okay. So this time I will import a data set from sklearn only. Okay. So first I will import some required libraries as pd import matplotlib dot pyplot as plt import keyboard as sns and from sklearn datasets there is a make moons dataset, which is a type of which is a problem of classification dataset. Okay, import make moons. Okay, I will show you by plotting a graph. Although, okay, so let's take x and y, and I will call my dataset make moons. Okay, now suppose I will take some n samples. N samples means total records. How many rows you want to take? Suppose I will take 250. Okay, I'm taking 250. What noise you want to add in your dataset? Suppose I'm taking 0.05 as my noise. Okay, now let's see my x. So here you can see there are two columns forming into my x. These are my input. This will be my input. Okay, this is my x. There are total two columns. Let's see why. and this is my output. Okay, this is my output. Let's store this. Okay, how we can store this? Because I will keep this here. I will suppose I will store this. Suppose I will take df is equal to, I will make a dictionary. Suppose I will take column one. So in column one, I will take the first column of X. See, there are two columns I have shown you into my that was into my X. Those were my input columns. So first I will take my X. First column will be my give me total rows and zero means give me the zero means give me the first column. Okay. In column one, I have taken the first column, and in column two, I will take I will take X X second column, that is 1. Okay, so X I have taken column 1, column 2, and let's take Y, and it will be my Y. Okay, okay, let's give this output. Okay, there are three columns, column 1, column 2, and column 3. X X first column is my input column, X second column is my input column, and third is my output column. Okay, let's take this. Now let's create a df train. Df train, I will take my input columns, right? These two are my input columns. Okay, I have taken my input column. Now input columns are there in my df train. Okay, now let's transform this into data frame. Data, let's take data train as a variable. Okay, called pd dot data frame. Data frame. Now I will give df train. I am transforming to data train. I am transforming data train to my df train. Okay. Okay. Now I will transform df also. Let's take data. Data is equal to pd dot. Again I will call data frame, and then I will call my df. Okay. Now let's check how is your data is looking. Data dot head. See, it is my first column, it is my second column, and this is my output column. Okay. In df train you have, let's sorry, data train dot head. I will show you this also. Yeah. In data train I have input columns. Okay. Now let's plot a graph. Let's plot a scatter plot to see the data, to see how data is distributed. Okay. Let's give x is equal to column 1, y is equal to column 2. Okay, let's give data as data because my main data is in my data variable, and q parameter I will give output. Okay, output I will give plt dot show. Yeah, this is how my data is distributed. Okay, now let's build a model. Okay, let's from scalar dot cluster import dbscan. Okay, I have imported my dbscan. Let's make an object to call dbscan. db is equal to db. I will I will let's make an object to call db. Okay, now I will give my parameters. What parameters we generally take? We take epsilon, which is my radius, and minimum samples. Okay, means at least like minimum number of nearby points which we require to form a dense region. Okay, now uh, let's take EPS is equal to 0.02. Let's take this. Okay, let's take 0.2. Okay, and let's take minimum samples as 5. Let's take 5. Okay, let's take this. Now I will predict db.predict predict. Okay, I will give my data train. Okay, this is my data train I am giving db.predict. So it predicted the outputs. Okay, you can see here it predicted the output through by training the model. Okay, now let's store this into my data train. Okay, we will compare by plotting the graph, my predicting graph and my actual graph. Okay, data train and I will take, suppose I am giving predict as a, I am storing these outputs in my predict column in data train. So I will simply copy this. I am storing this into my predict column of data train. Okay, now let's plot a graph to compare. This is my actual data, graph and my predicted graph. Okay, I will compare that. Now SNS dot scatter plot. I will give x is equal to I will give x is equal to column 1, y is equal to column 2, and uh, I will give data as is this time I will give data train to compare for comparing. Okay, I will give data train. Now I will give due parameter as predict. Okay, predict. Now plt dot show. Now can you see the predicted graph here? And can you see the actual graph? Okay, so this is how we made predictions using DBSCAN algorithm. Okay, DBSCAN clustering. Okay, so this is how DBSCAN works. Okay, so that's all in this video. In the next video, we will discuss Silent score. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss Silent score. So what is Silent score? Silent score is method used to check how good our clustering is. Means you have like chosen cluster number as 2, 3 for building the model. So it will tell us that you have basically chosen the correct cluster number or not. Okay, all data it tells us all points correctly placed in their clusters, all clusters clearly separated from each other, and this silent score is used in unsupervised learning algorithms like k-means clustering, hierarchical clustering, DBSCAN clustering. All these three clusterings algorithm we have seen practically in our previous video, right? So understand this. This is very important. range of silent score -1 to 1. Okay, so the score of choosing the cluster number will always lie between -1 and 1. Now, if your score of choosing the cluster number is close to 1, then it is excellent cluster, means you have chosen the right number of clusters. Okay. But if your cluster numbers score is close to -1, then it is wrong clustering. Okay. You should not choose that number of cluster you have chosen. Okay. And around 0 clusters overlap. Okay. So we will always try to reach to close to +1. Okay, so let's see how we can perform silent score, how we can check we have chosen right number of clusters or not by silent score. Okay, let's see. So I have already explained k-means clustering. Okay, so what I will do now is I will simply copy paste starting code of k-means till the model building of by k-means clustering. Okay, I will simply copy paste. Then I will perform silent score. K-means clustering and these all clusterings, k-means, hierarchical clustering, DBSCAN, I have already explained practically. Okay, I don't need the plotting k-means. Okay, now so 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 when we were building our model, then we saw by elbow method we got three number of clusters as three. Okay, right? So in that case, when we are building our model using k-means clustering, we have chosen the n number of clusters as three. Okay. Now we have taken the three number of cluster that is right or not, or we can choose different number of cluster which is perfect for our prediction. Okay, now so so I think, yeah, I will copy this also. Okay, now I will check KMN. This is my object where we have called k-means. Okay, I will check labels. Okay, means the output labels. Now you can see as we have chosen three clusters, then we are getting three different type of categories: 0, 1, and 2. Right? Now let's check we have chosen right number of clusters or not from sklearn dot metrics import. I will import silent score. Silent. Okay. Now let's check the silent score of this model we have built. Okay. Let's check. Now I will have to give my data and labels as I will give, sorry, I will give labels as my KMN dot labels, right? Now let's check. So we are getting 0.68, which is not very near to plus +1. But yeah, although it is saying that this model is also good. Okay. Now let's check. We can choose the different number of cluster, better number of cluster or not by plotting a graph. Let's make a list of Silat score where number of clusters I will take 2 to 21. Okay. I will make a list J for J. I will take in range 2 to 21. I will take. Okay. Now I will give a for loop for I in range 2 to 21. 2 to 21. Let's take km1 I am taking as a variable. Suppose km1. K means I will call K means, and I will give now n number of clusters as I from 2 to 21. Okay. Clusters as I am taking as I 2 to 21. Okay. Now I will fit my data into it. Dot fit into data. Okay. Now let's append my Silat score from which I will append Silat score, Silat score data, and I will this time I will take labels of km1 because I have fitted my data into km1. So km1 dot labels. Okay. Now I will append my data. Now let's plot a graph to check if I can take different number of clusters or not. Which number is better for us for taking cluster? 3 or not? We have taken 3 as our cluster. Here 3. Now I am checking if I can take different number of cluster or not. Plt.plot. I will take number of cluster and our SS because SS in SS I have appended the all Silat scores from range 2 to 21, right? Now I will give some plt.x label. What should I will give? I will give number of clusters. Number of clusters. Okay. Now on y label, suppose I will give as let's take Silat score. Silat score. Okay. And I will give plt dot xsticks as number of cluster. Okay. Now I will give grid so that I can check which value I can take. X is equal to I will take suppose x. Okay. Now plt dot show. Now you can take basically it is saying here you can see it is giving 3. Okay. 3 as highest Silat score, right? It is I got 0.68 as Silat score. This is the maximum Silat score I am getting from the range of 2 to 21. Means I am saying that from 2 to 21, which number of clusters I should take. So it is saying that from 2 to 20, basically, sorry, not 2 to 21, from 2 to 20, 2 to 20, the best number of clusters you can take is 3 because you can check the highest value is on 3 number of clusters in 3, right? You can check around 0.68 and next is on 2, but already I am getting the highest value of Silat score on 3 number of clusters, so it is saying and I'm checking that it should be close to 1. Okay, so on 3, which is I'm getting around 0.68, so that is the closest point of 1 here in this graph. So it is saying that the best number of cluster you can choose from 2 to 20 is 3, because it is the it is close to 1 with respect to others. Okay, so that's how we can check silent score, and the clusters I have taken is correct or not by using silent score. That's how we can check. And yeah, we have chosen the right number of clusters, which I got to know about by plotting this graph. Okay, so that's how we can check total number of clusters we have taken is correct or not by silent score. So that's all in this video. So in the next video, we will see association. Okay. So thank you. Hello guys, welcome to the channel. Today we will discuss association rules. So what is association rule learning? Okay. So association rule learning is an unsupervised machine learning technique used to find hidden relationships or patterns between items in data. Okay. Now let's understand this slide. It answers questions like people who buy bread also buy butter. Okay, means people who are buying bread are also buying butter or not. Like it it find answers of these type of questions, like customers who buy a laptop often buy a mouse also. Okay, users watching one movie and also watch another movie which is related to that movie. Okay, so these are the type of questions which answers association association rule. Okay, so it is mainly used in market basket analysis, recommendation systems, e-commerce, retail stores, medical analysis. Now let's understand this by using a real life example. Now, suppose a supermarket has this data. Okay, first customer, bro- first customer bought bread, butter, milk together. Okay, second customer came. He bought bread, butter. Third customer came. He bought milk, eggs. Fourth customer came. He bought bread and milk. Fifth customer came. He bought bread, butter, and eggs. Okay. Now, so what we discovered from this data? Look at this data carefully. Okay, what customer one, 2, 3, 4, 5 bought? You will find customer who buy bread. Here you can see four customer have bought bread, often buy butter also. You can look at this. Bread, butter, bread, butter, bread. No, it is not butter. So yeah, here you can see again butter. So this relationship is called an association rule. Okay. So understood this association rule concept by this real life example, and these are some examples of questions. Okay, now there are some important metrics in association rules. These metrics decide whether a rule is good or not. Okay, first is support. Support tells how frequent an item set appears in the data set. Okay, so its formula is transactions containing A and B upon total transactions. Okay, for example, suppose total transactions are 10. Okay, number of total transactions are 10. Now bread and butter together appear four times. Four times. Look at this. Now divide 4 upon 10. You will get 0.4. So it means 40% transactions contain both bread and butter. Okay. So we found this using support. Okay. Now look at the second one. That is confidence. Confidence tells if A happens, how often B also happens. So its formula is support A intersection B upon support. Okay, support A. Okay, support A. Now, suppose bread appears 5 times, then bread and butter together 4 times, right? Now, look at this. Divide 4 by 5. You got 0.8. It means 80% people buying bread also buying butter, right? 80% people. Okay. So this I got from confidence. Okay. Now third one is lift. Lift tells how strong the relationship is between A and B. Okay. So its formula is confidence of A and B, A to B, and upon support B. So if lift is equal to 1, I got the value of lift as 1, then there will be no relations. Okay, no relations. If lift is greater than 1, positive relationship. If lift is less than 1, negative relations. Okay, now let's understand what is the working process of association tools. Okay, I always try to basically give basic language notes. Basically, I always try to give you the notes in basically basic language and with clear explanation. Okay. Now understand. We understood the three different metrics in association rules. Now understand working process of association rules. First, find frequent items. Okay. Find items combination appearing frequently. We saw we are getting bread and butter frequently, so we found this. This is step one. Now step two, generate rules. Create rules from frequent item sets. Example, bread to butter, butter to bread, right? Generate rules. And then calculate support, confidence, and lift. And check whether rules are useful. So this is how association works. Okay. This is the concept of association rules. Okay. So there are two different algorithms of association rules, that is a priori algorithm and FP growth algorithm. We will basically see both algorithms in our next video. Okay. Practically, theoretically, or and practically also. We will understand both of these. Hello guys, welcome to the channel. In this video, we will discuss a priori algorithm. In our previous video, we have discussed association rule. Okay, what is association rule? If you have not watched that video, please watch that video first and then come to this video. Okay, so what is a priori algorithm? A priori algorithm is a machine learning algorithm used for association rule mining. Okay, let me give you a quick recap of association rule. So, association rule learning is an unsupervised machine learning technique used to find hidden relationships or patterns between items in data. Okay, it answers questions like people who buy bread also buy butter or not. Customers who buy a laptop often buy a mouse also, right? Users watching one movie and then also watch another movie which is related to that movie. Okay, so these are the questions which for which we find answers by association rule. And there are two types of algorithms of association rule, that is a priori algorithm and FP growth algorithm. In this video, we will discuss a priori algorithm. Okay, so let's see its some important metrics. Okay, first is support. Support tells you how frequently an item set appears in the dataset. Formula is this. Transactions containing A and B upon total transactions. What it means? Suppose you have total transactions 10. Okay, total transactions as 10. And bread and butter together appears as 4 times. Okay, so you will divide 4 by 10, you will get 0.4. It means what you got, 40% transactions contain both bread and butter from 100%. Okay, this is what you got from support. Okay, now second one is confidence. If A happens, how often B also happens? So its formula is support A intersection B upon support A. Okay, support we have already calculated here. Now let's suppose bread appears 5 times and bread and butter together appears 4 times. Okay, so I will divide 4 by 5 is equal to, we got 0.8, means 80% people, if they are buying bread, then they are also buying butter. That is what we got from confidence. Now, third one. Third one is lift. Lift tells you how strong the relationship is between A and B. Now, it will it will take confidence A to B and upon support B. Okay. We also already discussed what is confidence and support. Now, if you got lift is equal to 1 as your value, then it means there is no relationship between them, A and B. Lift is greater than 1, it means positive relationship between A and B. Now, if lift is less than 1, then it means it has a negative relationship between A and B. Okay, these are the three important metrics which is used by association rule. Now let's discuss a priori algorithm. A priori algorithm is a machine learning algorithm used for association rule mining. Okay, its job is to find like these questions answers, like which items are frequently bought together, which events occur together, or which products have strong relations. Okay, suppose you have this data set. Okay, customer one came. He bought milk and bread. Second one bought milk, bread, and butter. Third one bought milk and butter. Fourth one bread and butter. And fifth one milk, bread, butter. So after you applied a priori algorithm on this, what you got? People who buy milk often buy bread. This pattern you got from a priori algorithm. Okay. So people who buy milk often buy bread also. So see here, he bought milk and bread also. Milk, bread. Here we didn't get the milk and bread together, but yeah, here bread and butter. Here again milk and bread. So people who buy milk often buy bread also. So people who buy milk and bread often buy butter also. Okay. So this is what we notice the pattern by the help of a priori algorithm. Okay. Now let's discuss how we can perform a priori algorithm practically on a data set. Okay. So let's see how we can do it practically. Now this is my data set. Okay. Here you can see total items are 20, and here you can see first customer brought 3 products. Second customer bought 1 product. These 3 products and then 1 product, and then customer 3 purchased these 2 products, and then again customer came. He bought 3, 4, 5, 5 products. Okay, so how we can identify which products are getting purchased multiple times. Okay, how we can do that? How we can notice that? By using a priori algorithm. Let's see how we can do it. Now, first I will import pandas std. I will load my data set pd.read plus csv. Now, this is my data set. I will right click, copy path, control V. Now, data.head. Now, my data gets loaded, and these are the first 3 digits. Now, let's check data.save. Now, it means I have 20 columns and total 7,500 rows in our data set. Okay. Now, if you notice, item one has first record as it is not nan. it has some value. Okay. If you will see item 4, first record is nan. Now let's check both data type. Okay. So how we can check that? Type data item 1, item 1, first record I'm checking. So give 0. Sorry. So this is the string data type. Now let's check for nan. So if I will check item 4's first record, then it will provide me. Yeah, nan is a float data type. Okay. Now what I will do is I will first make a list to store those values which has string data type. Okay. Let's suppose I will create a list called market. Now I'll give a for loop I in range, I in range 0, data dot shape 0. Okay. Now let's make an another list to append market. I will this time I will give j for j in data dot columns. I will give a if condition if type of data j and I is string, then append my customer, by which I will append this one data j and I. Okay. Now let's append my market also by appending by customer. To customer, I will append my market also. Okay. Now I will make another list called list. I will give a for loop for I in market. I will write for j in I list dot append I by j. Now I will import collections. Import collections to basically see all the categories and their numbers, how many times it got purchased. Okay. So I will write collections dot counter counter my list. Okay. Now here you can see mineral water is purchased 1,787 times. Eggs is purchased 1,348 times. Okay. So this is the list we got every for every product. Okay. Now let's store this in a variable. Let's store this in a variable. I will suppose take P. Okay. Now, if I will show you P dot keys, means show me all products. So here are your all products. Okay. P dot keys. And if you want to check their values, P dot value, sorry, values. So here are the values. Okay. Burgers 654 times, meat, meatballs 157 times, eggs 1348 times. Yeah. Okay. Now, now let's store this both p dot keys and p dot values. Okay. In a data frame. Suppose I will give some name, item name, item name as p dot keys. In this, I'm saying in item name column, give me all p dot keys, and in suppose values column, give me p dot values. Okay, I'm saying this. Now, now let's convert this into a data frame. DM. I will sort values. Okay, sort values by values. By values. I will sort the values by values. Why we are sorting? Because we want the data in descending form. Default setting by default setting we will get the data by ascending order. So I will write ascending is equal to false. Okay. So yeah, here you got the values. Okay. Now, now I will import from ML extend dot pre-processing pre-processing. If you don't have ML extend, just open your CMD. Just open your CMD here. CMD is a command prompt and just write pip install ML extend. Okay, and enter. It will be downloaded in your system. Okay. Dot transaction encoder import import transaction encoder. Okay. Now, now let's create an object tr to call my transaction encoder. I will fit my market data into it. So what it will do, so first here you can see by your data frame, mineral water, we basically set ascending is equal to false. So we are getting the uh, data into descending form. So here you can see most of the in every product, most purchased product is our mineral water. It gets purchased 1787 times. Now next one is eggs, which got purchased by 1348. Okay, so now what TR transaction, basically transaction encoder will do here, it will convert transactions into a true false table. Okay, true false table. It is just a warning. You can ignore this warning. Okay, so it gets fitted. Okay, now let's suppose I will make a new variable and I will convert it into a data frame where I will give this uh, tr. I will give tr dot transform. Tr dot transform. I will give market and I will give columns as tr dot columns slash. Okay, tr dot column because transaction encoder I have called by tr. So that is a spelling mistake. Okay, now if you will see your new dir, it will look like this. Here you can see what it means. False, false, false. Means here you can see though first customer came, this products he didn't purchase. Okay, he didn't purchase. Now the second customer came, these products he didn't purchase. So this is what it classified by true false. Okay, that's what transaction encoder do. It will convert your transactions into a true false table. Okay, now I will perform my a priori algorithm from ML extend dot frequent patterns. I will go for frequent patterns. I will import a priori. Okay. Now, now let's give a priori. You will click here Shift plus Tab. Here you can see there are some hyperparameters. Now we will have to give our first is your data set. So what is my data set here? New df, right? New df. Now again shift plus tab minimum support. Suppose I will give minimum support as 0.05. Suppose I will give 0.05. Okay. Now suppose use column. I will set this by true. I want the column use column names. I will set this by true and let's suppose I will give max length that is my I think max length. Okay, max length I will set as 3. Okay, now I will sort this also, sort values by which I will sort, by which column I will sort support. Okay, now 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 I got the data. Now you can see I'm getting mineral water and eggs together. Okay, mineral water chocolate together. Okay, so these are some values which are getting we are getting together. Okay, these are purchased mostly. Okay, these are purchased mostly. Soup was purchased mostly. Mineral water and eggs together was purchased mostly. Then cooking oil. Okay, granted cheese, mineral water and chocolate, whole wheat rice, mineral water and spaghetti, chicken, turkey. Okay, these are the values we got. Okay, so that's how a priori algorithm works. Okay, so that's all in this video. In the next video, we will discuss FP growth algorithm. Okay, so thank you. Hello guys, welcome to the channel. Today we will discuss FP growth algorithm. In our previous video, we discussed a priori algorithm. If you have not watched that video, please watch that a priori algorithm because initial steps are same for FP algorithm, FP growth algorithm as a priori algorithm. So I will not like do practically from scratch for FP growth algorithm. So please watch that a priori algorithm video first. Okay, then come to this video. So FP growth algorithm is a frequent item set mining algorithm. Okay, used in association rule learning. Its main purpose is to find items that are frequently bought or used together. If you will find same thing I have did through a priori algorithm. Okay, so basically it also does the same thing. Okay, so suppose we have these transactions like transaction 1 bread milk, transaction 2 bread diaper eggs, transaction 3 milk diaper cola. Okay, so these are transactions and these items were bought by the customer. Okay, so basically, FP group helps us find patterns such as the customer is buying bread, he is buying milk also. If someone is buying bread milk, then they are buying diaper also. So these patterns which we can find by FP growth algorithm. So basically, you will find that we are doing the same thing by FP growth algorithm what we have did by a priori algorithm, but there is a difference. Why FP algorithm was introduced? So the previous algorithm a priori had a major drawback. Okay, it generates a huge number of candidate item sets, right? So when you will work with larger data sets, then it will consume by a priori algorithm. It will consume more memory uses and more database scans and slower execution. So to counter this problem, FP growth algorithm was introduced. Okay. So FP growth algorithm solves this problem by no candidate generation, fewer database scans, and faster execution. Okay, that is the difference between a priori and FP growth. So main idea behind FP growth algorithm, instead of generating candidate item sets like a priori, FP growth stores transactions in a spatial tree structure, okay, called FP tree, frequent pattern tree. Okay, the tree compresses the data set while preserving important information. That is the this is your important information. Okay, so let's see how we can perform FP growth algorithm practically. So again, for performing FP growth algorithm, I am using the same dataset which I have used in a priori algorithm. So this is my dataset. I have already discussed about this dataset. Okay, basically I have 20 items. Customer one is buying these three items. Customer two is buying this one item. Customer three is buying these two items. So that is how this data set is prepared. Okay, so I will use this data set for FP growth algorithm. So what I will do is I will copy the initial steps of a priori algorithm in our FP growth algorithm because initial steps are the same. So I will copy initial steps for a priori for from a priori algorithm to FP growth algorithm. These steps I have already discussed in a priori algorithm, right? So if you have not watched that a priori algorithm video, please watch the video. I have explained all the steps here. I have explained all the steps. Initial steps I will copy from a priori algorithm. Okay. And at the last I will I will basically perform epigrowth algorithm. Okay. So I will copy paste from initial steps. Okay. So my data set gets loaded. So data.shape is will be same because we are using the same data set. These steps I have already discussed. Okay. These steps I have already discussed. You can watch my previous video of a priori algorithm. Okay. Then come to this video. Because initial steps are same, so that's why I'm not explaining the initial steps. I've already explained these steps. So initial steps are very same. Okay. I've created a market list where I have string values. I will store those values into the market. Okay. Then I imported collections to see basically the all the items, how many times they are getting purchased, how many times they are getting purchased. Okay. For example, mineral water is purchased 1,787 times. Eggs were purchased 1,348 times. Okay. So that's what it is telling me. Now I will store this into a variable. I will see the my all the categories, my all the products. Okay. I will see their values, how many times they were purchased. I've explained all these steps. You can watch my previous video of a priori algorithm. Then I have stored in a new variable of these keys and these values uh, in a new variable. Okay. Then I transform this into a data frame. Sorry. Now next I converted this table into true false table. Items are getting purchased, that is true. Items are not getting purchased, that are false. Okay. These steps I have already explained. So yeah, this is a warning. This is not an error. You can ignore this. Then I have stored this into a new variable, new df. Now you can see the table, true false table basically. Okay. Then in the last step, in previous video I have applied a priori algorithm. In this video I will basically take FP growth algorithm. Okay. So from ML extend dot frequent patterns import FP growth. Okay. Now I will take FP growth. So if I will click Shift plus Tab, Then these are their hyperparameter. First, df means take your data. So my data is new df, new slash df. So this is my data. Again, shift plus tab, minimum support. Suppose I will take minimum support. 0.5 means here it is taking 50%. But minimum support here default value is 50%. But I will not take 50%. I will take 5%, 0.05. This is 5% and 0.5 means 50%. So if I am taking minimum support is equal to 0.05, what it means? So we are saying that item set will be considered frequent only. Like we are saying that by taking minimum support 0.05, set will be considered frequent only if it appears at least 5% of all the transactions happening. Okay, that's what I'm saying by minimum support is equal to 0.05. Now let's check other parameters. Other parameters use column names is equal to false. It is the default value. But I will do true. I want the column names. Okay. Now again shift plus tab. Max length is none. Let's take max length is 3. Let's take as 3. So what is the meaning of max length and why we are taking 3? So what it means? I am saying that the maximum size of item sets to generate, basically 3 item sets. So suppose 3 item sets are purchased together, bread, egg, and milk. Then it will show me. Suppose one item set is purchased, that will be shown. If 2 items are purchased, milk and bread, that it will show. But if 4 items are purchased together, it will not show me because I have put a condition of max length is equal to 3. Means only till three products which are getting purchased at a single time, that products show me. Please show me the those products which are getting purchased at a single time. So it will show me one, two, three. One product purchased, it will show me. Second, two product purchased together, it will show me. Three products are getting purchased, it will show me. But 4 products which are getting purchased together, it will not show me. Okay, you can basically customize your values. You can take 4, 5, 6, whatever value you want. Okay, I'm taking it as 3 now. Now you can see that eggs are getting purchased frequently. Okay, burgers, turkey, mineral water. Okay, so these values we got. See, mineral water and eggs. Suppose I will sort the value by descending. Sort values by which we will sort by support. Okay, now it is saying soup is getting purchased frequently. Mineral water and eggs are getting purchased frequently. Okay, mineral water and spaghetti is getting purchased multiple times together. Okay, that is what we can find by FP growth algorithm and also a priori algorithm. Okay, these two algorithms which comes under association rule learning. Okay, so this is what FP growth algorithm does. Okay, so that's all in this video. In the next video, we will discuss ensemble learning. Okay, thank you. Hello guys, welcome to the channel. So our today's topic is ensemble learning. So what is ensemble learning? Ensemble learning means combining multiple machine learning models to make one stronger model. Think it like this. One student is solving a question. Okay, then higher probability he can make mistakes. Okay, now 10 students will solve the same question. Okay, then what will happen? Majority answer is usually more accurate. Okay, so similarly, when you will make prediction by only one model, then it may get weak prediction, right? So we will basically combine multiple models to for our better prediction. So this technique is called ensemble learning. Okay, so that is what ensemble learning. This basically combines multiple machine learning models to make one stronger model. Okay, so there are some types of ensemble learning. First one is voting methods. Voting methods are techniques used in ensemble learning to combine predictions from multiple machine learning models and produce a single final prediction. Okay, so the basic idea is behind voting methods is instead of relying on one model, we make predictions from multiple models and combine them to make a better decision. Okay, so voting methods are commonly used when several models are trained on the same data set. Okay, so that is what voting methods. Okay, it will take predictions from multiple models, it will combine them and will make a perfect decision. Okay, so these are some types of voting methods: hard voting, soft voting, and average voting. We will discuss this types and voting methods in depth. I'm just giving overview of the types of ensemble learning. We will discuss one by one of its types in depth in both ways, practically and theoretically. So don't worry, I'm just giving overview of it. Okay, so second one is bagging. Bagging, the idea behind bagging is train many models in parallel and combine their results. Okay, so understand its process. Step one, create multiple random datasets from original dataset. Means you will have a original dataset and it will create multiple random datasets from that original dataset. Then second step is train one model each dataset. I have multiple random datasets from my original dataset. Now I will train one model in on each dataset. Each dataset. Okay. Now step three, take majority voting for classification problem and take average for regression problem. Okay. So the most famous bagging algorithm is random forest. Second one is itself bagging. So the most famous is random forest. Okay, its base estimator is decision trees. It creates many decision trees and then it combines them. Okay, the third one is boosting. So idea behind boosting is it trains models one after another sequentially. Each new model focuses on mistakes made by the previous models. Okay, that is what the working of boosting. Let's understand its working. So we took model one. It make predictions, but gives some wrong predictions. Okay. Then model two focuses on the wrong predictions. Then third one again focus on remaining mistakes, right? Then it will give the final prediction. Okay. So that's how boosting works. And the most popular boosting algorithm is XGBoost because it gives high accuracy and it basically handles missing value by itself. Okay, so that's all about ensemble learning and its types. We will discuss the different types of ensemble learning in the next video, how we can perform them, how we can do them practically. So we will discuss those types in the next video. So thank you. Hello guys, welcome to the channel. Today we will discuss voting methods for classification. So voting is an ensemble learning, which I have already discussed in my previous video. Voting is an ensemble learning technique where we combine predictions from multiple classification models and take a final decision based on voting. We will combine all the prediction taken from multiple classification models and then we'll make a decision based on voting. Okay, like suppose model 1 votes for class A, model 2 votes for class A, model 3 votes for class B. So you can see class A is getting more votes So the final prediction will be class A. Okay. So the idea behind this is many models together often perform better than a single model. Okay. So that is what the idea behind voting. So suppose why should we use voting? Suppose we have three different models. Okay. I have implemented. I have implemented three different models like logistic regression. From logistic regression, we are getting 85% accuracy. Decision tree accuracy, I am getting 82%. From KNN accuracy, I am getting 84%. Okay. So each model makes different mistakes, right? So when we will combine them using voting, the mistakes can be cancelled out, leading to better performance. Okay. So that's why we should use voting. Okay. For classification problem, there are two types of voting. Okay. Although it has three types, but for classification problem, there are only two types, hard voting and soft voting. And what is hard voting? In hard voting, every model votes for a class. This is also called max voting. Okay. In hard voting, every model votes for a class. The class receiving the majority votes becomes the final prediction. Suppose we want to classify an email as spam or not spam. Okay. Now first model is our logistic regression. It predicted the email is spam. Second model is our decision tree. It also predicted that it is spam. Now I have third model, KNN. It predicted not spam. So there are more votes for spam email. So spam has two votes. Not spam has one vote. So final prediction will be spam. Okay. Now second one, soft voting. Soft voting basically uses probabilities instead of direct class predictions. Okay. So each model predicts how confident am I about each class. Then probabilities are averaged. Okay. The class with the highest average probability becomes the final prediction. Suppose three models predicted cat has 80% for logistic regression. Cat predicted 80%, for dog it predicted 20%. Okay. Decision tree. It predicted cat as 60%, dog as 40%. Now third one. Third one predicted cat as 70% and dog as 30%. Now when we will calculate the average 80%, 60% and 70% upon 3, then I will get 70% for the cat and 20 plus 40 plus 30 upon 3. I will get 30% for the dog. So here you can see I am getting more average probability in cat. So final prediction will be cat. Okay. So that is what voting for classification and their types. Now we will see how we can perform this using Python practically. Okay. So let's see how we can do it. Now I will import some required library, pandas, spd, import matplotlib dot pyplot as plt because I will plot some graph Seaborn as SNS. Okay. Now, now let's take a dataset from sklearn. Make Moon's dataset. I have worked on Make Moon's dataset in our previous video also. Uh, so I will load the dataset from sklearn.datasets, import Make Moons. This is the dataset. Okay. In sklearn. So I am importing this. Okay. Now x and y is equal to I will take. I will make a I will store the data set into x and y. Let's take x and y. I will call my make moons. Suppose n samples I will take. N samples mean how many records you want to take, means how many rows you want to take. Suppose I'm taking 1,000 rows of the data set. Now, suppose I'm giving noise as 20%, 0.2. Okay. Now, now let's make a data frame. I will make a data frame. I will make three columns. Suppose x1. I will take for, I will say for x, sorry. I'm saying that give me all rows of first column, 0, first column. Then second, I'm taking x2. Now I'm saying give me all rows of my second column. Okay. Now third one, that is my output, that I will take as y. So because I stored already y as my output. Okay. So I will do shift plus enter. Now, okay, okay, I will give this, sorry, 1, because x1 has the first column, x2 has the second column, and y has the output column. Okay. Now, now let's take an variable and transfer this into a data frame. What I'm transferring into data frame? df. Okay. Now, let's check your data by checking its first three rows. So yeah, that is your first three rows of your data. This is your inputs x1 and x2, and y is your output. Okay, prediction. Okay, now let's plot a graph to see how my data is spread. Now I will take x is equal to as x1, y is equal to x2, and I will take data as data because in the data variable I have the data. Okay, and I will do, I will give hue parameter as my output, which is y, right? Now I will do plt dot show. Yeah, now look at this. This is how your data is spread out into a graph. That is, this is your first category, this is your second category, or you can say this is your first category, or you can say this is your second category. This is how your data is spread out. Now now let's divide the data set into input and output. In x input I will take input columns x1 and x2, and into y output column variable I will take y column. Okay, so let's take x input xi is equal to data dot I log. Now I'm saying that give me all rows, give me all columns, but don't give me the last column. That is my output column. Let's take y output. Yo is equal to data. Last column is your y column. That is your output column. Output column y. So divide this data set into input and output. Now I will split the data set into 80% for the training and 20% for the testing. Okay. So from sklearn dot model selection import train test split. Okay. Now I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split. I will give x and y. Test size I want as 20%, so I will give test size is equal to 0.2 and random state is equal to 42. Okay, now my data gets split into 80% for the training and 20% for the testing. Now, now let's train the model into using three different algorithms. Okay, so suppose first algorithm I will take decision tree. Okay, from sklearn dot tree import decision decision tree classifier, because this is a classification problem. I will import this. Suppose I will take second one as from, I will take suppose support vector machine. Okay, sklearn dot svm import svc support vector classifier. Third one, suppose I will take naive bias. Naive bias Gaussian NB I will take. Okay, from sklearn dot sklearn dot naive bias import, I will take Gaussian NB. Gaussian NB. Okay, shift plus enter. Now let's build our first model using decision tree classifier. So suppose I will take an object to call my decision tree classifier as dt. Okay, I will fit my training data set into x train comma y train. Okay, and I will check the accuracy also for both training and testing, for both data set training and testing. X test. Okay, sorry, train. First I'm taking training data 100 comma. Now second one I will check for testing. Okay, test test where I will take white. Now now here you can see for training data set I am getting 100% accuracy, and for testing data set I am getting 96% accuracy. Okay, so now let's check for the second one, that is my SVM algorithm. Okay, now I will suppose give an object SV and I will call SVC support vector classifier SVC. Here I will give SV, here I will give SV, and here also I will give SV. Now in support vector machine I am getting 90% accuracy for training data and 90% accuracy for testing data. Okay, now third one is your naive bias Gaussian NB. Now let's take an object GNB. Okay, Gaussian NB. Okay, I will give GNB here, GNB, here also GNB, here also GNB. Now, for Gaussian NB, nearby Gaussian NB algorithm, I am getting 86% accuracy for training data and 87% accuracy for testing data. So we have built three different models using three different algorithms, right? First one is your decision tree classifier, second one support vector classifier, and third one is your Gaussian NB, naive Bayes Gaussian NB algorithm. Now, what I will do is I will combine these three models using voting classifier. Okay, so how we can do it? From sklearn dot ensemble import voting classifier. Voting classifier. Okay, I've imported this. Now let's make a list of these three columns. Okay, list is equal to first one is your DT, right? I will take DT. Suppose I will take DT1, that is decision tree classifier. Okay, I will take this. Now second one is your SVM. Now let's take SV1, call your SVC. Okay, now third one is your GNB. Let's take GNB1 and call your Gaussian NB. Okay, now I have made the list. DT1 as decision tree classifier, SV1 as SVC, and Gaussian NB, GNB1 as Gaussian NB. Okay, now, now let's create an object BC and I will call voting classifier, and I will give the list here, LI. Okay, I have given the list. Now, now let's check the accuracy of, sorry, I will first fit the training model into VC and Y train into 100. Okay, spelling mistake. X train comma Y train into 100. Sorry, not 100. I'm not checking accuracy. Sorry for that. Yeah. So, so here you can see it has combined all three algorithms together. Decision tree classifier, SVC, and support vector classifier and Gaussian NB algorithm. Okay, under voting classifier. Okay, now let's check accuracy for that. VC.score. I will simply copy this. I will give VC. So we are getting accuracy for training data as 97 and testing data for 97.625 for training and 97 for training testing. Okay, 97.625 for training data set I'm getting the accuracy, and 97.0 accuracy for testing data. Okay, now let's make a table to to compare the prediction between these four algorithms: decision tree classifier, SVC, and Gaussian NB. This is how voting classifier works. Voting method for classification. This is how it works. Okay, it has combined all three algorithms into under voting classifier. Okay, and giving predictions by combining them. Okay, now let's take prediction, and I will make a list dt1, dt1. I will take dt dot predict x test. Okay, second one svm, svm. I will take sv dot predict x test. Now third one is your gnb. Let's take gnb, gnb dot predict x test. Now last one is your voting classifier, where I have combined all these three algorithms into one voting classifier. VC, VC dot predict X test. Okay. Now I will convert this into a data frame. I will pass PRD here. Now you can compare the predictions between all those four algorithms. Okay. Now first one you can check all the all algorithms give one as their prediction, zero for the second, zero for the third, zero for the fourth. Now here you can see a difference. As you can see, GNB was giving me GNB is giving me 86% accuracy for the training and 87% for the testing. It is a quite low accuracy, right? So here you can see the difference. DT has predicted 0, SVM has predicted 0, but GNB has predicted 1. Again, voting classifier predicted 0. So here you can see the difference. Okay, and remaining all you can see the same it all predicted the output. Okay, so this is how voting method works for classification problem. Okay, here you can see we have combined voting uh, all these three algorithms into voting classifier and then predicted basically fitted the data and checked the accuracy of voting classifier. We we got 97%, 97.625% accuracy for training, 97% for testing data. Okay, so this is how voting classifier works. Okay, so in the next video, we will discuss how voting method is used for regression problem. Okay, so that's all. Thank you. Hello guys, welcome to the channel. Our today's topic is voting method for regression. So what is voting regression? Voting regression is an ensemble learning technique where we combine predictions from multiple regression models and take their average to get the final prediction. What it means? Suppose you want to predict a house price. So you ask from three experts. Expert one said 50 lakh. Expert two said 55 lakh. And expert three said 52 lakh. Okay. Now, instead of trusting only one expert, you take the average. You added these three and divided by three, and you got the average. You got 52.33 lakh. Okay. So your final prediction is 52.33 lakh. Exactly, this is exactly how voting regression works. Okay. So now let's understand how voting regression works. Step one, you will train multiple regression models. For example, you train your model on linear regression, decision tree regression, and random forest regression. On these three algorithms, you trained your model. Okay, now Step 2 will be, suppose a new house came. Okay, new house came. So linear regression predicted 40, anything like value 40. Decision tree predicted 50 lakh. Random forest predicted 45 lakh for a house price. Okay. Linear regression predicted 40 lakh. Decision tree predicted 50 lakh. Random forest predicted 45 lakhs. Okay. Now, step 3, calculate the average. Prediction, your to last prediction will be the average. 40 plus 50 plus 45 upon 3. You got 45. So the final prediction will be your 45 lakhs. Okay. So this is how uh, voting regression works. Okay. So now let's see how we can perform voting regression practically using Python. Okay. So let's see how we can do it. So this is our salary data. I will show you how. Basically, we have worked with salary.csv previously also, but I will show you how it is looking. I will import pandas libraries, and then I will load my data into a data variable csv. I will right click. I will right click, copy path. I will paste it here. Now let's check my data is loaded or not by checking its first rows. Now Now it's a salary data set where we are predicting salary based on years of experience. Years of experience, like you have 1.1, 10 years salary is 39,343. So this is what this data set is saying. Okay. Now let's divide this data set into input and output. Data.ilog. Give me all rows and all columns, but don't give me the minus one. It means last column. That is my output column. I will take my output column into y variable as salary. Okay. Now, now I will split the data set into 80% for the training and 20% for the testing. So I will import train test split, model selection, import train test split. Scalar dot model selection, train test split. Now I will take my all four variables x train, x test, y train, and y test. Okay, I will call my train test split x and y. I will give my test size equal to 0.2 and random split as 42. Okay, now my data gets splitted. Now, now what I will do, I will train the model into on three different algorithms of linear regression. Okay, for this data set. Okay, so let's take first model as your linear regression itself. Scalar dot linear model, import linear regression. Okay, now second one, let's take decision tree regression from a scalar dot tree, import decision tree regression. Okay, now third one, let's take neighbors, k nearest neighbor I will take. Okay, let's take k nearest neighbors, import So what I will do, I will train my model on these three algorithms for this data set. Okay, so let's import all shift plus tab, shift plus enter. Now let's train my first model. Let's make an object LR to call my linear regression. Now fit your training data into it. X train, comma Y train. Okay. Now let's check its accuracy also. For training data and testing data both, into 100. And let's take the second for testing data, Y test into 100. Now from linear regression, we are getting accuracy for training data set 97% and for testing data set 89%. Okay. So this is our first model we have built. Now let's make the second model using decision tree. Let's take DT. I will call my decision tree regression. Okay. Now I will do DT dot fit. I will do DT dot export, DT dot export, DT dot export. Now from decision tree regressor, we are getting 99% accuracy for training and 93% accuracy for testing. Now let's make the third model. Third model I will make for k nearest neighbors. Okay, let's say kn. I will I will call k nearest neighbor, k neighbors regression. Sorry, I will do kn. I will replace this also by kn. So from k nearest neighbors, K neighbors regressor, I'm getting 97% accuracy for training and 89% for the testing. Okay. Now it is a uh, kind of overfitting also, but like in this video, we are not going to focus on that. We our motive is to learn how voting regression works. Okay. So what I will do now is I will import voting regressor from sklearn dot ensemble import voting regression. Okay. Now I will create a list first for uh, all three algorithms. Okay. Now I will make a list. First is your LR, that is your linear regression. Sorry, I will take as linear regression. Okay. Now the second one is your DT, decision tree. I will take DT1. I will take DT1 and I will call decision tree regression. Now, the third one is your K nearest neighbor. Let's take KN1, KN1, and I will call K nearest neighbor, K, K neighbors regression. Now, shift plus enter. Now, Now let's create an object to call voting regression. BR, I will call voting regression. In voting regression, I will pass my list li. Okay, that is my list. Now I will fit my training data. X train, comma, Y train. Okay. Now you can see it has combined all the algorithms into one under voting regression. Okay. Now let's check the accuracy. I will simply copy. I will replace this by vr.score. So we are getting 99% accuracy for training and 91% accuracy for testing. So it is a kind of overfitting whether I am getting more accuracy for training. Okay. So I will not focus on this. Our motive is to like understand how voting regression works. So this is how voting regression combines all the algorithms into one under voting regression. So now let's understand how voting regression actually predicts the continuous values because we are dealing with a regression problem. So we will predict the regular values. Okay. So I will create a table to show you how it is taking the average value from by calculate. It is basically predicting the average value by calculating by taking all the predicted values from k nearest neighbors, decision tree regression, linear regression, and dividing them by three because we have total three algorithms. Okay. Now let's take LR1 as your LR as your first column. LR dot predict what predict X test. Okay. Second one, second column I will take DT. DT. Now DT dot predict X test. Third one, I'm taking KN. KN dot predict X test. Okay. Now I have prepared the list. Now I will convert this into a data frame. PD dot data frame. I will pass DF. Okay. Now you can see how it predicted the values. Okay. LR predicted this. DT predicted this. Okay. So I will take VR also. VR VR dot predict X test. Now you can see. So LR predicted this, DT predicted this, KN predicted this, and VR predicted this. So this is the average of all these three values. Now let's suppose I will show you. Control C, Control V. I will add this. Control C, Control V, and I will take this also plus Control V, and I will divide by it by 3. Okay. Now let's check. Now you can see we are getting the same value as we are predicted. So it basically giving you the average value. Okay. Voting regression. Average value by taking all the values from these three and giving you the average value. Okay. So this is how voting regression works. If you will calculate this also, you will add all these three and divide by three to this to the addition of these three values, you will get this value. So this is how voting regression works. Okay, so that's all in this video. In the next video, we will discuss bagging for classification. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss bagging for classification. So bagging is an ensemble learning technique used to improve the performance of a classification models. So the main idea behind bagging for classification is instead of training one classifier, train multiple classifiers on different subsets of data and combine their predictions to help reducing overfitting and improving the accuracy of the model. What it means, suppose you have a data set. It will divide the data set into multiple parts, okay, from the original data set. And then suppose I have chosen my base model as suppose support vector machine, support vector classifier for classification problem. So it will suppose I have chosen n estimate is equal to 5. Then it will divide my data set into 5 parts. And then suppose I have chosen support vector classifier. So it will apply support vector classifier one by one to those 5 divided data sets. Okay. So this is how bagging for classification works. Okay. So let's understand more clearly from this example how bagging works for classification. Suppose you have 1,000 training records, okay, 1,000 rows. So create bootstrap samples. Randomly, it will randomly create multiple data sets. Example, data 1, 1,000 rows, data 2, again 1,000 rows, data 3,000 rows, and data 4,000 rows. Okay, it will basically split the dataset. Each dataset is created by sampling with replacement. Suppose what is what it means. Each dataset is created by sampling with replacement. Suppose you have original dataset as your A, B, C, D, E. So how it will basically create the sampling with replacement. Suppose it will divide first dataset as A, B, C, C, D. There is no E in that data. Now second data it has divided like B, C, D, double E. Okay, there is no A in the second data. Okay, so this is how it replaces. This is how it created the different data sets by sampling with replacement. Okay, so now step two. Train multiple classifiers. Suppose you have decision tree as your base model. So dataset one, tree one, dataset two, tree two, dataset three, tree three. This is how it will train the model on each dataset. Okay. Now we have multiple classifiers. Okay. Now what it will do, make predictions. Suppose a new customer arrives. Each tree will predict. Suppose tree 1 predicted yes, tree 2 predicted no, tree 3 predicted yes, tree 4 again predicted yes, tree 5 predicted no. So majority voting when you will count, then it yes has 3, no has 2. So then your final prediction will be yes because I have the majority count yes as 3. Okay. So this is called majority voting. This is how bagging for classification works. Okay. Now, so the most famous basically algorithm is random forest for bagging. It is called random forest and bagging because suppose the most famous example is of bagging is random forest. Okay, so it creates bootstrap samples, trains many decision trees. Always remember that the base model of random forest will be always decision tree. Okay, decision tree. So it will train many decision trees, use majority for voting for classification, what I have explained here. Okay, now, and lastly, you can say Bagging plus decision tree is equal to your random forest. Okay. So this is how random forest works. We will see how bagging classifier and random forest classifier works. Okay, practically. So let's see some advantage of bagging. First is reduces overfitting, especially uses useful for decision trees. Okay, improves accuracy, obviously, reduces variance, predictions becomes more stable because it is reducing overfitting also. Okay, we have already discussed Riz and Lasso algorithm for uh, decreasing the overfitting problem. Okay, so from this bagging also we can reduce overfitting, reduces variance also. Okay, works well on large data sets, can handle large amounts of data effectively. Okay, so now let's understand how we can perform bagging for classification practically. Okay, by both bagging classifier and random forest classifier. Let's see how we can do it. So first I will import some required libraries. Import pandas as ed and import matplotlib. I will plot some graph dot pyplot as plt. Import seaborn as SNS. I will load dataset from again make moon dataset from our sklearn. Okay, so that is a very good dataset for classification problem. Okay, so I will again in this video import that datasets, import make moons. Okay, now I will store this into X and Y. I will call my make moons. Okay, I will take n samples. N samples mean total number of record. I will take suppose 1000. Okay. I will add some noise also. Let's add some noise 2%, 0.2. Okay. Now, sorry, that is a spelling mistake. Noise. Now, what I will do, I will make a data frame in which I will take all input columns. There are two total input columns and one obviously one output column in this data set. We have already seen in our previous video. There are total three columns in this data set. Okay. Now I will take suppose df. Our first column will I will take suppose x1. So x1 has all input columns. I will go for x and I will say give me all rows of first column, 0. 0 means first column. Give me all first column and all rows of first column. Now second, let's take x2. Now give me the second row as well. The second column as well, sorry. Second column as well with all rows. I will give 1, 1 for my second row. And in y column, I will take the output. That is my y. Okay. Now I will store this into data variable by creating a data frame. I will pass my df. Now let's check your data. So yeah, this is how your data is looking. X1, X2 your input, Y is your output. X1, X2 is your input, Y is your output. Okay. Now let's plot a graph to see how my data is looking. Sorry, not pair plot, scatter plot. Let's take X is equal to X1. x1. Let's take y is equal to x2, and I will give data as my data. I will give comma here, and I will give u parameter as my y, and I will say plt dot show. So this is how my data is looking. Okay, this is your one category, and this is your second category. Okay, blue one is your one category, and orange one is your second category. Okay, now now uh, I will take my data set, input data set into xi, x input data dot ilog I will use. Now I will take all rows, all columns, but I will not take the last column -1. That is my output column. I will take my output column into y, data y. So xi has the input columns, and y/o has output column. Okay. Now I will split the data set into 20% for the training and sorry, 80% for the training, 20% for the testing. Okay. From sklearn dot model selection, import train test split. Train test split. Now I will now I will take all variables x train, x test, y train, y test. Okay, is equal to, I will call my train test split. Now, what are my variables? Xi and yo, y/o, and I will take test size as 0.2. I want 20% as my testing data, and I will give random state is equal to 42. Okay, I have taken 0 by mistake. Yeah, my data gets split into 80% for the training and 20% for the testing. Okay, now I will import first bagging classifier from sklearn dot ensemble, import bagging, okay, sklearn dot ensemble bagging classifier. Second one I will import from sklearn dot ensemble, import, I will import random classifier. I will use random forest also. So I will import random forest classifier. Now what you want to give for random forest classifier, your base model will be decision tree. Okay. Bagging classifier, what which model you want to take as your base model? Suppose I am taking support vector classifier. Okay. Support vector machine from sklearn dot. I will go for SVM import SVC. SVC. Okay. Now, now let's create an object to call bagging classifier. Bagging classifier. Okay. Now, bagging classifier, I will take estimator. Estimator means I will take SVC. Estimator means I've already explained what base model you want to take. I am taking SVC, support vector classifier, as my base model. Okay. Now, I will give an estimator. N estimators is equal to, I will give suppose 20. What I am saying here? I am saying here estimator as SVC. I am saying that take base model as support vector classifier and n estimator is equal to 20 means divide my data set into 20 parts, not 20 parts, 20 different types. Divide my data set 20 times into different types and use my support vector classifier on all those 20 divided data sets, different type of data sets. Use my SVC for all those 20 type of data sets. Okay, what I'm saying here. Now I will fit my model. Bz.fit x train, comma y train. Okay, so training data gets fitted into my model. Let's check accuracy of my model. Bg.score. I will take, I will see my accuracy for both x train and y train into 100, comma. I will take X test also to check my data is getting overfitted or not, or it is working perfectly. Test. Now, so yeah, a little bit difference in my training data and testing data, but yeah, 96.5 for training and 95% for the testing. Okay, so this is what accuracy I am getting from my bagging classifier by choosing my support vector machine as my base model. Let's check on random forest classifier. Suppose I will take an object to call my random forest classifier. Okay. Now in this, you don't need to take estimator. Okay, because it it is using decision tree as your base model. Okay. Now if I will show you, these are some its hyperparameters. Okay. So these are some hyperparameters of random classifier. Estimator I will give suppose an estimator. Suppose I am giving this time 30. Okay. An estimator I have explained what I am doing by an estimator by giving an estimators. Okay. I've already explained. Now fit. Let's copy this. Now fit your model, your training data into this. I will replace this by RF. Okay. It gets trained. Now let's check the accuracy on my random forest. Okay. Random forest. X test. Sorry, not here. Here I don't need to change anything. I will change this RF. Now you can say it is a case of overfitting, right? Because you are getting 100% accuracy for your training and 93.5 for testing, right? So what you can do here, you can you can limit your max depth because it is taking decision tree as base model, so you can limit your max depth. You can limit your max depth. Suppose I am taking 4. So let's check. Yeah, it is still a case of overfitting. 95% accuracy for X train and 92 for X test. Let's try 5. Okay. So it is getting closer, but also there is a difference of 2%. So yeah, 96% for training and 94% for the testing. So this is how you can check on different numbers of max depth. Okay, so it should match the accuracy, both accuracy for training and testing for both. So we saw in this video how we can use bagging classifier, how we can choose my base model, what is the meaning of an estimators, how we can perform bagging classifier, random forest classifier for classification problem, how we can use bagging for classification. That's what we have learned in this video. In the next video, we will discuss how we can use begging for regression problem. Okay, so that's all in this video. Thank you. Hello guys, welcome to the channel. So in today's video, we will discuss begging for regression. In our previous video, we have discussed how we can use begging for classification problem. Now in this video, we will discuss begging for regression. So what is begging for regression? Begging is an ensemble learning technique where multiple regression models are trained on different random subsets of the training data and their predictions are combined to get a final prediction. What it means? The idea behind begging for regression is also same as begging for classification. So in the same way, begging will create number of samples of your main data set, and then suppose I have chosen my base model as linear regression. So that linear regression model will be trained on all the samples of the data. Okay, so that's how begging for regression works. Okay, so the main goal of begging is reducing overfitting, reducing variance, improving prediction stability, and increase accuracy. Okay, so the goal of begging is also same as the begging of classification in regression. Also, okay. So what is the let's understand working of begging for it. Step one, same as classification. You have a data set. It will create samples of your data set. Suppose I have chosen n estimator is equal to 5. Then it will create 5 samples from your main data set. Then step two, I have chosen 5 estimator and it created 5 samples of my data set. And then suppose I have chosen linear regression as my model. So it will train my linear regression model on each sample, on 5 samples. Okay. All the 5 samples it will train my model. Okay. Now step three. Now a new input came for you. So all the models will give their predictions. Okay, suppose house size is 1500 square feet and you are trying to predict the price of the house. So suppose I have chosen decision tree. So suppose decision tree one chosen uh predicted 50 lakhs. Tree 2 predicted 55 lakhs. Tree 3 predicted 52 lakhs. Again, decision tree 4 predicted 53 lakhs. Model 5 predicted 54 lakhs. Now, step 4. Now, take all the predictions and calculate their average. Okay. This is how we calculate the average. Okay. Add all the samples upon total number of samples. Okay. Now, we got the final prediction. That is my average 52.8 lakhs. That is my final prediction. That is my price of the house. So that is how begging for regression works. Okay. Let's understand how we can perform it practically. Okay. So this is my data set. I have used this data set previously in my previous video also. So here in this data set, I'm analyzing salary of employees based on their years of experience. Okay, so let's understand how we can use begging for regression on this data set. Okay, let's import pandas as ed, load your data set, ed.read/csv. Now right click, copy path. I will paste it here. I will check my data dot head. My data is loaded or not by checking its first 3 rows. So yeah, my data gets loaded and these are my first 3 rows. Now let's take input column into X and output column into Y. Okay. Simply data.ilog. Give me all rows, give me all column, but don't give me the last column, that is my output column. Although I have only 2 columns. So my data I'm taking output in Y. So I will give salary. Okay. Now, now let's split the data set into 80% for the training and 20% for the testing. Okay. So from sklearn dot model selection, import train test split, train test split. Now I will take my all four variables x train, x test, y train, and y test is equal to, I will call my train test split. Now I will give my x and y variables. I will give test size is equal to 0.2. I want 20% as my testing data. Random state I will give 42. Now my data gets split into training and 80% for the training and 20% for the testing. Now let's import bagging regression from sklearn dot sklearn dot ensemble import bagging regression because we are dealing with the regression problem. So I've imported bagging regression. Now I will import random forest regressor also from sklearn dot ensemble import random forest regression. Now what which model you want to give your which model you want to give to the bagging regressor as your base model. Suppose I am taking linear regression, sorry, linear regression. So from sklearn dot linear model, I am taking linear regression. Okay. Now let's make an object bg. Call your bagging regressor. Okay. Now your base model is your linear regression. So give linear regression. Now, what estimators you want to give means how many samples, in how many sample it should divide your data set. Suppose I'm taking 40. Okay. Now I will fit my training data into it. bg.fit x train, comma y train. Okay. It gets fitted. Now let's check accuracy on both training and testing. Y test into 100. I will simply copy this. Okay. I will pass X test here and sorry, I have done a mistake. Train and Y test. Now 97 for the training and 89% for the testing. So you can see it is a problem of overfitting. There are many ways I have already explained to fix overfitting. You can change your base model also. You can check, you can take another model for the as your base model for bagging regression. Okay, so I am not like changing my model now. So now next I will create an object for random forest classifier, random forest regressor, sorry. And here it will basically, its base model is always the decision tree. Okay, so suppose I'm taking an estimator. I'm taking suppose 50. 50 times divide my do sampling of my main data set. Okay. Now RF, I will simply copy this. I'll change this to RF. Now, now let's check accuracy on my random forest regressor RF dot and RF dot. Okay. So it is also giving it is also a case of overfitting. Let's limit its max depth. Suppose I will give 5. Let's see. No, no change. Let's take 4. Little bit change. 95. There are 4% of difference. Let's check 3. No, not working on 3. Let's check 6. So yeah, it is giving it is a difference of 4% accuracy. You can check on different numbers of max depth. Okay. So we have discussed how we can use begging for regression by both way begging regressor and by creating by giving a base model to my begging regressor and by random forest regression. So this is how begging for regression works. So that's all in this video. In the next video, we will discuss boosting. Okay. Thank you. Hello guys, welcome to the channel. So our today's topic is boosting for classification and regression. Okay. So first understand what is boosting. So boosting is an ensemble learning technique where models are trained one after another sequentially. Okay, each new model tries to correct the mistakes made by the previous model. Okay, let's understand by this basic example. Suppose a teacher gives a test to students. Now, first teacher checks the paper and finds some weak students who didn't perform well, okay, in the test. So now second teacher came. It will focus more on those weak students, right? So and then third teacher came and he will focus on the students who are still making mistakes. Okay, so by this, what will happen? At the end, the combined result becomes much better. So first teacher, a teacher giving test to students. First teacher finds some weak students. Then second teacher focuses on weak students. Then third teacher came and he also tried to like focus on those students who are still making mistakes. So at the end, the result will become much better from the previous one. Okay. Okay. So this is exactly how boosting works. Now let's understand this. So step one, how boosting works. Training model one. Some points are classified correctly and some incorrectly. What is analyzed by training model? Training model one, sorry. Step two, it increased the focus on incorrectly classified points. Incorrectly classified points given by the training model one, which will be handled by training model two. Training model three, it will again identify some mistakes. So at the end, we will combine all models. Okay. And then our final prediction will become obviously become it will become strong, right? So boosting for classification. Okay. Obviously it will be used when our target variable will be categorical, like yes, no, true, false, cat, dog, cow, or something like that. For example, spam detection, disease prediction, fraud detection, sentiment analysis, right? So target, suppose I have taken example, email. First email, spam, yes. Email two, no. So boosting train multiple weak classifiers here and combine them into a strong classifier. Okay. Now, how boosting for regression works? Suppose it will obviously use when target variable is continuous for regression problem. For example, house price prediction, salary prediction, stock price prediction. Okay. Now let's take an example. Your actual house price is 50 lakh. You know that. Okay. So model 1 predicted 35 lakhs. So there is an error of 5 lakh, right? So model 2 will learn this error and tries to reduce it. Now suppose it reduced 5 lakh to 3 lakh, but still we have that 3 lakh error. Now model 3, it will further reduce the remaining error, 3 lakh error. Okay. Then final prediction will become very close to 50 lakh. So this is how boosting for regression works. Okay. So most famous algorithm is boosting algorithm is XGBoost. Okay, so its full form is extreme gradient boosting. So this is an advanced and optimized version of gradient boosting. Okay, it is one of the most popular algorithms in machine learning, and like in competition and industry, it is used. So these are some features of XGBoost. Regularization. We have already discussed this topic by Ridge and Lasso algorithms. It prevents overfitting. Okay, so it is prevented by itself, executes faster training. Okay. Third, it will handle missing values on by itself. Okay. Tuning removes unnecessary branches. Okay, and high accuracy. Okay. So often perform better than many ML algorithms. Remember, many ML algorithms, not every ML algorithms. Okay, it will perform better than many ML algorithms. Okay. So this is what the theoretical part of boosting and XGBoost. Now let's check how we can perform XGBoost practically. Okay. So for classification problem, I have this data set. I have used this data set previously also. So on the basis of CGP and academic performance, we are trying to analyze that a student will be placed or not. Okay. A student will get placement or not. And second is my years of X on the basis of years of experience. This dataset also I have used in my many videos. So years of experience, on the basis of years of experience, we are trying to analyze the salary of an employee, right? So now let's check how we can perform it practically. So I will first give a markdown here, classification. First I will check by classification, how we can perform attributes. Okay. Now first I will import pandas. Now I will import my data. This is my data for classification. I will right click, copy path. I will paste it here. Now I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded. And these are my first three rows. Now I will take all input columns into X data.ilog. I'm saying give me all rows and give me all columns, but don't give me the last column. Okay, last column is my output column. I will take this into Y. Data placement. Placement. Now my data gets splitted into input and output. Now I will split the data set into 80% for the training and 20% for the testing. Okay. Now from sklearn dot model selection import train test split. Train test split. Okay. Now I will take my all four variables x train, x test, y train y test is equal to, I will call my train test split. Now I will give my variables x and y. I will give my test size as 0.2 as I want 20%. Random state I will give 42. Now my data gets splitted into 80% for the training and 20% for the testing. Now I will import XGBoost. If you have not XGBoost, then you can simply download it. Just copy this, open your CMD command prompt. Just open this, just paste this, enter. So you can see requirement already satisfied. Means I have already installed XGBoost in my system. So you can download like this XGBoost in your system. Now I will import XGBoost. Import XGBoost. Sorry, boost as XGB. Suppose I will import XGBoost as XGB. Now let's make an object model is equal to, now call your XGB dot, now call your XGB classifier. Yeah, I need to XGB classifier. Now if you will click shift plus tab here, you can see many parameters here. You can customize these parameters and estimators, how many times you want to break your, like how many times you need the tree, how many times you want the model to train. Okay, max step, max leaves. Okay, these are the things you can customize. Now let's check by taking n estimators. N estimators is equal to, let's take 100, and max depth, let's take 3. Okay, now fit your model by your training data. X train, Y train. Okay, now it gets fitted. Now let's check the accuracy of the model. Model data score X test comma Y test into 100. So we are achieving 83% accuracy, not a good accuracy, but yeah, we are getting 83% accuracy. So you can like customize your parameters here to increase the accuracy according to your data. Okay. So now let's check how we can use XGBoost for regression. Regression. Sorry, I will give a markdown here. Now, so I will import my data. Data2 is equal to pd.read slash csv. This is my salary.csv, and I will copy path. I will paste it here. I will check my data is loaded or not. So yeah, my data gets loaded, and these are my first three rows. Now let's make another object model2 is equal to, call your XGB dot. This time I need XGB regressor. Okay, so here you can see XGB regressor. Okay, now let's I will give the same parameters here. Suppose I am giving this time 50. Okay, now let's fit your training model. Okay, so first I need to take input columns into this. I need to data 2 dot sorry data 2 dot ilog, take all columns, all rows, but don't give me the last column. Now y2 is equal to data. I'm taking salary in this. Salary. Now let's take your all four variables x2 train, x2 sorry data 2, x2 test, y2 train, and y2 test is equal to call your train test split. I have already imported for classification problem. Now this time you need to give x2 and y2 because these are the variables in which I have taken input and output column. Okay. Now test size I am taking range 0.2, random state 42. Now let's make an object model 2, call your XGB dot XGB regressor. XGB regressor. Now, now I will give you parameters here. Suppose this time I'm taking 50. Now, model 2 dot fit your x2 train and y2 train. Okay. Now it gets fitted. Now let's check the accuracy. Model 2 dot score x2 test comma y2 test into 100. So we are achieving 89% accuracy. Okay, you can change this, you can try this 100. Okay, so it is not improving much more. 5, let's take. So yeah, it decreased the accuracy. So yeah, so we are getting almost 90% accuracy for my regression by XGBoost. Okay, so this is how XGBoost works for regression and classification both. Okay, so that's all in this video. We learned what is boosting and how we can perform XGBoost for classification and regression problems. So that's all in this video. Thank you.